So you'll want to learn PHP, and rightfully so, because other than JavaScript, PHP is the most used language on the web. The vast majority of websites you visit are built with PHP. It's fast, but more importantly for you and me, it's easy to pick up and learn to start writing web applications. Hi, my name is Jeremy McPeak, and this is the course you want to take to learn PHP. Now, I assume nothing from you. We will start from the very beginning, and I'll show you the tools that you'll need to get started learning and writing PHP. And after you have everything installed on your computer, I'll start walking you through the fundamentals of the language. You'll learn about variables and syntax, and how to make your applications more intelligent by making decisions from within your code. We'll talk about arrays and looping over those arrays, and you'll also learn how to write your own functions and how PHP treats the variables both inside and outside of those functions. But there's so much more to PHP than just these simple constructs. You'll learn how to get and handle user input from both HTTP GET and POST requests, and you'll also learn how to persist that data using sessions. But if you're like me, you'll learn more by doing than by watching a video. So we'll then start building a web-based glossary application. I'll show you how you can organize your project using controllers and views, read from and write to files, as well as how to build a simple authentication system. You'll then learn a little bit about MySQL, and we'll adapt our project to store and read data from MySQL instead of physical files on the file system. Now, we have a ton of work ahead of us, so when you're ready, cue up the next video and we will get started. The very first thing that you need to do is set up your environment for PHP development. Now, PHP runs on the server. It does not run in the browser, and that is a very important distinction because we use completely different tools for client-side development and for what we call server-side development. PHP is a server-side technology, just like Ruby and ASP.NET and several other technologies. So what we essentially want to do is set up our computer to be a web server, because that's how this whole thing works. We make a request to a web server, the web server executes the PHP, and then it returns the resulting HTML. And the name of PHP, which is PHP Hypertext Preprocessor, that's very descriptive as to what PHP does. It essentially generates HTML. So when it comes to setting up your environment, the very first thing you need is PHP. Now, let me say this. We're going to go over the things that you typically need for PHP development, but don't install anything yet. We are going to install a tool that's going to give us everything that we need and configure it how we need it. Because the thing about PHP is that you have to install different pieces of software. You also need to configure them however you need to configure them. And we're just not going to do that. If there's a tool out there that will get us up and running very quickly, then that's what we are going to do. We are programmers after all. We are going to be lazy. Now, that's not to say that whenever you get more experience and you want to tailor your environment to your specific needs, then feel free to install the tools individually and configure them how you want. But for this course, we're going to use a tool to simplify everything. So the first thing that you need is PHP. Now, PHP is both a language as well as a runtime. If you're not familiar with the term runtime, it's basically just a program that runs and it executes code. So whenever we write PHP, we can't really do anything with that PHP code. We need a runtime that understands PHP in order to execute it, and that's what the PHP runtime is. So if you go to php.net, you are going to be able to download and install PHP. You can also get the source code and compile it for your own personal version of PHP. There are some developers who do that because they might need some extra tooling or functionality that doesn't come with the default PHP package. So later on down the road, that might be something that you do. So you can download and install PHP. There's also the documentation at php.net. So this is a site that you will probably frequent because of the documentation. So that's the first thing that you would need. The second thing is a web server, because PHP by itself isn't going to handle any web requests. You need a web server to do that. And there are many web server solutions available, and many of them work with PHP, but the de facto standard is the Apache HTTP web server. The website is apache.org, and if you go to projects, you're going to see a ton of projects here, but the one that Apache is really known for is the HTTP server. So if you were downloading and installing these things individually, that's what you would want to install. Once again, we're not going to do that. So you need PHP and you need a web server. Those are the two absolute fundamental things that you need for PHP development. The third is not as important, but you would be hard-pressed to write really any useful application without it, and that is a database. And when it comes to PHP, the MySQL or the MySQL database is the database that is used. Out of the box, PHP supports many database solutions, and you can use many database solutions, but if you need some special functionality, then you might have to compile your own version of PHP. But MySQL support is built in, and if you were installing everything, this is something else that you would want to install. However, when it comes to beginners, or whenever you need an environment very quickly, there are some solutions available that just makes your life a whole lot easier, because it gives you everything that you need, it configures everything, and you can get up and running just like that. So the first thing is MAMP. It stands for Mac Apache MySQL PHP, or at least that's what it used to stand for, because that is what MAMP was. It was a solution for Macintosh operating systems to give you Apache, MySQL, and PHP. MAMP is now both Windows and Mac, and this is what I typically go to whenever I need a quick PHP development environment, because it gives you everything, it configures everything. And in this course, this is the tool that I use, and if you use Windows or Mac OS, then I encourage you to use MAMP. The installation is very straightforward. You have two versions, but really whenever you download the Pro version. Now the Pro version is not free. You do have to pay for the Pro version. However, there is a free trial. But whenever you install MAMP, you get to choose. Do you want to use that trial, or do you just want regular MAMP? And regular MAMP is going to be just fine. So download it, install it, and you will be good to go. And we will go over MAMP here in a few moments. So this is the time that you need to install something. This is what you want. Now, if you're on Linux, then MAMP isn't going to work for you. Instead, there is a tool called XAMPP. And XAMPP also has packages for Windows and Mac OS. So this is an alternative, but notice that there is no MySQL. It tells you up here what this is. It's Apache MariaDB, which I have to admit I have no idea what MariaDB is, and PHP and Perl. So this is a solution, especially if you're on Linux, but if you're on Windows or Mac, then you will probably want to use MAMP. And once again, MAMP is what I am going to be using in this course. Now, I should mention that if you are on Mac OS, then you already have PHP installed, and you might know that. Somebody might have told you, hey, you have PHP, and that is true. However, if you go to the console, write php-v, you're going to see that you have PHP 5. So the version that comes with Mac OS is always going to be lesser than what is available online. And so while yes, you could technically use this, we are not going to do that. And when it comes to development, you typically don't want to either. You want to use the latest and greatest. So let me pull up MAMP. One of the nice things about MAMP is that it installs everything for you, but it doesn't turn on the different services until you start MAMP. And this is very useful if you don't have a dedicated development machine or a dedicated virtual machine for development, because these are services that would normally run in the background. They're consuming resources on your computer. And with MAMP, it will start those services whenever you start up MAMP, and it will turn those services off whenever you close MAMP. So that is a very nice feature. Let's go to Preferences, and you're going to see the start-stop settings. Now, by default, both of those are checked, and if you want to uncheck them, feel free. That's fine. It doesn't really matter to me. But I like to have those start and stop whenever I start and stop MAMP. So when it comes to ports, these are the ports for the different services, like Apache. The default HTTP port is port 80. So whenever we run our application, we would have a local host and then port 8888. And in fact, we will pull up the MAMP page. Well, that's a modal. We'll do that here in a minute. And you can also set the other ports here. Now, when it comes to the PHP tab, we have two choices. We can use 7.0 or 7.1.5. We, of course, want the latest and greatest, so that is what we're going to choose. If you wanted to turn on caching, you could do that, but I'm going to leave that off. And then comes the web server. Now, this is where we can set what's called the document root. This is a very important directory because this is where we put all of our files that are going to be served by the web server. So all of our JavaScript, our CSS, images, even most of our PHP files, any HTML files, we would want to put them inside of this document root. And for Windows, that defaults to the htdocs wherever MAMP was installed, and the default is just at the root. So make note of this because we're going to be spending a lot of time in that directory. And then finally the About. So let's close that out. And then let's click on the Open Start page because this is going to give us a lot of useful information. Now, notice up here in the URL, we have localhost, and then 8888. That is the port that we were using. If we change that to port 80 inside of our configuration, then we could omit that port. But when it comes to convention, we typically have a port for development purposes. Now, over here on the left-hand side, it gives us the information for our MySQL database server. So whenever we need to connect to that database, we have all of that information there. There's a tool called PHP which is a very useful tool for managing a MySQL database because out of the box, you don't have anything except a command line utility. You can download a graphical interface for managing a MySQL database, but there's also an option like PHP and this is something that we are going to be using primarily because we have it at our disposal. And then there's PHP Info, which is very, very useful because this gives us all of the information about our particular installation of PHP. So if you are working within an environment that you didn't set up and you want to see what modules are installed, you can use PHP Info to do that. And we're not going to really go over anything here because we have everything that we need. And now we get to write some code. So I'm going to use the command line to fire up my code editor because that's really the easiest way to open up my code editor where I want it to open up to. So I'm going to cd into MAMP htdocs and I'm going to run code. I like to use Visual Studio Code because it is a nice editor, especially for JavaScript environments. But there's also many other code editors available. So if you're brand new to writing code, I highly recommend that you download and try as many code editors as possible, because that's the only way that you're going to find which code editors that you like to use. There's Visual Studio Code, there is GitHub's Atom, there is Adobe's Brackets, there's Sublime Text, there's PHP WebStorm. There are a ton of code editors, and let me reiterate, download and try many of them, because none of them work the same, and you're going to find some that you like. You're also going to find some that you don't like. So I'm going to create a new file, and let's call this index.php. And the name is very important. Index is what's called a default document, and I'll show you what a default document does here in a few moments. But as far as the code is concerned, we're going to have an open angle bracket, a question mark, and then PHP, a space, then echo, and then a pair of quotes. Now they can be double quotes, or they can be single quotes. It doesn't matter as long as they are the same. You can't have double quotes and then a single quote. You need two of the same type of quote. I'm going to use single quotes, and we are going to type what's called a string. It is a type of data that we work with very regularly in not just PHP, but programming in general. It is a string of characters. So we're going to say hello world. This is our typical incantation for learning a new language. And then we're going to have a semicolon after the trailing quote. And then finally a question mark and then a closing angle bracket. So this is our first line of PHP code. Now we just need to run this. And so we of course want to pull up our web browser. We want to go to localhost, and we need to specify the port 8888. And we are going to see hello world. Now let's view the source. All we see is the text hello world. We don't see the PHP tag or anything like that. We just have the text. And I want to reiterate that PHP runs on the server. So what we see here in the browser is the result of running this code. We are simply writing out hello world to the response that is then being loaded into the browser. So we could come in here and we could add HTML, which is something that we will look at in the next lesson. But for now, this is going to be fine. So this index HTML is the default document for our Apache web server. If you notice, we didn't specify index PHP here in the URL. Of course, we could do that if we wanted to. But the default document means that whenever you don't specify an actual file, if you just have the directory, or in this case, just the host name, it's going to find that default document if it exists. Because we could also come in here and let's rename this to index1.php. And now we're going to see, well, it's not a 404, but it couldn't find any file to serve here because index1.php is not the default document. And we didn't explicitly say index1 in the URL. So the default document is there so that we can omit the file name. And if the default document is there within that directory, Apache is going to use that file. So that is our first PHP application. And in the next lesson, we are going to dig a little deeper into the syntax of PHP because we can't just type anything that we want. We, of course, need to write actual PHP code, and there are certain rules that we have to follow. In the previous lesson, we set up your environment for PHP development, and then we wrote a single line of code that outputs the text hello world. And whenever we looked at the source code, that's all we saw. Now, the code itself comprised of many other pieces. We had this PHP tag, and then we had an echo, and even our hello world was surrounded by quotes. But we don't have any of that in our output. So in this lesson, we're going to dive a little bit deeper into the syntax and to see why this is behaving the way that it does. And we're also going to talk about variables as well, because that kind of ties into what we are talking about. So let's first of all talk about our code block. So we can call this several different things. We can call it a PHP tag, we can call it a PHP code block, or just a code block. But as you probably already know, this is where we put our PHP code. If you'll remember from the previous lesson, I mentioned that PHP is both a language and a runtime. Well, the runtime needs to know where our PHP code is, and it looks for these PHP tags. So anything inside of the PHP tags is considered PHP code, and thus it's going to be executed by the PHP runtime. In fact, we can see what happens if we take out this code and we place it outside of a code block. So let's just do that. Let's hop on over to the browser and refresh the page. And now we have the literal text that is what we would normally think of as our code, both the source code and what is rendered in the browser has both of those things. So what is outside of a PHP tag is treated as just normal text. And in the previous lesson, I said that PHP generates HTML, and that is a true statement. But a truer statement would be that PHP generates text. Because, as you will see here in a few moments, we're going to mix PHP and HTML, and that's how we make all of this stuff work. So the PHP runtime is going to execute a PHP file. In this case, our index.php file. It's going to leave everything alone that is outside of a PHP code block, and it's going to execute all of the code inside of a PHP code block. So that's the first thing you need to know about how this works. The second thing is that inside of a PHP code block, white space means nothing. So here we have everything on a single line, and it kind of makes sense to do so here because it's not a very complex piece of code, and it's also very nice looking. And I know that that sounds kind of weird to say, especially about code, but code needs to be as simple as possible. As you are writing your code, even if it's just for yourself in your own projects, you want to keep your code as organized and as neat as possible, because that makes it easier to read, also makes it easier to maintain, because you will revisit your projects many months down the line. And I know what you're thinking, because I thought it too. Well, I wrote it. I will always know what's going on. Yeah, no, you won't. So we have everything on a single line here, but we could add as many lines as we wanted. So we could just keep on adding lines. We could add some spaces in between echo and then our string over here, and it will still give us the same result as before. We see hello world, and whenever we look at the actual source code, we see the hello world on a single line with nothing else. So white space means nothing, but we use it to organize and to make our code look neat. Now, we have two things, actually three things going on here on this line of code. The first thing we have is echo. This is a command, or in the terms of PHP and other languages, this is what we would call a function. A function is a piece of code that performs a particular purpose. In the case of echo, its purpose is to output text. So we are saying echo out this text here, and that is, of course, what we see in the browser. And if you remember from the previous lesson, I mentioned that this hello world is called a string. It's a string of characters. And a string is how we work with text inside of our code. So whenever we want to echo out anything or just output something in the response that is sent back to the browser, we can use echo to do that. And that means we can come in here and we can actually add in some actual HTML. So let's do that. We're going to wrap our text with a P element. If we go back and refresh the page, now we see that the P element is there. And whenever we view this in the browser, well, that's going to look the same, isn't it? Let's do this. Let's change it from a P element to an H1, because that at least changes the style of the text. It makes it much larger as well as bolder. And there we go. So we can output normal text, but we can also output HTML. But we can also do it like this. Since the area outside of a PHP tag or code block is considered just text, we could do this. Now, let's first of all break this down. We have an opening H1 tag, we have our PHP tag, and then we have our code that is outputting the text hello world. We have the closing of our PHP tag, and then we have the closing H1 tag. So if you're going to guess that we aren't going to see any difference here, you would be correct, because the result is essentially the same, although whenever we look at the source code, we see that H1 is on a different line than hello world. But as I mentioned earlier, if we're just going to output the text hello world here, and not going to do anything else that would make this code more complex, then it would make more sense to put everything on a single line so that it's easier to read. So now, whenever we go back, let's refresh the page, we now have kind of the same output as far as the actual source code itself, but of course what is rendered inside of the browser is going to look the same. Now, the reason why we see this line break is because we have a line break here. And when the PHP runtime executes, it's going to put the hello world text on that same line. But notice that the closing h1 element is still in line. So in order to make that be on a different line, we would need to add another carriage return. And there we go. So if you want to actually format your HTML to look nice, then you're going to have to play around somewhat. And some developers do that, others don't. I'm one of the latter. I just want the code that I'm working with to look fine. What is actually sent to the browser, I really couldn't care less. Okay, so I mentioned that we had three things going on, and we talked about the echo command. The second thing is that we are passing in this string to the echo function. In the previous lesson, I said that this is a string because it is a string of characters. And while that's true, a string is how we work with text in our code. So I'm going to use the terms string and text or text data interchangeably because that's essentially what we have. A string is text data. So we are passing text data to the echo function so that the echo function can perform its work. So that's the second thing going on. And then the third thing is the semicolon. So we have what's called a statement. A statement is just code that does something, and every line of code does something. In this particular case, we are echoing out some text. So we have a statement, and we end that statement with a semicolon. So the semicolon says to the PHP runtime that this is the end of a statement. So in programming, a statement is just a smaller piece of a larger application. Just like in a spoken language, a sentence is the smaller piece of a speech or a smaller part of a written body of work. So a statement, it's doing something, and it's just a smaller piece of an application. Now, there's one other thing that I wanted to talk about as far as strings are concerned. In the previous lesson, I said that a string begins and ends with a quote. So we have a single quote at the beginning, we have a single quote at the end. If we omit that quote and we save it, now Visual Studio is going to signify that this is an error. That's what that red squiggly line means. And this is giving us immediate feedback saying that there's something wrong here, but let's ignore that. Let's say that we don't have that in whatever code editor that we're using, and we refresh the page. Well, now we see that this page isn't working. This is Chrome telling us that the page isn't working. And the reason why is because the server returned a status code of 500. So when you see a 500 error, it's not a problem with the runtime. Well, it's usually not a problem with the runtime. It's usually not a problem with the server. More often than not, it's a problem with your code. Now, this isn't very helpful because this doesn't tell us anything as to where the problem is. And when it comes to programming, we need to know where the problems occur. Otherwise, how in the world are we going to fix it? So in the next lesson, we're going to change that so that we have some feedback whenever we see an error occur in the browser. But thankfully, Visual Studio is telling us where the problem is here. So we can just change our code to be an actual string here, and then the problem, of course, goes away. So now let's do this. Let's take out our code, and let's have an actual HTML document. Although, let's get rid of some of this because we just don't really need that. And for the title, let's say that this is Hello World. And then inside of the body, let's have an h1 element that says this is the title, as if that wasn't apparent enough. And then we're going to have in our code. So as you would expect, we're going to see our content. We have our title, and then we have just our content. And of course, if we look at the HTML, that's what we have. Now, let's do this. We're going to use a variable because in reality, there's really no reason to use PHP code here. We could come in here with a P element, say hello world, and everything would be fine. But the whole reason as to why we have PHP is so that we can have dynamic web pages and websites, so that we interact with a database or perform some kind of calculation, and then that is going to change the HTML that is sent to the browser. That's why we have PHP. So we are going to use a variable, and then we're going to output the value of that variable. So first of all, what is a variable? Well, it's nothing more than something that stores data. So you can think of it as a box, and you're going to put something in that box so that you can reuse whatever you put in that box. And in PHP, you create a variable with a $sign. Every variable begins with a $sign, and then you give that variable a name. And you want to be descriptive whenever you create a variable name, because as you're reading your code, you want to be able to know what a variable is for. So I'm calling this variable name, and then I'm going to assign it my name. You can put your name there or somebody else's name, it doesn't matter. And we are going to echo out our name. Now, in this case, our name variable contains string data. So when it comes to echoing our name variable, we don't have to come in here and specify that this is a string because we already have our string data. So we are just echoing out our variable. If we go to the browser and refresh, we see the result there. Whatever we assigned that name variable is being output in the HTML. But that's not very useful. Let's say that we want to greet whoever is our name. So we can do this. We can add two strings together. The technical term is concatenate. We concatenate two strings together, but it's essentially adding them. So we're going to say hello, comma space. And then in order to add two strings together, we use a dot. Now, many other languages use a plus sign, and that makes sense because you are adding two strings. But in PHP, we use a dot. So we say hello, comma space, and then dot, and then our variable name. That's going to combine those two strings together, and we have hello Jeremy and hello Jeremy. Now, we could also do it like this. If you'll remember from the previous lesson, I said that whenever we create a string, we can use single quotes or we can use double quotes. And the reason why we have both of those is because they do essentially the same thing, but there is a difference. If you use double quotes, you can embed a variable just like that. Now, notice here the color coding. Hello is in the color of a string, and then the name variable is in the color of a name. And this is one of the reasons why I say that you need to try different code editors, because different editors have different features. And as far as Visual Studio Code is concerned, it is smart enough to know that it needs to color these two things differently. Because whenever we view this in the browser, we're going to see the same results. Hello, Jeremy. And if we tried to use single quotes instead of double quotes, we are going to see something completely different. We will still see hello, but now notice the coloring. They both have that orangish color, which is the color of a string. So whenever we view this in the browser, we're going to see hello and then $name. So there is a difference between strings with double quotes and strings with single quotes. The convention is to use single quotes unless if you want to embed a variable, and in which case, use double quotes. Well, in the next lesson, we are going to set our environment up so that we can see errors. Because as I mentioned, errors are very important. When something goes wrong, we need to know what and where it goes wrong. In the previous lesson, we looked at several things. We looked at PHP code blocks, at syntax and variables, and in the midst of all of that, we caused an error to occur. And whenever we saw the error in the browser, well, all we saw was Chrome's error page. We didn't have any information about the error that occurred within our application. And that's important for us as developers. When an error occurs, we need to know what the error is and where it's located so that we can find it and fix it. Now, in a development environment, that's what we want, but a production environment is a completely different thing. We don't want to display any type of error information because we could potentially leak information that then could be used against us. So let's start by taking our index.php file, let's copy it, and let's rename it to error.php because we want to keep our index page just as it is. And the error that I am going to introduce is removing the closing quotation mark on line 13 whenever we echo out hello and then the name. We have created what's called a syntax error. This is a literal error with our code. We have violated the rules of PHP's syntax, and Visual Studio is dutifully telling us that is the case. However, let's assume that this is just a massive application and we don't know where this error is. So let's just pretend there. So let's go to the browser. Let's refresh, well, not refresh. Let's go to error.php, and of course, we get Chrome's error page. Now, once again, in a production environment, this is what we would want. Well, not exactly, but for the most part, this is what we would want. We don't want to display any error information at all. But in a development environment, we do. And so we need to modify our PHP's configuration so that we can display those errors. Now, we want to go to wherever we have installed MAMP. For me, it's at the root. If you're on macOS, it's probably in your applications folder. Just wherever it's installed, go to MAMP. And then there's going to be a folder called conf. Now, don't be confused here. There are a ton of PHP folders here. Now, the reason why we see this on screen is because over the years, I have installed and reinstalled and updated many versions of MAMP, and thus all of these versions of PHP have been installed. So that's why there are all of these. On your installation, you probably will just see two. 715 and then 70 something. I don't remember. We want to go to the folder that is 715 or whatever the latest version is. Basically, what you want to do is go to wherever the version is set in your preferences. So if you go to preferences and then PHP, the standard version, that is the version that you want to use. What is listed there? 715 for me. So we want to go to PHP 715, and here is our PHP INI. Now, it's always a good practice that whenever you modify anything that is important like this, make a copy so that you have a backup. And I'm going to just call this php.ini-original, and then we're going to modify PHP INI. Now, the setting that we're after is called display_errors. In fact, that's not it, but this is giving us some information about all of the different settings. And you can see that there's a ton of settings that you can choose from, but the one that we are after is display_errors. So just do a search for that and keep going until you find the actual setting. Now, whenever you see a semicolon before any text, that means that this is commented out. It's ignored. Basically, it's there for documentation purposes. So on line 374 here, for me, this is the actual setting because it doesn't begin with a semicolon. And you can see that it is set to off. Now up here, we can see the possible values for display_errors. There's off, there's std error, that's the standard output, and then there's on or standard out. Actually, std error, I really don't know what that is. I know what std out is, that's the standard output. But in our case, we want to set this to on because that is going to display the errors in the browser, which is what we want. But if you scroll up, you can also set the error level. Now, there are many different error levels, and by levels, that means different categories of errors, basically. So right now it's set to all. It's going to display all errors and warnings. But then you can have it display just the errors, or you can have it display just the warnings, or just the notices, or other things. But the actual setting, once again, is where it doesn't begin with a semicolon. So the error_reporting is set to show all messages. And in development, that's typically what you want. So let's save this. And let's go to the browser, and we're going to refresh, and we're going to see that nothing happens. We have to restart Apache in order for those new settings to take. So you can go to the MAMP application, stop the servers, and wait for those to stop. And then once the indicator has stopped, then those services are stopped. Now, I'm going to click this, and I wish that there was an indication signifying that I had clicked it. It doesn't do anything until a few seconds later, so don't just keep clicking it or it'll never start. Just click it once, wait a few seconds to see if there's anything going on, and then go from there. We can see that those services are now running. If we refresh the page, now we have our error. It says it's a parse error, syntax error, unexpected end file in, it tells us the file, error.php, on line 18. So you can see here that there is very important information. If this was in production and a malicious person came upon this error, they would know at least some part of our server's folder structure or directory structure. And you want to avoid leaking out any type of information. So once again, don't display any errors for production, just for development. So now we know where that error is. It is on line 18 of error.php. Now line 18 is here, this closing HTML tag. But this is where it thinks that we wanted to end that string because this is the end of the file. Since we opened a string and never closed it, it's assuming that the end of the string is the end of the file. So we want to add our closing quote there. We, of course, save that, the error goes away, and whenever we refresh the page, we see our ugly little page again. But let's do this. Let's echo, and let's create, well, we're not creating a variable yet. We're going to use a variable that doesn't exist. First_name. Let's refresh the page, and we still see that this works. And the reason why our application is still working is because this wasn't what's called a fatal error. This doesn't cause our application to just stop working. So we now have our ugly little page and then a message. And this is a notice. It's not the same thing as an error. So this is just warning us that there is an undefined variable, first_name, and then it tells us the file and the line as to where that occurred. So all we have to do to fix that is, of course, get rid of line 15, or we could just create that first_name variable, and we could set that to just an empty string. So now if we refresh the page, that message goes away, and we once again have our wonderful little page there. So now that we have errors set up and being displayed within the browser, we can continue on so that if we ever run across any other errors, we know where those errors are and we can fix them. In this lesson, we are going to look at conditions and decisions because they are intertwined. If you want to make a decision, well, you have to have a condition. So before we get into that, let me briefly go over how I'm going to organize the code in this lesson and the following lessons. I want you to be able to find these files easily in the code download. So I'm going to create a folder that is correlating to the chapter and lesson. So this is the second chapter and the third lesson. So this folder is going to be called 2.3, and then all of the files for this lesson are going to be inside of this folder. And what you see on screen is going to be what is in the files. So the file name, the file contents, everything is going to be what you see on screen. So we are going to be working with conditions and decisions. So I'm just going to call this conditions. We could use index.php, and that would actually be easier as far as the browser is concerned. But I want you to be able to look at the file name and see that, oh yes, this is where we did conditions and decisions. Okay, so the first thing I'm going to do in this file is create a PHP block. But notice that I have not closed that block. And this is perfectly legal, and it's actually something that we should do. If we have a PHP file that has nothing but PHP code, nothing else, then this is fine. We should do this. If we have HTML or anything else, then we should probably close our code block, just so that you're aware. Okay, so a condition. What is a condition in programming? Well, it's a lot like a condition in real life. Let's just go back to school, and we are sitting in basic math, and we need to compare two numbers. So we're going to compare the number 1, and we're going to use the less than comparison, and we're going to say that 1 is less than 3. That is, of course, true, right? That is a true statement. So in programming, this is essentially what we do. We compare two or more values, and we get a result. It's true or it's false. So we are essentially testing something and then working with the result of that test. So here we have a variable called result, and we are comparing 1 is less than 3. That is, of course, true. So the value of true is being assigned to result, and we could echo that out. So let's just do that, and we'll see what we have. So let's go to our browser. We'll go to 2.3 and conditions.php, and we have the number 1. Why do we have the number 1? That should be true, right? Well, here's the thing. If you're not really familiar with computer science, at the very basic level of a computer, you have a transistor. Inside of a CPU, it's nothing but transistors and silicon and all of that stuff. But a transistor is either on or it's off. There is no other state that a transistor can be in. That is the absolute basis of computers. Something is on or something is off. So whenever you talk about bits and bytes and megabytes and things like that, a bit has one of two values. It's either 0 or it's 1. 0 would be off. That is typically false. 1 is on, and that is typically true. So the result that we have here says 1 in the browser, but that's representative of true. So let's do this. We're going to echo result equals true. Now, notice what I've done here. I've used two equal signs. This is the comparison operator for equality. We are comparing result with the value of true. Now, also notice that true is not $true or anything like that. It's just plain true, and it's all lowercase. So if we go back to the browser and we refresh the page, we still see the value of 1. Because what are we doing? We are echoing the result of comparing our result variable with the value of true, and we're seeing if they are equal. So if we have a keyword or a special word called true, it goes without saying that we have a special word called false. So if we go back to the browser and refresh, we don't see anything at all. Because if something is false, then PHP isn't going to output anything. It's just not going to be there. So this is the basis of making decisions. We have some kind of comparison, and we're going to use that in our decision. So when it comes to comparing values, we can check for less than, we can check for greater than, we can also do less than or equal to and greater than or equal to by just adding an equal sign after. We can compare the equality of two values with two equal signs. Now, once again, I cannot stress this enough. If you are comparing two values and you want to check if they are equal, you use two equal signs, not one. If you use one equal sign, you are assigning something. You're taking what's on the right-hand side and assigning that to what's on the left-hand side. That is not what you want to do if you are comparing two values together. You want two equal signs. So if we have the ability to compare if two values are equal, then we also have the ability to check if two values are unequal. For that, we have an exclamation point. You might hear other people say bang or not, and that is followed by an equal sign. So we have a not equal, we have equal equal, we have greater than or equal, greater than or equal. And we could use this with more than just numbers and what we call Boolean values. Boolean values are true and false. So now let's do this. Let's create two variables that are going to be for the first name and last name. So we'll say first underscore name, which, by the way, when it comes to naming variables, there's many different styles that we can choose from. Traditionally, variables in PHP have an underscore between the different words. So we have two words in this variable name. We have first and name. So we would separate that with an underscore. Now, in other frameworks like Laravel and Symfony, the convention is to not use underscores, but instead use camel casing, where the first word begins with a lowercase letter, and then every other word after that begins with an uppercase letter. We have camel humps, so that's called camel casing. The important thing is to be consistent. If you are in a project and you start using underscore variables, then continue to do that. If you use camel case variables, continue to do that as well. Don't mix and match your styles. Pick a style and stick with it throughout that entire project. It's also important to use the style that your particular framework is going to use, because chances are you're going to use a framework. If you don't, well, more power to you. But if you use something like Laravel or CodeIgniter, or there's many other frameworks to choose from, look at their style guidelines and follow them. It just makes your code easier to read for you as well as anybody else that is going to be looking at your code. Now, for this course, I'm going to try to use underscores. I typically like to use camel casing, but traditionally in PHP, variables use an underscore, so I'm going to try to do that. So we have a first name variable, we have a last name variable of McPeak, and we are going to make a comparison here. So we're going to check if our first name is equal to Jeremy. So notice what I'm doing here. I have an if statement. That's what this is. If, and then we have our condition inside of a pair of parentheses. And then we have a pair of curly braces. So if first name is equal to Jeremy, then this code inside of these curly braces are going to execute. So let's just echo, and we'll say that the condition is true. So let's go to the browser. Let's refresh the page, and the condition is true. That is natural because our first name variable contains Jeremy, and we are comparing that with Jeremy. But let's do this. Let's change the J in our comparison to a lowercase j. Now let's go back, let's refresh, and we get nothing because this condition is false. And because that condition is false, this entire if statement is false. But let's say that, well, we want something to happen anyway. So we can have an else statement. So if first name is equal to Jeremy with a lowercase j, then echo the condition is true. Else, echo the condition is false. So now we will have at least something on the screen. The condition is false. So there's one other thing here. Notice that I did change this to a lowercase j. And as far as programming is concerned, there is a difference between an uppercase j and a lowercase j. Even though for us humans, we might look at that and say that, yes, they're equal. Of course they're equal. But they aren't. They are two different strings because one has a different value than the other. So we have this ability to make a decision. If something is true, then we are going to echo this. Otherwise, we're going to echo this. But we also have the ability to have multiple comparisons within a single condition. So let's say that we want to check if first name is equal to Jeremy with an uppercase J, and the last name is equal to a string that has McPeak with uppercase M, lowercase c, uppercase p, and so on and so forth. So now let's look at what we have in the browser. We have true. Okay, so let's look at this. We have two conditions here. We have first name is equal to Jeremy with an uppercase J. Then we have two ampersand signs. This means and. So if we were reading this and translating this into English, if first name is equal to Jeremy with an uppercase J and last name is equal to McPeak with those uppercase characters, then the condition is true. And we saw that it was true in the browser. And we can have as many comparisons as we need inside of a single condition. However, the more comparisons we have, the more complex our condition becomes, and the more we have to really think about it. So try to keep your comparisons as small as possible. It just makes your life a whole lot easier. So we've talked about the and. Let's do the or. So the or operator is two pipes together. We say first name is equal to Jeremy or last name is equal to McPeak. So in the case of or, we have our condition and we have two comparisons in that condition. If one of these is true, then the entire condition is true. So let's change this again. Let's change the uppercase J to a lowercase j so that our first comparison is going to be false. But since we have an or condition, we are still going to see that our condition is true. Because even though our first comparison is false, our second comparison is true. We are saying is if first name is equal to Jeremy with a lowercase j or last name is equal to McPeak. So the condition is still true. However, if we change this to an and, both of these comparisons have to be true in order for the entire comparison or the entire condition to be true. I'll tell you what, it is hard to say comparison and condition in the same sentence and get it right. So I just had to throw that out there. Okay, we have a condition here, but let's say that we want to do more than just this comparison or this condition. We want a second condition in case if this one fails. So let's do this. We're going to say if first name is equal to Jeremy with a lowercase j, last name is equal to McPeak, else if, then we have another comparison. And in this case, we're going to say if first name is equal to Jeremy with an uppercase J and last name is equal to McPeak, then we're going to say the second condition is true. And let's also change our first so that it says the first condition is true. And then we're going to have an else where we say the condition is false. Okay, so let's read this, because whenever you come across multiple if and else ifs, it's easier to just read it so that you can get an understanding of to what's going on. So if first name is equal to Jeremy with a lowercase j, or if last name is equal to McPeak, then we are going to say the first condition is true. However, if this condition is false, then it's going to fall down to the next else if. If first name is equal to Jeremy with an uppercase J and last name is equal to McPeak, then the second condition is going to be true, and that's what we will see. Now, if both of these conditions are false, then we will see the condition is false. So go ahead and think about what you're going to see on screen. Well, you're going to see that the first condition is true. That's because we have this or operator here. First name does not equal Jeremy with an lowercase j, but last name does equal McPeak. So let's change this. Let's make McPeak have a lowercase p. Now, whenever we refresh the page, we're going to see that the second condition is true, because the first condition is all false. Both comparisons are false, so that one's false. The second condition, first name is equal to Jeremy, and last name is equal to McPeak, well, that one's true, so that's what we see. But if we make this fail, let's change this to a lowercase j, or no, let's not do that. Let's use the not equal. So if first name is not equal to Jeremy and last name is equal to McPeak, then we should see this, but that's not the case. Instead, we're going to see that the condition is false. And I guess that's not right. The conditions are false. So let's get that right. The conditions are false. And so at the heart of it, it's very simple. We make a comparison, and then we make a decision based upon that comparison. However, we can make this as complex as we want or need to. We can have a condition that has multiple comparisons, but in doing so, we also make our code a little bit difficult to follow. But regardless, this is something that is going to take a little bit of time to get a hold of, because there are different comparisons that you can do. The inclusion of and or just adds to the complexity of it. So this is something that you need to practice. And if all else fails, just read it. Read it as the code is written. It translates to English very easily, and you'll get a better understanding of what's going on when you do so. In this lesson, we are going to talk about arrays. Arrays. I have a very difficult time saying arrays, especially when I start talking faster, and it definitely does not come out correctly. So please bear with me when I say the term arrays, because if I want to say it correctly, I have to stop and think, okay, I need to position my mouth correctly. Arrays. And go from there. So what is an array? Well, it's a data structure, really. It's a way that we can store multiple values in a single variable. So let's look at this. We're going to create a variable called guitar. I'm a guitarist. I love to play guitar. I love to collect guitars. Some people say that I have too many. Some people being my wife, and I say that I don't, but she usually wins. So I want to have a page that displays my most favorite guitars that I own and guitars that I want to own. So we're going to start with a guitar called Vela. It's made by Paul Reed Smith. I have become a Paul Reed Smith fan because, well, I like the shape of their patterned regular neck, and especially with the Vela, the pickup configuration is just, it's wonderful. It has a single coil in the neck and a humbucker in the bridge, and it's just, it's an offset body. It's beautiful. It sounds great. It's a wonderful guitar. So that's going to be the first one that I want to have here. But, then I want to own a Gibson Explorer. I'm not a huge fan of Gibsons, but I want an Explorer. I like the shape of them and all of that stuff. But now, this is going to run into a problem because we've created a guitar variable. We have assigned it a value. And then we have reassigned another value to the guitar variable. So now we still have just a single variable, but now it contains Explorer. So we could get around this by changing the name of our variables so that we have Vela guitar, then we can have Explorer guitar, and let's add a third. We need to have a Strat. So we have a Strat guitar. And while this is going to work, this is not really feasible because as more guitars are added to this list, we have to add another variable, assign it a value, and then that's just another variable that we have to keep track of. It's not an ideal solution. So instead, we can use an array. I'm doing pretty good saying that so far. So we can have a variable called guitars, and then we can create an array in one of two ways. We can use the array function, and then we can pass in our values. So we would have Vela, and then Explorer. Well, we need a separate string there. Explorer, and then Strat. Notice that I am separating each of these with a comma. And this is the old way of creating an array. If you are, unfortunately, in an environment that is PHP 3 or below, then this is how you have to create an array. But 5.3 is many years old. Hopefully that you would be in at least 5.4 or above, and in which case you can use the newer syntax, which looks a lot like JavaScript. You just use the square brackets. So you have an opening square bracket, you define your values. Once again, they are separated by commas, and then you have the closing square brackets. So this is the syntax I'm going to use. And this gives us the ability to reference any one of these values at any given time. But how do we do that? Well, let's first of all do this. Let's echo guitars. Now, we aren't going to get what we would hope we would get. Let's go to the file. We get a notice, array to string conversion in arrays.php on line 5. And then we see array. So what we see here, array, is the result of our echo statement. We are trying to echo an array, but there is no conversion between an array and a string. So that's why we get the notice. It's not an error, but it is a notice. It's a warning. So all we see is array. Instead, we want to see the contents of that array. And so we can use a function called print r. And then we pass in our guitars array. And whenever we go back to the browser, we're going to have a nicely formatted output. But if we view the source, we're going to have even nicer. So we have array, and then we have our values. But notice here on the left-hand side, we have what's called an index. A normal, traditional array has a list of values, and we access those values by specifying the index. And notice that this first index is 0. We start counting at 0 in PHP and in many other languages. There are some languages that start at 1, and they're just wrong. So we use this exact syntax here, the open square bracket, the index number, and then the closing square bracket to get whichever value that we need. So we can go back to our code, and let's do this. We're going to say echo guitars, and we want the guitar at index 0. That is going to be our first item in our array. So whenever we go back to the browser, let's refresh, we will see Vela. If we change the index to 2, we can count it 0, 1, 2. We're going to see Strat. But if we say index of 3, well, we don't have anything at index of 3. We get a notice. Once again, it's not an error, but it says that there's an undefined offset of 3. Sometimes you will see the term offset, and more often than not, you can translate that to index. So here's what we could do. There is a function called isSet. And if guitars at index 3 is set, then we can output that value. So we can use a decision here. If isSet guitars index 3, then we are going to echo that guitar. Otherwise, we'll have else. We will echo that the guitar does not exist. So we go to the browser. Let's refresh the page. And we have a fatal error. Uncaught error, call to undefined function is set. It helps if you actually do that correctly. There is no underscore in is set. So we see guitar does not exist. And unfortunately, this is one of the things that I have always said about PHP is that it is not consistent. There are many functions that have an underscore between the words. There are other functions that don't. And unfortunately, you just have to memorize which ones do and which ones don't. And apparently I haven't memorized that. So there is some inconsistency with the functions and the API given to us by PHP. But that's just the nature of the beast. We have to go with it. So this is a normal array. We access each individual item within that array with an index. So let's add a comment, and I haven't talked about comments, have I? If there's ever a time that you want to make PHP ignore some of your code, you can comment out that code, and you do so with 2 slashes. I'm not going to say if it's a forward slash or a backslash because, frankly, I don't know which one is which. I typically say forward backslash. So with 2 forward backslashes, you can comment out some of your code. So if we comment out our guitars and we go and refresh the page, well, that wasn't a very good example. I tell you what, let's do this. We will have our print R, and we will print R the guitars. Once again, And of course, whenever we refresh the page, we are going to see that output followed by guitar does not exist. But if we comment out the print R, we are not going to see the output of the array. We just see the output of guitar does not exist. So that's what a comment is. It is basically just saying that, hey, PHP, ignore this. And it's a nice tool for adding your own comments to your code. So if you wanted to give some insight into some code that you've written so that the future you knows what you did, or somebody else looking at your code knows what you did, you can add some clarity with comments. So this is a traditional array. But PHP also has something called an associative array. And this is kind of the same thing, but it's also a little bit different. So we're going to have guitars 1, and we're going to have guitars 2. So let's do that. We are still going to use the square bracket syntax, but now we have to specify what's called a key, and then the value for that key. So if we look at the print R of guitars again, and I didn't change the variable there. There we go. Let's refresh. If we look at this, we have our indexes over here. Well, our indexes, we could also kind of call those keys. So we have our key on the left-hand side, then we have an arrow, which is an equal sign followed by a greater than sign, and then the value. And that's essentially what we do to create an associative array. We specify the key, so I'm going to use the manufacturer as the key, because I'm going to say that this is a list of my favorite guitars. So the first manufacturer is Paul Reed Smith. I'm just going to say PRS. And the value is going to be Vela. And since we have 3 of these, we need to separate them with a comma. So the next is going to be Gibson. And then we have the arrow. The value for Gibson is going to be Explorer. And then we have Fender, which is the manufacturer of the Stratocaster. So there we have Strat. So this is the associative array. We have a key and a value. So you could think of guitars kind of as a lock for multiple doors. And whatever door you want to open, you have to provide the appropriate key. So the PRS key is going to open the door for Vela. So we would do essentially the same thing in order to access these values. We would say guitars, and then whatever key that we used. So PRS in this case. And we have a lot of echoes, so let's just comment out all of that. In fact, let's just comment out everything else so that we just have our associative array. So if we refresh this, now we see undefined variable guitars, of course. See, whenever I change things on the fly like that, it just never turns out well. So we are using the PRS key. We're using essentially the same syntax as we did with indexes, except that we are specifying the key, PRS in this case, and we are getting Vela as the value. So this is also case sensitive. So if we say PRS with a capital P, that is not the same as PRS with a lowercase p, and in which case we see undefined index. So once again, we could do essentially the same thing that we did with our first guitars array. We can use that isSet function, and if that particular key is available, then we will display that value. So if PRS with a capital P is set, then we are going to output that value. Otherwise, we're going to say guitar does not exist. So we should see guitar does not exist, which is just what we wanted, but let's go ahead and let's add a PRS key with an uppercase P. And I also like the Starla. Well, no, the single cut, because the Starla has a Bigsby tremolo, and I'm not a fan of tremolos. So now we have a key of PRS with an uppercase P. We have the value being displayed here, the single cut. And so that is essentially it as far as arrays are concerned. Now, in the next lesson, we are going to look at loops. And loops and arrays go hand in hand because loops allow us to loop over an array and output each item within that array. So if we wanted to easily build a list of my favorite guitars, we can do that very easily with a loop. And we will, of course, do that in the next lesson. In the previous lesson, we looked at arrays and how we can store multiple values and multiple keys and values in a single variable. And they are a wonderful tool. And in fact, it would be hard to write some software without arrays. But one of the things we did in the previous lesson is we just picked and chose, different items and then chose to display those on the page. While yes, there may be times when we do that. It's going to be very rare, actually, whenever we know that we want the item at index 1 or we want the item at index 10. More often than not, whenever we have an array, we want to work with the array as a whole and work with every item within that array. And that's what a loop is very good at doing, because a loop gives us the ability to execute the same code over and over and over again. So if we want to work with every item within an array, and especially if we want to do the same thing with every item in the array, then the for each loop, and really any loop, is going to be what we want to use. But for right now, we're going to talk about the for each loop, because when it comes to working with arrays, this is the loop that we typically use. Now, we're going to do something a little different starting in this lesson, and that is we're going to start mixing our PHP and our HTML, because that is, after all, why we are using PHP, to change the output of our HTML. So if you look at the htdocs folder, there is a file called template.php. There is a folder called assets that has a subfolder called CSS, and then there's two CSS files here. These are going to be used for the template. So if you are following along and want to do exactly what I do on screen, you can take the contents of that template and then paste it into a new document, because that's exactly what we are going to do here. Now, there is one thing to note. We are going to display a title in these files so that whenever you see them in the browser, you know that, okay, this is the page for the for each loop. But I'm trying to use the title variable, and it, of course, is not defined. So that's the first thing we need to do, is set the title. And we are working with the for each loop, so we're going to set title equal to that. Now, notice, though, that the syntax for outputting the title is a little different. We have been using echo, and we've also been using open angle bracket, question mark, PHP space echo, and then whatever we want to output. Well, now all we really have to do is this. This is a shorthand version of that. So we save a few keystrokes and really make our code a little bit easier to read and maintain in doing so. So you're going to be seeing this from now on, as opposed to just saying echo. Is just the easier thing to do. So now whenever we go to the browser, let's refresh, and now we see that this is the for each loop, and the title also says this is the for each loop. Okay, so we are going to be working with guitars. We want to display some guitars. So let's call this variable favorite guitars. This is going to be an array, and we'll have a Vela, we'll have the Explorer, and then we will have the Strat. So we want to display these in a list or a table, just some way so that we can see that these are my favorite guitars. Of course, I have more, but this is going to be manageable. So down here I have an H1 element, and this is going to be my favorite guitars. And here where we see the content here, that's where we're going to put our content. Now, when it comes to mixing PHP and HTML, we want to limit the mixing as much as possible. I mean, we can't get away from mixing it completely because, well, there would be no way. There would be no way that we could output the title here without mixing PHP and HTML. However, we want to limit how much PHP we put in our HTML. And there are many different schools of thought as to how to do that. The more processing you do, more people will say that you need to separate your PHP and HTML. So if you had something like a loop, that might be something that you want to put up here at the top of the page so that that code will execute up here and it will be written up here so that you wouldn't have a for each loop inside of your HTML. However, in most cases and in most frameworks, if you're going to be outputting an array of things, chances are the for each loop is going to be here in the HTML. So that's what we are going to do here. So the for each loop is very easy to use. We start with for each, then we have a pair of parentheses, and then we have a pair of curly braces. So it looks a lot like an if statement, but we don't have a condition really. Instead, we specify the array that we want to work with. That was favorite guitars. And we want to also specify what we want to refer to each item within that array as. So we say for each item in favorite guitars as, and we're going to call each item a guitar. So we work with our array, and then we create a new variable for every item that we work with. So if we were going to output a table, let's do that. We'll say table, we'll say class equals table and table striped. And since each guitar is going to be on its own row, we are going to have to output a tr element and a td element. So we could do something like this. We will say tr and then td, and then we will have our guitar. We will close td, close tr, and there we go. So whenever we go to the browser and refresh, we are going to see our table. We have the heading, my favorite guitars, and then we have Vela, Explore, and Strat. So the code that is inside of the curly braces is what's going to execute for every guitar inside of favorite guitars. That's how the for each loop works. But there are some arrays where we have key value pairs. So let's call this KVP guitars, KVP being short for key value pairs. And we'll do kind of the same thing from the previous lesson. We'll have PRS and then Vela. We'll have Gibson and then Explore, and then we will have Fender for the Strat. And when it comes to the for each loop, this is going to be very, very similar. Let's do this. Well, we'll just copy this table. We'll paste it again. And we aren't working with favorite guitars. Instead, we're working with KVP guitars. And then we want to say that, okay, we have our guitar, but we also need the key for that guitar. But let's first of all see what this looks like in the browser. It's the same exact thing. So if you have an array that has key value pairs or an associative array, and you just specify a variable name, it's going to be the value. However, we could come in here and we could say key and then have arrow and then guitar for that variable. So the key is going to be our key and then the guitar is going to be the value. So that means that we have two variables to work with. So I'm going to add another column and we're going to output the key there. So now our original for each loop is still going to be the same, but our second has two columns. We have the key being listed here, then we have the value, and the same is true for the following rows. So the for each loop is pretty straightforward. For each item in an array, we want to execute certain code, and that's really it. So we're going to move on to the next loop, which is called a for loop. And the for loop is traditionally the first loop that you would normally learn. However, I'd like to start with the for each because it's just easier. The for loop is still easy once you get a grasp of what's going on, but it's not as straightforward as a for each. But when it comes to a for loop, you typically use just regular arrays, ones that have indexes, as opposed to associative arrays. So we're going to get rid of everything working with our second array so that we have just the first. And we also need to change the title. This is the for loop, not the for each. Now, the for loop is useful when you want to execute a loop for a certain amount of times. Like, let's say that we want to display the numbers 0 through 10. Well, with a for loop, we can do that very easily. The syntax, however, is a little different. The easy part is that we have for, a pair of parentheses, and then curly braces. And just like the for each loop, the code for our loop is going to be inside of the curly braces. However, it's what's inside of the parentheses is where things begin to be very different. Because since we want to execute a for loop just a certain amount of times, there are certain things that we need. Like, for example, we need to keep track of where we are as far as how many times we have executed the loop. So the first thing we need is a counter. And traditionally, we have a variable called I as our counter. So that's the first thing we need. We initialize our counter. I is equal to 0 because we typically start at the beginning of an array. Or it doesn't have to be an array. We just typically start at the very beginning, and that's 0. The second thing we need to know is how long we want to execute the loop. So this is a condition. We want to execute a loop for 10 times. So we say as long as I is less than 10, we want to execute this for loop. But then we need to increment our counter because every time our loop, it's called iterating. Every time our loop iterates, that's whenever our counter increases and the condition is met and we execute our code, that's incrementing through the loop. We need to keep track of how many times we have done that. So we need to change the value of I. We need to add 1 to it because that is keeping track of where we are. So we can say I equals I plus 1. That's going to take the value of I, add 1 to it, and then assign that to I. We could also write that like this. We can say I plus equals 1. That is the same thing. It's going to take I plus 1 and assign that back to I. But what I like to use is called the increment operator. It is simply I plus plus. Anytime you have plus plus at the end, it is going to increment that value. So if I is 0 and we say I plus plus, well, I is going to be 1 because it is incrementing I to whatever is the next number. So if I is 1 and we say I plus plus, then I becomes 2, and then 3, and then so on and so forth. So this is how this for loop executes. We initialize I as 0, and then it checks to see if I is less than 10. So right now, I is 0. 0 is less than 10. So the loop is going to execute. The code inside of it will execute. So this will execute. Then I is incremented, and then the condition is checked again. So now, after the incrementation, I is 1. 1 is less than 10, so the loop executes. I increments to 2. 2 is less than 10. The loop executes. And it does this over and over again until we get to 10. So after 9, I becomes 10. 10 is less than 10? Well, no, it's not. So at that point, the loop exits and the code inside of the loop does not execute. So let's first of all do it like this. We will see 2 loops now in our for file. We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. The loop ran for 10 times because we start at 0. And so that is how that works. But we want to work with our favorite guitars. So we need to know how many items are in our array. Now we could just hard code it 3 because we only have 3 guitars, but that's not very sustainable because if we add more guitars here, then we have to come down and change our loop. So instead we have a function called count. This is going to count how many items we have in our array. So we call count, we pass in our array, and that is going to give us how many items are in our array. So now we can do this. We can say guitar equals favorite guitars, and we can use the I variable as our index, and then we will simply output guitar. So now whenever we view this in the browser, we're we're going to have two loops, Vela Explorer Strat, Vela Explorer Strat. So that second loop is our for each. We'll get rid of that. And now we just have our for loop. So it's a little bit different. Okay, it's a lot different. There's a lot to wrap your head around, but it is still useful. When you know how many times you want to execute a loop, the for loop is the loop that you want to use. However, in this particular case, the for each would work better, because at this point in time, we're not really doing anything with I except using that as an index to get our value. Now, if we were doing something else with I, then it would make sense to use the for loop. And so now we'll move on to the final loop that we're going to talk about. Let's create a new file. It's called the while loop. And it's not really a combination of the two, but it is easier than the for loop, at least in my opinion. Let's change the title to while loop, not white, while, and then the syntax. So we have while, we have a pair of parentheses, and then the curly braces. That's it. Now, inside of the parentheses, we have our condition. So while our condition is true, the loop is going to execute. We are essentially going to do the same thing that the for loop did, but we're going to use the while loop to do it. I'm not going to say that the for loop is better for this case, because some people might think that this is a little bit easier to follow, and I would agree with them in that sense. But we are going to start by initializing a counter variable, I is equal to 0, while I is less than the count of favorite guitars. We're going to echo our guitar. Now, the issue here, and the issue really with the for loop too, is if you don't increment I, you get a loop that never exits. So let's go to while, and we have vela, 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 vela. And you can see that it's still going. It will continue to fill out vela, 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 because we did not increment I here. So that is an issue. Anytime you're using a counter, be sure that you have an endpoint, because you will get a loop that never ends. But this is essentially what the while loop does. It executes the code inside of our loop while the condition is true. Now, there's one other loop called a do while loop. And I have to admit, I've used a do while loop maybe 3 times in my entire career, and it's been almost 18 years since I've started my career. So that is a long time to go with just a few uses of do while. So we're not going to talk about it, at least right now. Functions are one of the most important parts of any programming language. In fact, throughout this entire course, we have used functions in every lesson. We have used echo religiously, and we've also used printr. Now, we didn't use printr very much, but we did so whenever we wanted to see the structure of an array. But these are things that provide useful functionality. They are there so that we don't have to write the code that make them work. Like, for example, echo. In order to write something out to the page, or to the HTTP response, if you will, we just have to use the echo function. We then pass in whatever data that we want to display within the page, and that's it. But the code behind the echo function, the code that is actually executed when we call the echo function, well, let's just say that there's more than one line here. But the echo function makes it simple so that whenever we want to write something to the output, we just call echo. Well, that is what a function is. It's code that we want to reuse that provides some very specific functionality, and we have the ability to write our own functions. Like, for example, let's say that we want to write a function for addition so that we can pass in some numbers and it will, add them together. Now, I know that we can do that very easily on our own. We can just say 1 plus 2, and that would give us the value of 3. But let's write a function to do that, so that it would look like this. We would say sum, because that's a good name for a function that adds numbers together. And then we can pass in the numbers that we want to sum, 1 and 2, and that would give us 3. So let's write that function. we start with the function keyword. Every function starts with function. And then we have the function name. So we are going to write a function called sum. That's what we call it. After the function name, we have a pair of parentheses and then a pair of curly braces. So we've just written a function. Now, it of course doesn't do anything, but it is there. But let's go ahead and do this. We have that result variable. Let's go ahead and let's see what we get. So we're going to output result. And whenever we view this in the browser, we don't see anything, of course, because the sum function doesn't do anything yet. So the first thing we really need are the values that we are going to work with. We are passing two numbers to the sum function, so we need some way to denote that we are getting data so that we can work with that data. So we have what are essentially variables. We call them parameters, but they are variables. They are variables for a function. So you have the function name, you have a pair of parentheses, and inside of the parentheses, you have what's called the parameter list. These are the parameters that this function is expecting in order to perform its work. So I've called these parameters A and B, but we could call them whatever we want. We could have number 1 and then number 2, if that's what you really wanted to do, but A and B is going to be fine. So inside of the sum function, we need to work with that data. We need to add them together. So we say A plus B, but that's not enough. We have performed the addition operation, but we need to return this result because right now it doesn't do anything. It just adds them together. So we have what's called a return statement. We say return and then the data that we want to return. So now, whenever we call the sum function, we pass in 1 and 2. That's going to give us the result of 3, and we will see 3 in the document. Now, I want to point out that I have reused the same name here. We have a result variable inside of the sum function. We have a result variable outside of the sum function. Now, even though they have the same name, they are two different variables. The variable that we have inside of the sum function is called a local variable. It is local to the sum function, and it is only accessible inside of that function. And this result variable is called a global variable. It is outside of a function, and it is completely separate from this result variable. Now, I should also point out that whenever we have called echo, we haven't used parentheses. We've just had a space and then whatever data that we wanted to send to the response. And here, whenever we call the sum function, we have the parentheses there. Well, what gives? Well, I've been calling echo a function when really it's not a function. It's a construct of the language, but it's just easier to say it's a function. So when you use echo, it's actually easy to get away without using parentheses. And if you use parentheses, it's still going to work just fine. But that is the main difference as to why whenever we use echo, we don't have to use parentheses if we don't want to. Whenever you call a function like sum, you have to use the parentheses. That's how you execute or run that function. So we have a function that accepts information and then it returns a value, but not every function is going to return a value. There are some functions that just perform a specific task. So let's write a function to do that. Whenever we have used an array, let's go ahead and create an array. Let's use our trusty guitars array again. We'll have our Vela, our Explorer, and then our Strat. And whenever we wanted to see the structure of that array, we used print R. So let's do that. We'll use print _R, pass in our guitars, and then whenever we view this in the browser, we are going to see the structure, but it's not formatted, at least whenever it is rendered in HTML. In order to see the actual structure, we have to view the source, and there it is. Wouldn't it be nice if we had a function that would wrap whatever it is that we are using print R with pre-tags, so that it would look something like this. We would have an echo and pre, and then we would have print R, and then after that, we would have echo, and then our closing pre-tag. And whenever we go back to the browser, there we have our formatted array structure. Now, the thing about this is every time we want to do this, we would have to write these 3 lines of code. We would have to have our opening pre-tag, we'd have to call print R and then pass in whatever data that we were going to work with, and then have our closing pre-tag. So we could write a function that would simplify that. So this is a perfect example of what the echo function or the echo command does. So let's do this. We're going to create another function called output, and we are going to work with some value. The printr function works with any type of value. It's not just arrays. It's just that we've been using it with arrays. And so in this case, we are going to use a pre-tag. We're going to echo out the opening pre-tag. We will print R, whatever value, and then we will echo the closing pre-tag. So that down here, this is all we have to do. We will call output and then pass in our guitars array, and we will have the same functionality. So we go back to the browser, we refresh the page, and there we go. So we have simplified our 3 lines of code into one. So that's now any time that we wanted to use this output function, we could. And that is something that we would probably put inside of a utility file so that anytime that we wanted to check a particular value, we could do that. So when it comes to functions, at the basic level, they are pretty easy to understand. You write a function by using the function keyword, giving it a name, and then any parameters that it may need, and then the code for that function. But there's some more complexity to functions, such as scope, and we very briefly touched upon it whenever I was talking about the variables called result. Well, that all works because of something called scope, and we are going to look at that in the next lesson. In the previous lesson, you learned about functions, and in fact, you wrote a couple of functions. You wrote a function for adding 2 numbers together because it's so difficult to do that without a function. And then you wrote a function for outputting a value of some kind. It uses the printr function, but it wraps that with a pre element so that it looks nice as it is rendered in the browser. Well, one of the things we very briefly talked about was the fact that we had 2 result variables. We had one inside of the sum function and one outside of the sum function. And I had mentioned that what we had inside of the sum function was called a local variable. Result is local to the sum function. I also used the term scope. Now, first of all, what is scope? Well, it's actually quite simple. Scope is the visibility of a variable. So the scope of this result variable inside of the sum function is local scope. It is viewable inside of the sum function and not outside of it. So therefore, it is a local scoped variable. And the same is true for the A and the B parameters, because those are essentially variables as well. So anything that is defined inside of the sum function is local to the sum function, and it cannot be viewed outside of that function. However, this result variable is a global variable. It is viewable globally, at least as far as this particular file is concerned. So let's look at this. I'm going to create a new variable called greeting, and it's just going to be hello world. And this isn't going to make any sense, but this is for demonstrative purposes. Inside of sum, we are going to say echo greeting, just so that we can see this work. So let's go to the browser, let's refresh. Now, you're going to see this fatal error. Don't mind that right now, because whenever I call the output function that we wrote in the previous lesson, I'm not passing anything to it. And that's why we have this error. It says that there are too few arguments to the function output. So the output function is expecting a value, and since we didn't pass a value whenever we called output, PHP is saying, hey, there's a problem here. Now, we could easily fix this by giving this what's called a default value or a default parameter. If we say our value parameter has a default value of an empty string, that error goes away. But in this particular case, we don't really want a default value. If you're not going to call the output function and not pass anything to it, well, then why call the output function at all? So default parameters are a nice feature, but I can't really tell you when you should and when you shouldn't use them. That's up for you to decide. Does it make sense for a function to have a default parameter? Then by all means, use a default parameter. Okay, so I'm sorry, I got off track there. So, okay, undefined variable, greeting, on line 7. That is our echo statement. So even though greeting is a global variable, and I said that if something is a globally scoped variable, it is viewable globally. We should be able to see that inside of some. But by default, we can't. We actually have to say that, hey, I know that there's this global variable out here and I want to use it. So inside of our function, on the first line of the function, we say global and then the variable that we want to use, greeting. So now, whenever we go back, we see the contents of that variable, hello world. So we can have multiple global variables. If we had a global variable 2, we could do that. We could say global and then as many global variables as we wanted to use inside of this function. So even though something is considered a global variable, it is only usable inside of a function if we explicitly say that we want to use it. So that's the first thing I wanted to show you in this lesson. The second thing is a little bit more complicated. Now, let me first of all say that what we are going to do is kind of pointless in the fact that we are going to write a function that does the same functionality of a built-in function already. It's called array column. So let's first of all define an array. It's actually going to be an array of arrays. So this is going to be an array of guitars, and each item within this array is going to be an associative array, so that each guitar is going to have a name. So we'll say name as the key. The value will be the actual name of the guitar, so Vela in this case. Then we will have manufacturer. I hope I spelled that correctly. And then the value is going to be, whoever made the guitar. So in that case, it's PRS. And we will have 3 guitars so that we have our Explorer and the manufacturer is Gibson. And then we will have our Strat and the manufacturer will be Fender. So this is our array of arrays. And the array column does this. It returns an array, but we pass in the array that we want to work with. And then we pass in the name of the key that we want. So if we wanted an array that contained just the names, we would call array column, pass in our guitars array, pass in the name key, and then that will give us an array of all of the names. So down here in output, we'll say guitar name, and then we will see an array that has the names of those guitars. If we change this to manufacturer, then we would say just the manufacturers, PRS, Gibson, and Fender. So we're going to write a function that's going to have the same functionality. I just wanted to point out that it's kind of pointless for us to do that because we already have that ability built into PHP. But this is a very good example for something else that we need to talk about as far as scope is concerned. So I'm going to call this function pluck, because that's essentially what we are going to do. And this type of functionality is very useful regardless of what language you're using. Many languages and many utilities for those languages have something either called pluck or something that does what pluck does. So let's first of all write how we would want to use pluck. So we'll say guitar names equals, and it's actually going to look a lot like the call to array column. And the reason why I wanted to point this out is because as you're writing your code, what is important is that you write your code how you want to write it. So as you're writing and you come across that, okay, I need a function to do something, just go ahead and write how you want to call that function. You end up with cleaner code if you write the code that you want to write and then worry about the implementation later. So we're going to write a function called pluck that we pass in an array, and then we pass in the key that we want to get. So we have function pluck, and then for our parameters, we'll have an array, and then we'll have the key that we want to retrieve. Now, as far as this actual function is concerned, we can write this in a couple of different ways. Regardless, we're going to have to loop over our array, because that's really the only way that we can get each name or the manufacturer. But how we loop is going to be the difference, because we could use a for each here. But PHP has many built-in functions that work with arrays that have their own internal loop. And many developers like to use these functions instead of looping because they think it makes your code easier to read, and it makes sense. I'm not going to tell you whether or not that's true. That's up for you to decide. But in this case, we're going to use a function because it allows me to demonstrate different things about scope. So the function we are going to use is called array_map. And I'm just going to call it the map function because map is very common. It doesn't matter if you're using PHP or JavaScript or C# or Ruby. Doing something called mapping is something that you will do a lot of regardless of what language you're using. And the premise is this: we are going to give the map function an array to work with, and it is going to return a new array. But the contents of that array depends upon whatever we tell it to. And I know that that doesn't make a whole lot of sense, but maybe some code will. So what we need to do is we need to write a function, and we're going to tell the map function what our function is so that it can execute our function. And it's going to loop over our guitars array. It's going to run that function on every item. So we're going to start with a function called return_name. And in order for the map function to work with our function, it needs to pass in the item that it's going to work with. So once again, every time it goes over our guitars array, it's going to pass each item to our function. And we want the name. So in our return statement, we specify the value that we want to be in this new array that the map function is going to create. So we have our item, we want the names of those guitars, so we are going to return item with the key name, and then that's going to give us our new array. And so now we just need to tell the map function what the name of our function is. And we do that with a string. We say return_name. It's going to find this function and it is going to execute it. So whenever we go to the browser, we have an undefined variable result, and that is because I can't type. What's the other? Undefined variable guitar name. That's down here in the output. So we have guitar names now, and let's change this other commented variable. Okay, so let's refresh the page, and now we have our desired results. We have Vela, Explore, and Strat. However, if we come down here and we call pluck, let's change this to manufacturer. We go back, let's refresh, we still just have the names. Now, the reason why is because we have hard-coded that we want the name key from our array. And if we wanted the manufacturer, well, then we'd have to change that here. We'd have to do manufacturer. But that's not what we want. We want our pluck function to return whatever it is that we specify. So this particular solution isn't going to work because there's no way for us to get this key variable from our pluck function into our return name function, because key is local to pluck, it therefore cannot be seen inside of return name. So this isn't a solution. Instead, we're going to use what's called an anonymous function. And it's just like it's named. It's a function without a name. So we have function. After that, we have our parameter list. And so the code itself is going to look very similar to what we just wrote, except that it's not going to have a name. So we return the item. We want our key here. And now let's go back to the browser. Let's refresh, and we should see our manufacturers, right? Well, no. We get some notices. And that's because this key variable that we have used inside of our anonymous function is not in scope. So as far as this anonymous function is concerned, this key variable is something like a global. So just like whenever we specified that we needed to use a global variable, we kind of need to do the same thing inside of our anonymous function. But we can't come in here and we can't say global key, because key is not global. Now we're going to get less notices. That's at least an improvement. But the issue is that we don't have a global variable called key. So instead, we have a use statement. After we have function and then our item parameter, we say use, and then we specify the variable that we want to use. So we are essentially doing the same thing. We're saying that we want to use this key variable inside of this function. It's not global, but it's still not in the scope of this function, so we need to opt in. We need to explicitly say that we need this variable. And so now, whenever we go back and refresh, we get the desired results. We have the manufacturers here. If we change this back to name, then we will see the names. So scope is, I'm not going to say it's a funny thing. It can be a confusing thing. We have local scope. And if a variable does not exist within that local scope, then you have to import it some way. If it's a global variable, you have to use the global statement. If it's not a global variable, but it is on the same level of scope, like for example, this anonymous function is essentially on the same level as key. They are inside of pluck. And so in this case, we can't use global because key is not global. Instead, we have to use the use statement. Unfortunately, only practice is going to get you used to not only working with scope and variables like this, but also getting used to seeing code like we just wrote. Anonymous functions can look a little funny and maybe even a little scary whenever you're starting working out, because you're used to seeing functions by themselves with their own names. However, the more used you get to seeing anonymous functions, the easier it is to work with them, and actually the more you will want to use them as opposed to named functions. Throughout this course, we have gone from our files containing just a few lines of code to files that contain many lines of code and HTML, and it's getting a little unruly. So what we need to do is take some time to clean this up, and we're going to do so using two functions. One is called include, the other is called require. And these two functions allow us to bring in other files. So in the case of our markup, there is several of these elements that we don't really touch at all. They are just there for the sake of our page's layout. Like for example, if we cut out the dot type and really all the way to this div element with a class of container, this is all just fluff. It's where our header is, and that's it. We don't change anything other than the value of the title variable. So what we could do is we could cut this out and put it inside of an external file so that we can include that in all of our other pages. So that, for one, the main page that we're working with is much cleaner. We don't have as much markup that we have to go through. But it also allows us to make changes across multiple pages by just changing our header, if that's what we need to do. So we are going to create a folder in the htdocs folder. We're no longer working within just 2.8 right now. And we could call this include or includes or inc. Many people choose any variations of those, and I'm just going to go with inc because that's what I typically see. And we're going to create a new file called header.php. And we're going to just copy and paste that stuff in there. So now inside of our file for this lesson, we can come in here and we can say include, and then we just need to specify the path to that file. Now we are in 2.8. We need to go to htdocs and then to the inc folder. So our path is going to be // that takes us back to htdocs. Then we have inc, then we have header.php, and there we go. So now we can go to the browser, let's refresh the page, and everything's the same. Even the wrong title, we see scope being used here. So we need to change that in includes. We'll change it to includes, refresh, and we see that change. So even though this title variable is declared inside of this main PHP file, we are still able to use it inside of header.php because it is in the title element. It's also inside of our navbar there. So this kind of ties into the previous two lessons where we have talked about variables and global variables and scope. We have defined the title variable as a global variable. Therefore, it is globally accessible, and we are able to use that inside of a completely different file without any issues at all. Now, let's go to that page. We need to go to inc header.php, but we're going to see a notice here that there is an undefined variable title. So we are directly trying to load header.php, and title is undefined. And that makes sense because as far as the header.php file is concerned, there is no title variable at all. The only reason why it works here inside of includes.php is because we have defined our variable here and we are including header.php. So what we could do is this, if we wanted to. At the top of header.php, we could check to see if that title variable is set. So we're going to say if not is set title, then we will set title equal to an empty string. Now let's just talk about this for a minute. The isSet function is going to return true or false. If title is set, it returns true. If title is not set, then it returns false. So we want this to execute if title is not set. But if isSet returns false, this code is not going to execute. So what we have to say is not isSet. The not reverses the condition. So if isSet is false and we say not isSet, then it's going to turn that into a true statement. It's kind of like English. If you have a sentence with two negatives, it makes it a positive. Well, it's the same way in programming. Two negatives make a positive. And let's close out this code block. If we go back to header.php, now that notice is missing. Now, whether or not that's what we really want, I'm going to leave up to you. Do you want to see the notice if you are missing the title variable? I mean, that could be very beneficial. If for some reason you include header, but forget about the title, well, you might think, well, where's my title? And it might take you a few moments to realize that, oh, I didn't set that title variable. Whereas if you have a notice, it's immediately clear as to what the problem is. There is an undefined title variable. You need to set it. So I'm going to comment this out because as far as I'm concerned, I would much rather see the notice so that I know that I need to fix that as opposed to scratching my head wondering why something doesn't work. Okay, so we have included a header PHP. We need to do the same for the footer. So let's go to our includes.php file. Our footer is really just the closing body and HTML tags. So let's cut those out. We're going to create a new file inside of our inc folder called footer.php. We'll paste that in, and then we will essentially do the same thing. We will include a file, and in this case, it will be our footer. So let's have another PHP code block, include our footer.php. So let's make that change, and we'll be good to go there. So now let's focus on our PHP. Now, as far as this particular file is concerned, we are outputting the guitar names variable. So the guitar's array and the guitar's name, or guitar names arrays, are really what we are working with in this file. So it's really okay that these stay here. But everything else doesn't need to be in here. The output function doesn't, and the pluck doesn't. And really, we could just go back to calling the array column function, but we'll just leave it as pluck for now. So what we can do is take out all of this extra code that we still want to use, but really these are utility functions. These are functions that we could use in many other files. So it makes sense that we put them in a new file that we can then bring in whenever we need them. So inside of our INC folder, we're going to create a functions.php file. Let's open up a PHP code block. Let's paste in that code. And that's really all that we need to do. Although with our sum, let's go ahead and uncomment sum. Let's get rid of where we bring in and echo greeting because we don't need that there. And let's clear out everything else. And we'll keep the pluck function just so that we have more than two functions. So now we want to bring in this functions.php file into our includes.php. And we can do that with the include. But I would say that this is something that we definitely need to make sure works. Because, markup, it's okay, really, if it's not there. But in order for this page to really work, we have to have the output function. We also have to have the pluck function. So we need to be absolutely sure that the functions.php file is brought in. So we're going to use a function called require. It does the same thing that include does, but this is going to give us an error if it cannot open up the file that we specify. So I'm saying functions2 here, which definitely doesn't exist. So if we refresh the page, we get a fatal error that it could not open the required file functions2.php. So it's going to immediately fail because it can't find that. So that is what we want. We want to make sure that we have the functions that we need so this page will work. Otherwise, we don't want anything to happen. So we will change that back to the real functions.php file name. We'll go back and refresh, and there everything works again. Now, there's one other function called require once. And when it comes to something like functions.php, this is really the function that we want to use. Because what this does is it requires that file just once. No matter how many times we call require once and then pass in functions.php, it's only going to bring that file in once. This is very useful because you might be using this functions.php file in another file that you include. Like, for example, if for some reason we need to use our functions inside of header.php, we would have require once in here as well. Although in this case, we just need to specify functions or / functions because it's inside of the same folder. But if we said require in here, and then we said require inside of includes.php, then it's going to bring those two files in, although in this case, that failed. So let's go to header. Let's just take that out. Let's try functions.php, and there we go. Now, see, here we have a fatal error. Cannot redeclare pluck because it was previously declared. So this is where the require once will come into play. If we say require once, then everything's okay. It's only going to bring that file in once so that we don't have to worry about, well, did I include this file already or what did I do? What did I do? With require once, you don't have to worry about that. So we have just cleaned up our files. All of the HTML that we don't change is inside of our header. All of the footer HTML, which was just 2 closing tags, is in the footer. And all of our functions are inside of a functions.php. One of the most important things of not just web applications, but applications in general, is handling user input, because that is how we make our application do what it is supposed to do. If we are writing a website for a storefront, we need to handle user input so that we can display the correct products. If we are writing a blog engine, we need to handle user input so that we display the appropriate blog entries. And things go on. In this lesson, we are going to talk about GET requests, because these are the most common requests that are made to any web application. Just about anything that you do by default within the browser is going to issue a GET request. So if you type something into the address bar, press enter, that's going to issue a GET request. And a GET request is really just us requesting to retrieve information. There's no side effects or anything like that. We just want information from the web server. So we just made a request to php.net, and the server responded with what we see here. If we click on any one of these links, like documentation, that's going to issue another GET request, and then the server is going to respond with what we see on the screen. So GET requests on the surface are very simple. And really they are simple. It's just that since they involve user input, we have to be very, very careful. Because the first rule, and really the only rule about user input, is to not trust it. And it doesn't matter if it's a web application or a conventional application running on the desktop. Any information that we do not control, we must assume is malicious, because that is the only way that we are going to protect ourselves and our application from any type of malicious intent. So, the primary way that we get information from a GET request is from what's called the query string. Let's go to google.com and let's do a quick little search for PHP. If you look at the address bar, you have www.google.com, then you have /search, that's the resource that we made a request to, but then there's this question mark. Well, everything after the question mark is what's called the query string. It contains a series of key value pairs that the web application is going to do something with. So the source is HP, I don't really know what that is, but the Q equals PHP. So Google's web service is looking for this Q query parameter, and it's going to take that value and then perform a search on that value. So that is how Google's web servers know what to search for. The request being sent to their servers has this Q in the query string, and it is set to PHP. So, of course, our application doesn't look for any of these query parameters by default. We have to program that in. Of course, it's there available for us if we want to access it, but we have to write the code that's going to look for those things and do something with those things in order for our application to react to those things. So let's say that we are going to write a store. And in order to display an individual product, we need to know the ID, or the way that we identify a particular product. And for the sake of simplicity, we are going to have a query parameter just called ID. So let's go to the browser. Let's make a request for this. By the way, I'm in folder 3.1. The file is get-input. And we are going to add a query string here. So we have a question mark followed by ID, because that is the query parameter that we are going to look for to get what product to display. Or I'll tell you this, let's do product ID. That way it's a little bit more clear as to what we're looking for, and then we can just type something. Let's just have the number 10. Now, if we press enter, we made a request to our PHP file with that query string, but of course our application isn't looking for that. So let's go back to our file, and we are going to create a variable called product ID. And we get that value with what's called a super global. And I'll show you why it's a super global here in a moment. But it is underscore get. And this is an array that contains all of the keys in our query string. Our key is product ID. And that is going to give us our product ID. So we can output that down here. So we will use the shorthand syntax to output product ID. And there we go. So let's go back to the browser. Let's refresh the page and undefined index product ID. And that's why I used camel casing. Let me get this on screen. I used camel casing whenever I specified the key with the get super global. And in the query string, it's all lowercase. So it is case sensitive. What you type in the query string has to absolutely match what you type in your code. So let's go back. Let's change that to make this all lowercase. And now we will refresh the page and we see the value of 10 there. Now we can change this to whatever. If we had a product ID of just some letters, a dash, number, and some more letters, we are going to see that absolute value there. But let's also do this. Instead of a product ID, let's say that we want to display all of the products of a given category, and we want to limit the amount that we show on screen. So we'll have category equals, and then whatever category ID, let's go with 10 again. And then for a second query parameter, we use an ampersand, and then limit equals, let's say that we only want to show 2. So, well, let's make that request. First of all, we get a notice here because we are trying to find product ID inside of our get superglobal and it doesn't exist. So we're going to have to handle that later on. But let's do this. We're going to get our category and then we want to get the limit. So we'll just call these variables category and limit. We will use our get superglobal and get those values. So now we can do this. We will say showing category and then our category. And let's have a period, limit, and then we will output our limit as well. And when we go to the browser, we see showing category 10, limit 2. And of course, these values are going to change as we change the values in our query string. So if we want category 1, limit 30, then that is what is reflected here in the document. So I said that I would show you why these are called superglobals. So let's copy these 2 lines, but let's first of all initialize these variables as empty strings so that we have them created. And then we're going to write a function that is going to set these 2 variables. So let's just call this set values. And these are global variables, so we need to say global, category, and limit, and then we're going to set those. So now let's call set values, and we will see the same results. Category 1, limit 30. Now notice though, that whenever we specified the global variables that we wanted to use, we didn't specify get. We just specified category and limit. So that's why these are called superglobals. They are accessible throughout our application. We don't have to opt in to use them. They are just there for us to use all of the time. So that is why they are called superglobals. Okay, so we have established that whatever is being given to us through the URL for a GET request is the user input, and we can do something with that information. But now watch this. I am going to put a script here, JavaScript. We are going to alert hello world, actually, hello cross-site scripting. So XSS, and we need to close that script element. Now Chrome is not going to allow us to do this. If we make that request, it says that Chrome detected unusual code, and it's just not going to let us. Let's go to Edge, and let's make that same request. So once again, I have specified HTML as the limit, so that if the user wanted to inject their own JavaScript into this page, They could. As you can see right here, we see an alert box saying hello XSS. And that is a huge, huge security concern. And this is why I say you should never trust user input, because anybody can come up here and they can make a request, they can pass in whatever information that they want, and if we don't take the steps to protect our application, then our application is going to be the launching pad for attacks. And don't think that your application is small enough that it could be ignored. You need to protect yourself. So anything that comes in via user input needs to be validated. And PHP gives us several tools for doing that. So here we have category and we have limit. And we know that these two things are numeric values, and they aren't just numeric, they are integers. That means that they are whole numbers. So we have the ability to perform validation on these inputs so that we can make sure that they are integers, and if they're not, then we can say, hey, nope, not going to do it. So we are going to call a function called filter_input. And this accepts several arguments. The first is the type of input that we want to validate. So that means it's either a GET request, it's a POST request, we are dealing with stuff from a cookie, or a server variable, or things like that. In this case, it is a GET request. So we say input_get. Then we specify the name of the variable that we want to validate. In this case, that is category. And then we have the filter that we want to use to validate this input. And in this case, it's called filter validate int. It's going to ensure that whatever is passed in through the category query parameter is an int. If it is not an integer, it is going to return false. Otherwise, it is the actual value that we wanted to work with. And we'll just copy and paste this for limit as well. We will change the variable name to limit. Now notice that there are no $signs. It is just the name of the variable itself. So now we can do a check. If category is equal to false, or if limit is equal to false, then we can do something that's called die. Die in PHP means that it stops completely. No more processing is done with the request. So let's go back to Edge if that is still open, and let's make a request for our page that is using the cross-site scripting attack. We press enter, and it looks like nothing happens. Now we still have our header, and let's look at the source, because this is going to tell us what is going on. Well, it's not really going to tell us what's going on. It's going to show us where the PHP page stopped processing. So when it finally loads, if it does load, then we should see there. It ends at the closing tag of nav. Now, the reason why we see that is if we go back and look at our code, well, we have included header, and of course we have required one. So all of this code has executed. But now we have gotten to where we die because the limit is invalid input. So nothing else is going to execute. So it stopped right here, and we see exactly what we should be seeing, at least as far as our code is concerned. And if we go and look at this in Chrome, we can pass anything that is not an integer to limit, and we are going to essentially see the same thing. And once again, if we view the source code, same thing. It ends at the closing tag of nav. But we could also approach this in a different way. We could say that, okay, if category or if limit are invalid, then we can still display the category with a limit. We just have to set some default values. So we can do this. We'll keep this, but we need to break this up into two if statements. So we'll have an if statement for category. If it's false, then we will set a default value for category. So let's go ahead and do that. We'll set it to, I guess, 1. And then for limit, we can set the default limit to 10. And then our code is still going to work. We have still ignored the user input, and that's really the most important thing. The most important thing is that we have caught invalid input and we are not using that input. Instead, we are replacing it with our own. So now, even though we have invalid input, we still have some action going on. And if we change the category to, let's say, category 100, we can see that category 100 is still there, but our limit is still 10. Now, if we omit limit, we are still going to see limit of 10. So in this case, we don't have to check to see if we have a limit or a category. The filter input is going to handle all of that for us. If it's there, it's going to validate it, and if it is valid, we get the value. If it is there and it's not invalid, we get false. If it's not there, we get false. Now, there are many filters that we can use, and I'm going to put a link to the PHP documentation that tells you all of the built-in filters. There are validation filters, which is what we used. There are sanitize filters, so that you can use them to strip out anything that you might not need. Like, for example, if you need an email address, it'll strip out everything that is not an appropriate character for an email. There's other filters and then filter flags. So this is very useful. The more code you write and the more filters you use, the more you will have them memorized. And you will memorize some of them because there are some that you will use regularly. In the previous lesson, we looked at the get superglobal, and we used it to retrieve information from the URL, or the query string, to be more specific. And remember that I said that GET requests are for retrieving information. We're not using a GET request to make any changes to our data store or to change the state of our application. And we definitely don't want to use a GET request if any sensitive information is involved, like a password or something even more sensitive, because all of that stuff appears within the URL. So anytime that you need to work with sensitive information, or you want to make changes to your data store or to the state of your application, you use what's called a post request, and you retrieve the post information with a superglobal called _post. And it is an array. It works exactly like the get superglobal. We specify our key that gives us our value. So we're done. I will see you in the next lesson. I'm kidding. We need to talk about how you issue a post request. Because in HTML, there's really just one way to do that, and that is with a form. Now, if you are submitting form data with JavaScript, then it's a little bit more flexible in that you can submit a post request that way. But we are primarily just sticking with HTML. So the first thing we need is a form. And there is this action attribute. Now, the action attribute is the file that is going to handle the post request. So if you leave this empty, then it's going to default to the current page, and that page is login.php inside of the 3.2 folder. And in most cases, that's what you want. So we're going to leave that alone. Now we do need to come in here and we need to say method equals post, so that it is going to issue a post request whenever we submit this form. So now we just need some fields, and since we are using Bootstrap, we are going to use some of its organizational classes. So we're going to create a div element with a form group class. We need a label inside of this, and this is going to be for our username or for our email address. So let's say that this is for email, and the text is going to be email. Now we need an input element. The type can be text. We could go ahead and use HTML5's email, but for now we're going to just use text, just in case if we wanted to later on test the filter input, because we could validate this information to ensure that it is an email. And if we set this to email and we try to submit something that isn't an email address, then the browser is going to prevent us from issuing a request. So we're just going to stick with test for now. In a real application, yes, we would want to use email. So we want the name to be email and we want the ID to be email. So we need both a name and an ID for this reason. The value of the name attribute is going to be the key that we use to access that information in our post superglobal. So if we wanted to retrieve the email value, then we would do so like this. And if we changed the name attribute to, for some reason, email2, in order to get that information, we would also need to make that change when we specify the key. So if you omit the name attribute, you will not be able to retrieve that information from the post request. So every field that you want to work with has to have a name attribute. The ID attribute is there so that whenever the user clicks on the label, it gives focus to the form control. So that is why there's both a name and an ID. And we also need a class here. So this is going to be form, not group, control. And that is going to be fine for our email field. Now we need a password, so let's change the type to password. We, of course, need to change the name and ID. We'll just set those to password as well. And the for attribute for our label, and then the text is going to be password. And then we need a button to submit. So let's create another form group, and inside of this, we will have our input element. So, or we could use a button. I just typically use an input element with a type of submit. And we could put a name here, and I will tell you why we could do that and why we might want to do that here in a little bit. But for now, we're just going to leave the name alone. And for the value, we're just going to have as login. So we have our form. Let's make sure that this is going to look okay. Let's make that request. And there we go. Although we can already see that there's a problem here, because I have code up here at the top where I am trying to retrieve something from the post global called email. And it says that there is this undefined index email. Well, the reason why we are seeing this is because I just made a GET request. I went to the URL, I press enter, that's a GET request. So of course there is nothing in the post superglobal. So here's how we can handle this. One of the ways is to check to see if it is a post request. And we can do that by using another superglobal called _server. This contains what are called server variables, and one of those is in all caps request_method. This is going to give us the type of request that was made. So if it was a GET request, this is going to be equal to GET in all uppercase. If it's a post request, then it will be post in all uppercase. So if the server request method was post, then we want to use our post superglobal. So let's just paste that code in. Whenever we go back and refresh, that's now gone. If we make a form submission by clicking on the login button, well, we didn't have anything there. So let's go ahead and type something into the email address. It doesn't matter what it is. And password is going to be password. Whenever I submit the form, well, we're not really doing anything, are we? We need to echo here. So let's echo that email address. Now, whenever you issue a post request and you hit the refresh, it's going to ask you, do you want to issue that same post request? So it's going to take the information that you had just submitted and resubmit it if you click on continue. Let's go ahead and do that because I don't want to type everything again. So there we go. We have the email address that was used. But we can also do something like this. If this is a post request, then we can use our output function and we can output our post superglobal. And then we will see the entire contents of that array. So here we have the array, we have the email, which was that, and then we have the password, which I typed as password. But notice that there wasn't anything for the submit button, and that's because I did not give it a name. Now, in the case of where you have a page with multiple forms, and you want the same PHP file to handle multiple forms, that is where having a name attribute for your submit button would be useful. Because then that way, you can determine which form was submitted based upon the presence of that button name in the post. So we need to make a fresh GET request so that our new HTML is loaded. And let's type in something different. user@user.com, 1234 is the password. So now whenever we submit, we have email, password, and login. So inside of our code, if we wanted to determine which form was submitted, we can just use isSet, and then we will check our post superglobal for that button. That was called login. So if this was set, then we know that we received a request for logging in. And let's just resubmit, and we see our output there. However, if you just have a single form, I recommend the other approach, just checking to see the type of request, because more often than not, that's what is going to be sufficient. And plus, that's just one less thing that you have to manage. If you give your submit button a name and there's only one form in that page, then you have to manage that name. Now, one thing to remember is that this is still user input. It can still be manipulated by the user, and therefore we need to distrust everything that is coming from the user. So the first thing we really need to do is validate this information. So we can first of all check to see if we have a valid email address by using the filter_input function. Except in this case, we aren't going to say input get like we did in the previous lesson. We're going to say input post. And then we specify the name of the field that we want to retrieve, and then we specify the filter that we want to use. So in this case, we want to filter validate email. That way we will ensure that we have an actual email. And we could check if email equals false, then we could display a message. So we could create a variable called status, and we could say that please enter a valid email address. So that's down here somewhere. Let's say after our form, and really after the div element there. Let's give this a class of row. And that's not, well, let's just do this. Div, we'll give this a class of row so that this is on a new line. And then we will check to see if our status is set. So we'll say if is set, and then status, then we will echo status. And we need to close our PHP block. So now let's make a fresh GET request so that everything is reloaded. And let's submit something that is not a valid email address. You can see how many that I've used in the past. So let's just do something like 1234. That's obviously not a valid email address. Password, let's do 1234 as well. Whenever we click on log on or log in, we see that we did not have a valid email address, so we are being prompted to please enter a valid email address. However, if we change this to a type of email, then the browser is going to catch that. However, don't rely upon the browser to do your validation for you, because not everybody is going to be using a browser that supports HTML5 form controls. Always validate information. Even if you think that it's going to be done client-side, assume that it's not. So validate everything. And so the things to remember are that your fields, if you want to work with them in a post request, need to have a name attribute. If you have multiple forms in the same file and they are all going to be processed by the same file, give a name attribute to your submit buttons. And before you start processing post information, make sure you have a post request. If you have just a single form, just a simple check for the request method is sufficient. But if you have multiple forms, check for the name of the button, and then you can process the post information as you need to. Well, in the next lesson, we are going to take this a step further and start implementing a simple user authentication system. And we will keep track whether or not a user is logged in, and we will use the session superglobal to do that. HTTP is a stateless protocol. That means that whenever you make a request to a web server and it sends a response, it completely forgets about you. All it cares about is that you made a request, it responded, and that's it. So even if you make a request a second after your first, it's not going to know who you are. It doesn't care who you are. All it cares about is that you made a request, it gave you a response, and that was it. Now you might think that, well, that's not true. Things like Amazon, Google, Facebook, Twitter, all of these things know who I am, and they know a lot about you. However, there's a difference there. Those are applications. Applications are different from the web server because they actually don't run directly on the web server. They run in some other runtime environment. PHP is a runtime environment. It's an application platform. That's one of the reasons why we have things like PHP, so that we can maintain state in our applications. Otherwise, we really wouldn't have any need to create applications. Because if you can't maintain state, well, there's nothing there. So the whole reason why we have PHP, Ruby, ASP.NET, things like that, is so that we can write stateful applications that run on a web server. So when it comes to PHP, we maintain state with what's called a session. And we have to start a session in order to use a session. And really, we have to start a session on every PHP file where we want to use session data. So what is session data? Well, it can be really anything, but we typically use it to store user information, like the email address and, small things like that. We don't want to store a ton of stuff in the session because it's going to consume memory and or disk space. So we want to store as little as possible. So we have to call this session start function in every PHP file where we plan on using session information. And it needs to be one of the very first things you do. Many developers will make it a habit to be the first line in a PHP file, because it depends upon your PHP configuration and even your version as to whether or not you get an error, because we want to set the session before anything is sent to the browser, including headers. Because depending upon your configuration and your version, if you try to start a session after anything is sent to the browser, then you will get an error. Now, we're not going to get an error here, but it is still a good idea to do it at the very beginning. So get in the habit of doing that. So we are going to start a session, and then we are going to use the email address to determine whether or not a user is logged in. So we're going to do this. We're going to grab the email address as well as the password, and we should validate the password. I can't stress this enough. You need to validate your inputs. However, for the sake of simplicity, we're not going to in this case. We're going to leave the email alone, but let's add a quick little to-do, validate this, because we need to. So we're going to take the email address and password, and we're going to compare it with something, because that's how you authenticate a user. You compare with our data store. Typically, that information would be inside of a database, but we don't have a database yet. So the next best thing is to store that information in a config file. So let's go to our INC folder. Let's create a new file. We'll call it config.php. And we will store our username and password here. So let's open up a PHP code block, and we're going to create what are called constants. These are very special types of variables where, well, it's constant. You assign it a value, and the value cannot change at all within that variable. That's why it's called a constant. And it's very useful for things like configuration. So we're going to create a constant variable called username. Notice that there is no $sign. It is just const, and then the text of the name that we want to use. And by convention, we use all uppercase characters for constants. That way we can visually see that, okay, this is all uppercase, that's a constant. And I'm going to use underscore notation here. You might see something like this used with no underscores, but underscores make sense here. So we're going to set this to something. Let's say that our user is going to be admin@admin.com. And then we'll set another constant for the password. So that's going to be all uppercase once again. And let's make this easy, and 1, 2, 3, 4. That's a very secure password. So these are the values that we are going to compare against. So we will compare our email and password with those values. And then based upon the result of that comparison, we will either set our session to remember the email address or we won't. And that's how we will determine if the user is logged in. So let's write a function that's going to authenticate our user, because really we want to keep our code inside of login.php as clean as possible. So let's have a function called authenticate. We want a username, although really we want an email address and a password. And we want to ensure that we have pulled in our config. So that's in the same path as our header. So let's go ahead and pull in config first. We'll pull in header, and that will also mean that we have that information inside of functions. So let's go to our functions, and we are going to do this. We can say if email equals, and then user underscore name, and password equals password. Then we can return true or false. But we have a condition here, and this condition is going to be true or false based upon whether or not these comparisons are true and false. So instead of doing an if statement and all of that, we can just say return email is equal to username and password is equal to password. If those are true, then of course the overall result is going to be true. If one of these or both are false, then it is of course going to be false. So inside of login, we could if authenticate user. Is that what we called that? I just wrote that and I can't remember what that is. Let's do authenticate user. And then we will use that here. We will pass in our email and our password. And if this is true, then we will use our session super global. And we will set email equal to email. Otherwise, we could, set a status. We already have a status, so we could say that the provided credentials did not work. Something along those lines. And let's use double quotes there so that we don't have to do any type of escaping. And now we need to think about what we do after we authenticate the user. We set our session email value, and then we want to do something. We don't want to go back to the login page. That's kind of pointless. Instead, we want to redirect to wherever authenticated users go. So we could call that file admin PHP. So to redirect, we use a header. It's called location, and you specify the location that you want to redirect to. So to set a header, we use a function aptly named header. Then we set the header. So we say location, colon, and then wherever we want to go, admin PHP. Now, let me say this. This is something that we are going to do more than once as far as just redirection is concerned. Not necessarily redirecting to admin PHP, but if we want to redirect, then we should really write a function to encapsulate this functionality. That way, we don't have to call header, we don't have to specify location or anything like that. We could just pass in where we want to redirect, and we're good to go. So it could look like this. We'll say redirect, admin PHP, and that's a whole lot easier to type. So let's do that. Let's go to our functions, and let's write a function called redirect. We will accept a URL, because even if it's a file name, that is still a URL, and we will simply set that header, although we will include our URL variable, and we need to use double quotes here since we are embedding a variable. So there we go. That should redirect us. And after we redirect, let's go ahead and die. We don't want any further processing, even though there shouldn't be any further processing. But this way we can ensure that there's not, so that we redirect to admin PHP and we're done with this particular request. Now, one thing we do need to consider is that redirect involves setting a header. And before we send any HTML to the browser, we need to set our headers because, well, that's just the proper thing to do. So up here on line 7, where we are including our header, let's take that out and let's do that farther down so that before we include the header, we have everything ready as far as the response is concerned, so that we set any headers that we need to and anything else. That way we are safe. And let's also do a require once for our config, just so that we have that once. And that looks good to me. So let's create a file called admin.php. And inside of this file, we will open up a code block, and we need to session start. So we'll do that. And for right now, let's just echo out our email. So we will use our session super global. We will specify email. And there we go. So now let's go to the browser and let's log in. That was admin@admin.com. The user is 1234. And let's log in. We should redirect to admin.php. We do. And then we see our email address. Now, one thing to note about sessions, they are unique for each unique visitor. So we are using Chrome here. If I open up another tab and we go to admin PHP, guess what? We are still using that same session. However, if we open up an incognito session and we go to admin PHP, well, we're going to see that there's an undefined index of email. So this is not involved in that same session. If we open up Edge, go to the same URL, we're going to see the same thing, that there's an undefined index. So these sessions are unique to unique visitors, and unique visitors are unique because they are using a different browser, essentially. It's not so much that they have different IPs, it's that they are using different user agents. And you don't really have to worry about leakage. If you set anything in a session, you don't have to worry about it leaking into another session, because PHP is going to ensure that those sessions are completely separate from one another. If for some reason there is leakage, then there is a very serious problem. Okay, now what we have here inside of admin PHP, if we go to admin PHP and we are not logged in, we see this. And we don't want to see this. Instead, what we really want to do is check to see if the user is logged in, and if not, we redirect them to login PHP. So let's go to our functions. And actually, no, let's go to our login PHP. We need to copy our files here, the config and functions, and we're going to paste those in. And then we're going to write a function, or at least call a function that we will then write, called ensure user is authenticated. I like this type of function because this checks if the user is authenticated. If so, then it doesn't do anything, but if not, then it redirects them to login PHP. And we can use this at the top of every protected page so that we can always ensure that the user is logged in before there is anything displayed on the page. So inside of functions, we have our function user, or ensure user is authenticated. We will write a function that checks if the user is authenticated. So is user authenticated? And if that is actually false, so if not is user authenticated, then we will redirect. So it's a good thing we wrote that redirect, because here we are using it. And then that really is all that we need to do, because if the user is authenticated, then we don't want to do anything. But we do need this is user authenticated function. So let's go ahead and write that as well. This is going to be very simple. We are going to use is set, and we are going to check if our email key is set inside of our session. If it is, then the user is logged in. If it's not, they are not, and it's that simple. So now, whenever we go to admin PHP and we refresh, we should redirect to login PHP, and that is exactly what happened. But we also need to kind of do the opposite. If we go to login PHP and the user is logged in, we need to redirect to admin PHP. So inside of login, we are going to use that function that we just wrote, the is user authenticated. And notice that I'm using the term is. If you are going to write a function that is going to return a true or false value, then having the name represent that is very useful. Is user authenticated implies that this is going to return true or false, and it of course does. So in this case, we're going to use our trusty redirect. We will go to admin PHP, and it wouldn't hurt to die there. And really, inside of the ensure, we should die there as well. So now if we refresh while we are logged in, then that should take us to admin. If we go to admin while we are not logged in, that takes us to login. And let's go ahead and try to log in here. And 1, 2, 3, 4, and we go to admin PHP. The last thing that we need to do is log out. And this is probably the simplest thing that we will do in this whole process. So I'm going to copy the require ones for our functions, and I'm going to create a new file where we have login and admin called logout PHP. We're going to open up a code block, and the very first thing we're going to call is session start, because even though we are going to end the session, we need to start it first. And then we are going to call a function called session unset. This is going to unset all of the variables that we have set in this session. Then we destroy the session with session destroy. And then we will want to redirect someplace. So we're going to require once, where we pull in our functions. We will redirect back to login, because if we are logging out, there's really no other place that we need to go. And then we will die. So that's it. Let's go, and we will travel to logout.php. That takes us to login. Now we can test this. If we go to admin.php, well, it just redirects us back to login. And that is the behavior that we were expecting. So we now have a simple but a functional user authentication system. And we will use that in our first project, a web-based glossary. Throughout this course, we have primarily been focusing on individual pieces of the PHP language. And while that has been okay, if you're like me, it's just not enough. Going over the theory is okay for getting an idea of how something works, but it's not until you actually start working on a project that things start to click. So we are going to start building a project in this lesson, and we will build this project throughout the remainder of this course. And we will touch on some of the things that we have talked about thus far, and we will also incorporate some new ideas. So classes, working with files, working with a database, namespaces, organization. There's a lot of things that we are going to cover. And in this lesson, we are going to start with organization, because when it comes to a project, the well-organized project is the one that is easy to work with. And that is our goal. We want to organize our project so that it is easy to develop. So in this lesson, we're going to focus on separating concerns. That is a concept that is not just used in PHP or web development, but development in general. The idea is that you have different components within your application that are responsible for doing one thing and one thing only. And the idea is this. We want to take our logic, which is what I'm going to call a controller. We want to take our logic and put that inside of another file. That file will be the controller. And then we want to take everything that is responsible for displaying the output. So all of our HTML, and including all of the echoing out stuff. That is going to be inside of another file called a view. So we have a controller where our logic lives, and then we have the view, which is our display. So these two things, they are going to at least know about one another, but there is not going to be any displaying stuff in the controller. There's not going to be any logic in the view, except for, looping over an array in order to output something or echoing out stuff. So if we look at the login.php file from the session lesson, then we can see the stuff at the top. This would be considered the logic. So we will take that and put it inside of a file, and then we will take all of the markup and put that in another file. So inside of 4.1, let's create two files. The first is going to be index.php. That is going to be our controller. And then we will have another file called index.view.php. Now you could say index.html.php or index.templates.php, but view is the term that is used industry-wide, so it makes sense to use view. And the basic idea is nothing new. It is something that we have used really ever since we started using templates in this course. And that is, if we look at login.php, we have set this title variable, and then we have included this header.php, and then that title variable is used inside of header.php. So we are essentially going to do the same thing in that inside of our controller, we'll have our title, and let's just do hello world for now. And then we will include our index.view.php. And then inside of index.view.php, we will simply echo hello world, or not hello world. We want to echo our variable. So if we go to the browser and let's go to index, we see hello world. So that's pretty simple. But you know, since we are talking about organization, it makes sense to organize our files into folders that are similar, so that if we are going to have multiple views, well, we need to put those inside of a folder called view, so that anytime we need to work on a view, we know right where to go, to the views folder. So we're going to create a new folder inside of 4.1 called views, and we will move our index view into that folder. So now, whenever we include our index.view.php, we have to say include views index. And really, let's do this. Let's do require there. So now, let's just make sure this works. It does. So we're on the right track. Now, I don't really like this for a couple of reasons. For one, whenever we have a controller in a view, we are going to have to do this in every file. We're going to have to require views / and then the view name. I would like to make this as simple as possible so that we could do something like this, view, and then we could specify index. And then the view function would then be responsible for tacking on everything else and actually doing the require. So let's create a functions file. And functions.php, yeah, that ended up in 4.1. And we will have a code block, and we will have a view. We will get our name as the parameter, and then we will require, and let's do this. We will say views, and then name.index.view.php. And so if we save this, we need to go back to index, and we need to require our functions.php. And we no longer need this require because our view function is going to take care of that. So let's go to the browser, let's refresh, and we see undefined variable title. But why? Why doesn't that work? It's a global oh, if you forgot about it, don't worry, I did too. Global title. We need to import that to the function. So now when we refresh, we see what we expected to. Okay, but this is a problem because we're going to call view multiple times, and it doesn't make sense for us to come in here and add every single global that we are going to use. That's just not sustainable. So instead, we can give this function another parameter. And this is how we will get data to this function so that it will be in scope for our view. And we have to keep note of this. I'm going to call it model because that's essentially what this is. A model is, well, it's the data that we are going to be displaying. The model is another term that is used industry-wide. So we're going to have this model variable inside of our view. So let's go ahead and go to our view. Let's change this to model. And then we are going to call our view function, and we are going to pass in that model. So in this case, that's simply title. Now, whenever we refresh the page, we still see hello world. And of course, if we come in here and we say hello model, and refresh, then we of course see that change reflected here. So this is great. And so let's do this. Let's take some of the includes that we have been using, like header, and let's include them. So we're going to go to login.php, and we're just going to copy all of this markup, and let's paste it inside of our view. And then we will do this. Now, unfortunately, we have just lost our title variable, but that's okay. We can eventually change that, but for right now, let's get rid of all of the stuff that we have in our content, or at least most of this. And then for our h1 element, we will use our model here. So let's output that here. We will use our shorthand, and we will say model, and there we go. So if we refresh the page, we are going to see the undefined variable title. That's okay for now, but we see hello model. Okay, so we have somewhat of a solution, but it could be better because I don't want to include the header and the footer in every single view. That's just something that I am going to forget, and I don't want to have something that I'm going to forget. So what we could do is use what's called a layout page. A layout page is essentially a template, but it's a complete template. It's not broken into individual files like our header and our footer. So inside of our views folder, let's create a new file called layout.view.php. And we are going to take the contents of the header file. So let's grab that and paste that into our layout view. Let's get rid of the PHP because we don't really need that, although we still want access to our title, at least for right now. And the footer was just the closing tags for body and HTML. So we'll just go ahead and add those in there. So now we need to incorporate this, because what we will do is have our content here. So basically, our content is going to be our view, in this case the index view. We can get rid of the header and the footer because now we are going to rely upon that layout page, and our view is simply going to be this. So there's nothing that we have to forget. We just have our markup, we start using our data, and then we're good to go. But we have to make this work. So instead of bringing in or requiring the named view inside of our view function, we will instead do this: require layout.view.php. And then inside of our layout view, we're going to require the actual view. Although we need a PHP code block there, don't we? So let's do that. We will require. Now in this case, we don't need the views prefix because we are in the views folder. And so we will just require the name. And then everything is just going to flow on through. So let's see if this works. And it does, although we are still missing our title variable. So let's address that. Now, we don't want to use something as generic as title, because there is going to be some information that we want to bring, not necessarily just into our layout page, but we might also want to specify some arbitrary information that would still be used in the view, but it wouldn't necessarily be the data that we pass to the view, kind of like what we've done here. So instead we could, have something called a view bag, or something along those lines. I apologize, a view bag. And this could be an array, so that then we could add in, whatever we need it to. So if we wanted to bring in a title, then we could do that. And in this case, we could say, what was the title? Hello World. Or that's too close to hello model. Let's say this is the title. And then we could use that inside of our views. So let's go to our functions. We of course need to say global and then bring in that view bag. But then that would give us access to it inside of our layout. So that instead of using our title variable, we could say view bag and then title. And then we would essentially do the same thing everywhere else. And this would also be used, I think we used it inside of the index view somewhere. No? Okay. So let's go to the browser, let's refresh, and there we have, this is the title, we have the hello model. But, there are going to be some pages where we might not set anything in the view bag. So let's comment that out. Let's comment out this other line, and let's refresh. We don't get an error, so that's okay. Although we might need to address that at some point in the future. So we have just organized our application into two pieces. We have the controller, and then we have the views. And we are just going to have to keep going from there. So in the next lesson, we are going to start looking at working with files. We need to know how to open up files and read files and write to files. And so we will do that in the next lesson. Our project is going to be a glossary, one where visitors can view a list of terms and their definitions. They will also be able to search for a term in order to get a definition, and we will also have an admin section so that we can log in order to manage our terms. So we need to store data, because otherwise, how would we have an application? So we're going to start by storing our data as JSON inside of a file, so that we will store it within a file, we will read it, parse it into something that we can use in PHP, and then we will also serialize that data back into a JSON structure so that we can save it. And then eventually we will migrate to a database. So we need to first of all know how to work with files. So let's do this. Let's simplify this. We'll pass an empty string as the model to our view. Let's get rid of title. And let's just not work with our view bag for right now. And let's say that we are going to get our data by calling a function called getData, for the lack of a better term. And we could specify a file name here. But that's not really what we need for this particular application, because the only file that we are going to be working with is our data file. We aren't going to be opening up several different files so that we would need a generic function. Instead, we need just one for opening up our data file. And the name of our data file is best served by putting it inside of a config. So let's create a new file. We'll call it config.php. And now we are starting to see a growth in our files. And the more that our files grow, the more we need to think about organization. Because right here, we are requiring two files, our config and then our functions. And that's really okay inside of our index.php, but as we add other controllers, we're going to have to require the same files over and over and over again. And then as we add more files that we need to require, well, things begin to get out of hand. So what we could do is create a file that is going to serve as our application file. It's something that we will put all of our require statements into. So that we will do this. We will grab the require statements and the opening PHP block. We will paste that into app so that inside of index, all we have to do is require app.php and we're done. That way, any other controller, we just have to require one file and we're good to go. As I said in the previous lesson, I don't want to have to implement anything that I will eventually forget. So this way, I might forget to require a file, but at least it's one file and it's not multiple files. So this means that we need to organize our files a little bit more, because we are definitely going to have more files that we want to require inside of app. So it makes sense to put all of these app-centric files inside of another folder. So let's create a folder called app. We will move app and config, and well, I can't multi-select names, unfortunately, but we will move app, config, and functions into app so that then whenever we include app, we just need to say app/ and then app.php. So our application is now a little bit cleaner. Okay, so we have a function name called getData. So let's write that. And we're going to, first of all, need the file name. So inside of our config, in the past, we have used constants, which are good. But we've had individual constants like username and password. And in this case, we're going to have a data file name as well. So it doesn't make sense to make multiple constants here. Instead, we can do an array. So we can say const config equals an array, and then we can have a key that is data underscore file, and we could call this data.json. And then if we wanted to store our user information as well, we can have a user's key, which would then be another array where we have keys that would be the email address, admin@admin.com, and I believe the password for that user was 1234. And if we had another user, we could come in and add the details for that other user. So this gives us a little bit more organization, at least as far as our config is concerned. And we don't have to worry about managing multiple constant names. So now, finally, let's get back to our functions. And let's write that function. It was called get_data. Now, there are two ways that we can go about doing this. The first way is a long way, and we will look at that code, and then we will refactor so that we can do it with much less code. So the first thing we want to do is check to see if the file exists. So we have a function called file exists, and we pass in our file name. And let's create a variable called fname, and we will get our config's data file key, or value rather, and we will use that variable. That way that's easier to type. So if the file doesn't exist, then we want to create it, and we do so with a function called fopen. Now I know that the name is fopen, but the thing is we can specify the mode in which we want to open that file. We can open it for reading, we can open it for reading and writing, we can open it for writing only, we can also open it for writing and reading. Now, I know that two of those are kind of the same thing, but you know what? Let's look at the documentation. So let's go to php.net, and whenever you know the function name but you want to see the documentation, just go to php.net/ type the function name, enter, and it will take you to the documentation for that function. So if we scroll down, we have the mode. R is to open for reading only. R+ is to open the file for reading and writing. Now, the thing here is that the file has to exist for those two modes to be used. So that's the main difference between R+ and W+, but I'm getting ahead of myself a little bit. So then we have mode W, which is to open the file for writing only. Now here's the thing, if it doesn't exist, it's going to create that file. If the file does exist, then it is going to truncate the file to nothing. It's basically going to delete the file and then start you over from scratch. So if you want to completely replace the contents of a file, then W is what you want to do. W+ will open the file for reading and writing. If the file exists, then it does the same thing as W. It will clear out the file and start you over from scratch. But if it doesn't exist, then it will create that file and let you write it. So that is what we want to use, W+ in this case. So we're going to say fopen, we're going to pass in our name, and then the mode W+. Now this is going to give us what's called a file handle. And we need that file handle because there are other functions that we need to use in order to do things with the file, such as writing to it, reading to it, and closing that file. Now in this case, we are calling this function getData, so we can assume that this is going to be a JSON structure that we are going to read. So we can initialize our JSON variable as an empty string. And then we create the file if it doesn't exist, and then we just might as well close the file because there's nothing there to read. The main reason why we're calling fopen in this case is so that it will create that file. So we want to close the file. If you open a file or create a file, you want to close it. You always want to close it because if you don't, then you will have a hold and a lock on that file and you won't be able to do anything until you essentially shut down your application. So in this case, We don't have anything in JSON, so that's fine. It's just an empty string. But if we do have a file, then we essentially want to do the same thing, except that we want to open the file in read only. We don't want to write at this point in time because there's no reason for us to write. We are just getting the contents. So we will get the handle for that file, then we will read that file. So here we will say JSON equals, and there's a function called fread. We pass in our file handle. That's what we use in order to read. We don't specify the name here because we've already opened the name. We use our file handle, and then we have to say the amount of data that we want to read. Well, we want to read the entire file in this case. So we have to get the file size, and we do that with a function called file size. We pass in the name of the file that we want to get the file size of, so fname, and that will read the file and put its contents into the JSON variable. Then, of course, we want to close that file immediately after we are done. So we have our JSON, we can return JSON. And there we go. So this is the first thing that we could do. The second thing is much easier. We don't really have to worry about handles or anything like that. Instead, we just call a single function in both cases, and it's going to do the work for us. So as far as writing the file, we would say file put contents. We specify the name of the file and then the data. Let's just do an empty string, and we're done. We don't have to worry about opening and closing and anything like that because that is done automatically by file put contents. So we're done there. Now the reading of the file, we have a similar function called file get contents. We specify the file name, and that's really all that we need to do here. But let's also store this in our JSON variable. And just like the file put contents, this is going to open, it's going to read, and then it's going to close. So once again, we don't have to do anything there. And then we just simply return JSON. So let's see how this works. Let's go to our browser. Let's go to our index page. Now we see file get contents data.json failed to open stream, no such file or directory. Now that's interesting because we shouldn't be using file get contents because that file, oh, that's why. If not file exists. It's amazing what the difference a keystroke makes. So let's refresh. Okay, so that first error went away, but now we see that there's this undefined constant JSON, assumed JSON in functions.php line 15. That is there. We needed a $sign. So now though, look over here, we have data.json. So it did create that file. So just for the sake of completeness, because I want to run this page without seeing anything, let's refresh. And there we go. So if we go back, data.json is there. So we have just created that file, and that's really great. So now let's provide some data. Well, this is a JSON file, so we're going to have an array of objects. And so our first object is going to have a property of term, and let's say that the value is going to be CSS. And then let's have definition. And, you know, let's just do cascading style sheets. Eventually we will want, an actual definition here, but for the time being, that's going to be okay. Let's do JS for a term. Let's have just JavaScript as the definition. And then we also need PHP. Makes sense to do PHP. So PHP, and then the definition will be PHP hypertext preprocessor. Okay, so we have data. Let's go ahead and refresh again. And we have our data. So it read it, but of course we didn't do anything with it. All we did is get the data. So inside of our code, let's do this. We have our data. Let's pass our data onto the view, and let's see what we have. So we refresh, and we have our raw JSON structure. And that is perfect, so that in the next lesson we can take that JSON structure, convert it into something that we could use, and then output the data. And we will do that in the next lesson. In the previous lesson, you learned how to read the contents of a file, and you also briefly looked at writing to a file. Although we didn't really write anything, we just used the function in order to create the file if it didn't exist. But we will get to writing to files in a later lesson. For now, I want to focus on the data that we have now, because since we have data, we might as well go ahead and display this data. So this is what we have. We have just a JSON structure. Now, if you're not familiar with JSON or JavaScript, it's really quite simple. What we have, essentially, I'm going to use PHP terms here. So if you are familiar with JavaScript, I'm going to be wrong. So what we essentially have is an array of associative arrays. So the syntax, we have square brackets. We have been using those throughout this course. So that is our array. But whenever you see these curly braces, then this would be the logical equivalent of an associative array in PHP. So we have a key and then a value, and then a key and then a value. And that is one of our items. Then we have another item. We have a key and a value and a key and a value. So that's the idea here, except that in JavaScript, this isn't an associative array because JavaScript doesn't have associative arrays. Instead, these are objects. Now, PHP has objects, and we are going to be working with objects in this lesson. But I'm getting ahead of myself. Let's just focus on what we have as far as our data. We want to turn this, because this is just a string whenever we get the data from the file. We want to turn that string into something that we can use within our application. And that's called parsing. We're going to parse the string. So let's change this to JSON because that's what we have. And so whenever we have JSON, we want to parse it. So let's create a variable called items. And no, let's do terms. And then we will call a function simply called JSON decode, and then we pass in our JSON. So this is the main reason why I chose JSON as the data format here, because every language and every platform now has built-in JSON capabilities. PHP is one of those. So by using this simple function, we have taken the JSON that we read from the file, and with terms, we have now created an array of objects that we can work with inside of PHP. So I am passing those terms to our view as its model. So let's go to our view so that we can start displaying this stuff. Now remember that inside of our view, we refer to our model as model. That is the variable name that is used inside of that view function. So what we want to do is loop over our model, because that's what we have. We have individual items within an array. So we want to use a for each. So we will say for each, and we will say model as, we can call this item, and then we want to output our data. Now, here's the thing when it comes to using objects. We could do echo, and then let's build a table. So before we start building that row, let's have a table with a class of table and table striped. And then we will have our closing table tag after the loop, so that the loop is going to generate a tr element and then two td elements. One for the term and then one for the definition. So we'll have opening and closing td, opening and closing td. So we can come in here and we can say item. But the moment that we start trying to use the syntax for accessing a property on that object, well, then things start to go wrong. So here's what we're going to do. We are going to create a variable. We're going to call this term, and we will say item. Now, the syntax for accessing the properties and the methods on an object is different than what you would find in most other languages. In languages like JavaScript or C#, Java, things like that, you would just have a dot, and then you would type your property name. So our property names are what we have inside of our JSON structure. They are the keys. So we have term and definition, term and definition. So we don't use a dot to access this value. Instead, we have an arrow. It's not what's called a fat arrow, which is what we have been using with associative arrays. It's a skinny arrow. It's a dash and then a closing angle bracket. Now, if you're not familiar with the term object, just think of an object as you would a normal everyday object. Just look at something on your desk or something near you, and if it's a thing, then that's an object. Just think of, a guitar. Here we go with guitars again. A guitar has a color. So that would be a property of the guitar. The amount of strings. So we could have a string count property because some guitars have 6, some have 7, some have 8, some have 12. There's varying numbers of strings. But then a guitar also has what we could call methods. These are actions. They usually change the state of an object. So, you can turn the volume knob up on a guitar, and that would be making the guitar louder. So we could have a method called make louder, and a method is just like a special function, basically. You execute it like you would a function, except that it is attached to an object. So you have these things on an object, and in the case of our terms, we have a term property, and then we have a definition property. So item and then definition. I should have used a shorter term, but that's going to be okay. So this is what we are going to have. Now, once again, these names that I've used, term and definition, come from the keys that are specified inside of the JSON file. So that's why I'm using those. If we changed term to hello, then we would use a property called hello over here instead of term. So there you go. All right. So we have our for each. We are going to say term there, and then we are going to say definition there. We need to finish that statement with a semicolon, and there we go. So when we see this in the browser, that's what we have. Although we see that we have a notice array to string conversion in line 6. So we will need to make note of that. But at least our data is here. We have our term and then the definitions. So line 6, oh yes, we are outputting model. So let's change that to glossary because that's what we have. So let's refresh and there we go. Now we can do our loop like this and that's okay, but I don't particularly like how we have strung all of this together. That just makes this more difficult to have to maintain. So we could write our for each in a different way. So let's move that down just so that we have that. And we're going to use a different type of syntax. We are still going to have a for each, and we're going to put this on the same line as PHP here. But instead of a curly brace here, we have a colon, and then we end that code block. That termination for that code block, we're going to do this. We're going to open up another code block, and we're going to say end for each, semicolon. So that's now inside of our for each and the end for each, we can have HTML. And that makes our code a lot easier to, first of all, read. It also makes it easier to maintain. So now we can come in here and we don't have to create these individual variables because we can use our shorthand output syntax and we can say item and then term. And then we will do the same thing for the definition. So we'll just copy and paste and then definition. So if we view this in the browser, we are going to get two tables. The first is using that shorter syntax or the HTML friendly syntax. I guess that would be the better term. And then we have one that uses the traditional for each where we echo out just a string. So we have two options. I'm going to opt for this one because that one makes our output easier to do. And since we are primarily working with HTML inside of our view, it just makes sense to use this type of output. Now, because we have this type of syntax for a for each it could be implied that, we could do the same thing with an if. If true, then we have colon, we close our PHP code block, and then we say end if to end that if statement, although we need PHP there. So it's the same type of thing. That way we can use our HTML and then we just output the values that we need to output. Okay, so we have our table of glossary terms. Well, let's go back to our code and let's specifically go to index.php because we are doing something here that we are going to do multiple times. Anytime that we are going to display the terms or our list of terms, we are going to be doing the same thing, calling get data and then decoding it. So it makes sense to go ahead and write a function. We could call this get terms, and then we will get our JSON, and then we will simply return JSON decode, and we will pass in JSON. So pretty simple. So that then all we have to do is call our get terms, and that's it. So of course, if we refresh, we get our results. But now we need to think about where we put this get terms function, because we do have a functions PHP file, and it does have two functions. So let's go ahead for right now, and let's put it inside of here. However, I'm also thinking about the future, because we are just now starting this application. We are, of course, going to be writing more functions, and we are going to want to put them someplace. Some of those functions are going to go in here. And the more functions you have inside of a file, the harder it is to find the function that you need if you need to modify it. So it kind of makes sense to start organizing our functions into separate files, so that a file will have just the functions that are related to one another. So for example, we have two functions that are data related. One is reading the file. The other is using that function to read the file to then decode the contents. So we could say that these are data related. Now, I'm also thinking farther into the future whenever we start incorporating MySQL into our application. And we are, of course, going to write functions there. And those are going to be data related. So if we start with a folder called data inside of our app folder, we can put our files that are data related inside of this data folder so that they are separate from all of our other files. So we're going to create a new file inside of data. And since these are dealing with file data, we'll just call this file_functions. We might change that at a future time, but for right now, that's going to be okay. And let's copy and paste. And then let's get rid of these. I copied and pasted so that I wouldn't have to type the opening code block in file functions. Now we need to include this, and all of our includes are inside of app.php. So we will require, and we want data/file_functions.php. And that's the only time we have to include this, because app is included inside of index.php. So we are starting to see the benefit of having this app.php file, especially in the next lesson when we add another controller. So now we don't really even need this terms. We could do something like this. We could just call get terms and pass that as the model to our view, and then we don't have that at all. So we have a pretty clean view now. Although let's go ahead and create our view bag, but let's do this all in one statement so that we have our title. And then for the title, this is our glossary, so let's just say glossary, so that we have a title in our title bar. So we need to make sure that this works. Let's go back, let's refresh, and everything works just fine. Although let's say glossary list, because that's what we have here. So there we go. And now our controller is nice and clean. We don't have any HTML inside of our controller. If we go to our view is nice and clean. And the only logic that we have is our for each, so that we can iterate over our model and output the term and definition. So now, in the next lesson, we are going to have a link for our terms, so that the user can click on the terms. That will take them to a separate page that will then give them more information about those terms. Now, we're not going to have any extra information because we just have a term and a definition. And of course, we can come in and we could add more information if we wanted to. But we're going to keep things simple. When visitors come to our glossary, they are greeted with a list of terms. Well, it's not really a list, it's a table. And we want the ability for users to click on the terms so that that will take them to another page for more detail. Now, we aren't going to have more detail, but we could easily add that at a later time. So we still want this functionality. So we need a link for our term. So let's just go ahead and add an A element there. Let's wrap our term with that element. And then we need to think about what we want to call the file that's going to be responsible for displaying the detail. So we could call it term.php. And that would be okay, I guess, but we are really just displaying the detail. So let's just call it detail. And then we need to think about how we get the term that we want to show the detail for. Well, whenever you click on a link, that's a GET request. And we know that with a GET request, we can use the query string. So we can just add the term as part of the query string. We can add a parameter called term, and then we will essentially output our term again. So this is going to be detail.php ?term equals, and then our term. So it's going to be as easy as that. So if we go and look at this in the browser, then there are our links. And looking at the bottom left-hand corner, we see our URL. That's going to go to detail.php, and term is in the query string. So let's create that detail file. So new file, detail, well, that's inside of views. We don't want that. We want that at the root. So new file, and then detail.php. Let's go ahead and take the contents of index.php and use that as a basis. Because we want this require, we will eventually do something with the view bag. But really what we want to do is check to see if we have a term in the query string. Because if we don't, then there's really nothing to display. And in that case, we could just redirect back to index. So if not is set, and we will use our super global of get and term. So if the term doesn't exist, then we will just redirect. Now we do not have this function. We wrote this outside of our particular project, and I would like to keep just everything inside of this project as much as possible. Now, as far as the CSS and JavaScript and stuff, that is, of course, outside. But let's just keep the PHP inside of our project. So we are going to rewrite our redirect. But it's easy enough, so it's not that big of a deal. Let's go to functions. And we want function redirect. And we, of course, need the URL there. And we set the header called location. And we incorporate the URL there. Now, after we set the location header, we will call die so that the processing is stopped. And so inside of detail.php, we just specify index.php. And there we go. So if the term isn't set, we just go back to index. If it is, then we need to get that term and then read our data so that we can display all of the detail about that term. So we have a function that is going to return all of our terms, and it's called getTerms. So we could have a function called just getTerm, so that it would look like this. We'll say data equals, and we'll call the function getTerm. We will use our get super global. Once again, we do need to validate this though. So let's add a to-do to validate input. And this should get us our data. Now we need to see if we actually have some data to work with. So if data is equal to false, notice that I'm just writing this code first so that we can then implement it later. So if data is false, then we could display a 404 because, technically that particular resource doesn't exist. But let's add a to-do. And I guess we'll just do 404. So if data is false, then we will 404, we will then die. Otherwise, we will pass our data to the detail view and then display that data. So that is essentially going to be our controller. It's not as clean and concise as the index controller, but we are also doing more stuff here. So let's write this getTerm function. Let's go to our file functions, and we will say function getTerm. We need to know what term that we want to get, and we are going to get all of our terms. So we'll say var terms, not var, I'm sorry. I get into a JavaScript mode and just say var all the time, so don't mind me. So we'll get our terms. Now this gives us an array of objects. So we need to iterate over this array so that we can check the term for each object. If the term is equal to what was supplied to the function, then we have a match. We'll just return that. Otherwise, we will return false. And the reason why we're going to return false is because that follows the convention for PHP functions. You know, if we have opened up a file, or rather we attempted to open up a file and for some reason the file didn't exist or something like that, we would have false as our handle. So it's the same concept being applied here. So we want to for each, and we'll say terms as item, and then we will check if item term equals term, then we will return item. Otherwise, if we go through all of the loop, we don't have a match, we will return false. That seems easy enough. So let's look at what else we need to do. If we have our data, if it's false, we 404. Otherwise, we have our view bag, and here we can incorporate our term. So we could say that this is the detail for, and then data term, although we can't really do that, can we? We could do this though. Term equals data term. And then we could just use term here. Now we don't have this view called detail, so let's go ahead and create that. We're going to do that inside of our views folder. So new file, we'll call it detail.view.php. And let's just use what we have for index as the basis for our view in detail. Now, as far as our title is concerned, we could use what we have in our view bag. So for right now, let's do this. We will say view underscore bag, and then our title. Eventually, we would probably want to do something a little bit different, but this is going to be okay for now. So we will have our title, and then we won't have a table because there's no sense in having a table if we are just going to display our information. And right now we just have the definition. So we can just output that with our model and definition. So that should be enough for us to actually test to see if this is going to work. So let's click on any one of these, and that should take us to detail PHP. It does. We have detail for CSS, and that's our title as well. And then we have our definition. So we are working here, except if we make a request for a term that doesn't exist. So if we do something like XML, heaven help us, we of course just get a blank page. Instead, we would want to display a 404, or at least something that says that this wasn't found. But let's also omit the term query parameter, and that should redirect us back to index, and it does. So we're good to go as far as that functionality. We just need to do something if the term doesn't exist. So we could do this. We could create another view for a not found, and it could say, you know, that doesn't exist. So let's do that. Let's create another view, and we'll call this not underscore found dot view dot php. Let's go ahead and just use what we have for index as the basis, or we don't really even need index. We can use detail. So let's use detail, and then we will say, instead of the title here, we will say that not found. This is generic. We don't want to be very specific and say that, hey, this particular thing wasn't found. Eventually, we might want to do that, but we want this to be as generic as possible. So we could have a title that says not found, and then for the content, that doesn't exist. Just something simple. So let's make a request for something that does exist. We, of course, know that that works. Let's make our request for XML once again. And, well, we didn't actually use that view, did we? So let's go to our detail controller. And here we are going to use the view. We are going to use our not underscore found view. We don't have a model for that, so we will probably get an error. We do. Argument count error. So we could add a default value for our view. And this is just part of development. You know, you're not going to get everything right the first time. If you do, then buy a lottery ticket because you are pretty lucky. Writing software is an evolution thing. You start writing software and then you start adding more things to it that is going to eventually break what you have written, and you just have to go back and fix those particular issues. So there we go. We can see that that is not found and that it doesn't exist. So now we have really a working detail controller and view. If the term is not set in the query string, we go to index PHP. We then get the specified term. If we don't have any data, then it doesn't exist. So we just say not found with our not found view. Otherwise, we use our term for our title, and I don't like this. Let's just use concatenation here because that will allow us to eliminate that term variable, and we don't really need it if all we are doing is just using that for the title. So that makes it a little bit cleaner, but let's of course make sure that I didn't break anything. So we will go to CSS and we still work there. So our application is coming along quite well. We're displaying a list of terms. We're able to view the detail of those terms, but now we also need to incorporate the search so that users can search a term and hopefully get some results. So we will start doing that in the next lesson. We are just a few steps away of having a complete working application. And in fact, as far as the front end is concerned, we are almost done. All we need to do is add the ability for users to search our glossary. Now, when I say front end, I'm not really referring to what is in the browser. I know that that's typically what you might think of, but whenever we are working with solely a server application, we have a front end, which is what the average user sees, and then we have the back end, which is all of the admin stuff. So in this case, we are almost done with all of the stuff that an average user is going to see. So we are going to add a form to our index view because that is the most logical place for the user to search our glossary. And then we will just go from there. So let's add another row here. And this is where we are going to put our form. And this is going to be an inline form. So we'll have a class of form-inline. I believe that's what the class is. We'll find out soon enough. Now, as far as the action is concerned, we are inside of index.view.php. However, whenever we see this in the browser, it is going to be index.php. So we will be able to leave this alone. However, if you wanted to be absolutely explicit and say that we're going to index.php, then feel free to do so. There's no harm in making sure that things are going to work how you expect them to. But I'm going to leave that, and we are going to make this a GET request because we aren't dealing with any sensitive information and we aren't changing the state of our application. We are just essentially requesting data. So I'm going to use GET. Let's have a form group that is going to contain our text box as well as the submit button. So we'll start with the text box. Let's give this a name of search because remember, whatever we specify as the name, that is what is going to end up in the URL. So we want something that is at least readable, and search just kind of makes sense. So we will have a name and ID of search, And really that's it as far as our text box is concerned. So let's add another input element. This will be type submit, or you can use a button. I'm just using an input out of habit. And as far as the value, this is going to be simply search. So if we view this in the browser, we should see our form, and there it is. Although we might want to style it so that it's over on the right-hand side, but this is going to be sufficient. Okay, so we have our form. Now we just need to write the code inside of our index controller. So we are going to make our nice and very clean controller be a little dirty, but that's okay. We're not going to do anything that is out of the ordinary or anything that would be inappropriate. So the first thing we want to do is check to see if we have a search term in the URL. So we will use isSet. We will specify our get superglobal and then search. If we have this, then we want to perform a search. So let's create a variable called items, and we will call a function called search_terms, and then we will pass in what was given to us through the URL. Now I want you to notice the name of this function, search terms. I called it this because our other function is called get terms. If we are consistent in our naming, it makes it easier in the long run to work on our applications. So always be mindful of what you have named things in the past, because if you keep it consistent, then everything's all good. So if we don't have a search term in the URL, then we can just do what we normally do and get all of our terms to display in our view. So then we will pass our items to our view, and we should be fine there. So now we just need to write this search terms. And we have our file functions inside of the file called file functions under app and data. And we already have a function called getTerm. And on the surface, it would seem like that we could use that. But remember that what this function does is it loops over all of our items. And if there is a matching term, then it just returns that item. It doesn't search the rest of the array for any other matches. If it finds a match, it returns it, and then it's done. So at the most, getTerm just returns a single item. Whereas whenever we are searching for something, well, we could return 0 items or 1 item or multiple items. So let's call this search term, or let's just call it search, because I'm going to probably say the term many times. So we have our search. And the first thing we want to do is get all of our terms. So let's just do that. We'll say items equals, and then get terms. And then we want to loop over our items so that we can search each of the terms with what was provided to the function. And we can also search the definitions, and that would actually be good. That way they can search for anything, and we will return anything that was a hit. That means that we need to loop over our array, and we need to build a new array that contains the matches. Now that kind of sounds like something that we have already used before. If you'll remember, many lessons ago, we used a function called arrayMap, and it accepts a callback function, and it executes that function on every item within our array. And that sounds great, except that it doesn't filter the array. If we have an original array with 3 items, the resulting array is going to have 3 items. There's nothing that we can do about that. However, there is another function called arrayFilter. Now there are many array functions, just let me throw that out there, but we have arrayFilter, which will allow us to filter our array, and that's exactly what we want, except that there's a slight little problem. The developers of PHP were not consistent. Now, I don't mean to beat you over the head with be consistent, be consistent, be consistent, but this is why you need to be consistent. Here we have 2 functions that work with arrays. We have arrayMap and we have arrayFilter. And they accept the same information. ArrayMap takes a function and then an array, but arrayFilter takes array and then function. There's no reason for these to be switched. None whatsoever. And this puts the burden on us. We have to remember which function has which parameter list order. At the very least, if we get it wrong, we have to go back and we have to fix it. And you might think that, well, that's not that big of a deal. But whenever you start working with other languages and other platforms, it is a big deal because other developer teams, they put forth the effort to be consistent. So be consistent. Put the burden on you to be consistent. Otherwise, you're going to tick off the people that are going to be working with you or working with your code. And that's all I'm going to say about that, at least for right now. So we want to pass in our array first, and then our function. And then inside of the function, we are going to perform our search. But how do we do a search? Well, let's look at this. We have a string. This is called hello world. And a string is nothing really more than an array of characters. So you can think of this as every character as an item in an array. So H is at position 0, E is at position 1, L is at position 2, the other L is at position 3, and so on and so forth. Now, when it comes to PHP, all of our functions return a position of a character. So we have a function called string position, or strpos, but it's short for string position. And it allows us to search a string for what's called a substring. The substring is just a smaller part of a larger string. So we have hello world as our string, and they use the term searching for a needle in a haystack. So hello world is our haystack, and then let's say that we have ELLO as our needle. That's our search term. So the string position function is going to return the position of where it finds the match for the needle, or our search term. So in this case, it's going to return the position of 1, because ELLO begins at position 1. So that's what we get. Now, if we do a search for HE, then that's going to return the position of 0, because the first match of HE is at position 0. HE and then LLO. So in this case, that's position 0. However, if we do a search for Z, well, there is no Z in hello world. So in that case, it returns false. So we can use this string position function to determine if we have a match with our search term. So it will look like this. We will have an if statement. If string position, our haystack is the term property for our item. The needle is our search term. And if this is not equal to false, then we have a match, although we do need a use statement here. Remember that inside of our anonymous function, we can use our search variable, but we have to explicitly say that we want to use it. So we will use search. And so if we have a match, if string position returns, or does not return false, I should say, we return our item. Okay, so makes sense, right? Let's go and let's check it out. So we are going to do a search for C. Click on search, and we got nothing at all. We should have 1 because of CSS. So here's the thing. Whenever we talked about conditions, I left something out. We have true and false, which we definitely talked about, but we also have something called truthy and falsy. These are values that are not true and false, but they can be used as true and false. Now, if you'll remember whenever we talked about conditions and we echoed out true, we saw that we used, or that PHP echoed out the value of 1. Well, 1 is a truthy value, and really, anything that is not 0 is truthy. It's just that 1 is the most common, so 1 it is. A string that contains anything is truthy. An array that contains anything is truthy. So there are many values that could be considered true. So we could do something like this. We could say if 1 echo, something out, and we would see that in the browser. We could also echo, or we can also do if and then have the string, and we would still see the echo statement. However, if we did something like this, where it was an empty string, well, we would not see the echo statement. If we said if 0, we would not see an echo statement. But now let's do this. We have string position, we had our term, which was CSS, and then we had our search, which was C. Well, C is at the position 0 in CSS. So what we ended up with was this. 0 is not equal to false. Well, 0 is a falsy value. So what we ended up with was really false is not equal to false. Well, that's not true. That is false. So therefore, our code, the return statement, did not execute. So then how do we make this work? Well, we have another equality operator. It is 3 equal signs, and this is a strict equality check. In this case, it's going to see the value of 0 and the value of false. They are not equal in this case. So this condition is false. However, if we say not, and then 2 equal signs, then this condition is true, because the value of 0 is definitely not equal to false. So when it comes to doing equality checks and inequality checks, most of the time you want to be strict about it. So in this case, we need to be strict because the string position function will return a positive value or 0 or false. If 0 and false could be the same thing, then we need to have an absolute strict check to make sure that what is returned by string position is not false. So that is why that didn't work before. If we go back and we do a search for C, now we will see our results because CSS is there. Okay, so we did a search based upon the term, but we also want to do a search based upon the definition as well. So this is going to be an or. If the term contains our search, or if the definition contains our search, then we want to include that item within our filtered array. So we will have definition, that's our haystack, our needle is search, and this is of course not going to be false either, then return. Now notice that I put this on 2 lines. You can do that. I just did it for readability purposes. If you wanted to put it all on 1 line, that's great, but I don't like to horizontally scroll. And if you do, well then I'm sorry. So there we go. Now we should see just, well, everything, because everything, well, yeah, everything has a C. I'm sorry. So if we do a search for CSS, we see CSS. If we do a search for CA, we still see CSS because cascading has CA. But let's do a search for AS. We should get cascading style sheets as well as JavaScript because that string is in both of those definitions. So it would be nice if our heading up here also included our search term. So we can do that with our view bag. Let's add another item here called heading, and we can do this. We will set the default to glossary. And then if we do have a search term, then we will say view bag and heading, and we will set that to equal to search results for, and we could wrap this around with quotes, but let's just do this. We'll concatenate our search term. So we will have that. And inside of our view, we need to get rid of that, and we need to output our new heading in the view bag. So view bag, and then heading. And now we have some indication that there is something other than the glossary there. So we have the search results for AS. If we did a search for Z, then of course there's nothing there. Okay, so we have our front end complete. We can click on any of the items in order to view the details. We, of course, see all of our items, and we can search for our items. Well, that means that in the next lesson, we get to start with the admin portion of our application. That is where we are going to add and update items within our data store, and we might do some deletion too, as well. We are done with the front end of our application, so now we need to focus on the back end. And I want to segregate these two pieces so that we don't have all of our admin code intermixed with our front end code. So we're going to put all of our admin stuff in a folder called admin. So let's create a new folder, of course at the root of our project, and then we will create a file called index.php. This is going to be the controller for the index of admin. And we also need a view here. So we want to continue on this idea of organizing our project. And we could put a views folder inside of the admin, but that doesn't make a whole lot of sense to me. I want all of our views in the same place, but we need some organization. So we're going to create a new folder inside of views called admin as well. And then we will create our view. Although let's just take our existing index view and paste that into the admin folder just so that we have something to start with. Let's also take the first two lines of code from our old index controller and paste that in. Now we do need to modify the path here because we are inside of a subfolder called admin. We need to go back a level so that we can get to our project's root and then go into app and then PHP. So we're just going to say .. And then let's do this. We will say view and we will specify admin/index. So that should work, right? Well, let's see. If we go to admin, well, code executes. That's saying something, but we see that there's an issue here. It cannot find views/layout.view.php. Now, the reason why it can't find it is because we've been using relative paths. And whenever we included that app.php file, which also includes everything else, well, all of the relative paths now are for this admin folder. So this is actually looking for a admin/views/layout.view.php file, which of course doesn't exist. So we need to make this work. One of the options is to completely reorganize our project, and I don't want to do that, for one, because that's a lot of work, and for two, I like how our project is currently organized. So another option then is to start incorporating absolute paths, because relative paths are great for flexibility, but sometimes you just need an absolute path. And it would be great if we had an absolute path for our current project folder. So that would be for the 4.6 folder. So first of all, what is an absolute path? Well, we have a relative path here. An absolute path would be something like this. We wanted to get the folder to this 4.6, or the path to this 4.6 folder. So the absolute path on my machine would be c:/mamp, and then htdocs, and then 4.6. That is the absolute path to this folder. And we could hard code that, but I don't want to hard code that because as we move this project from one folder to another, we're going to have to go in and make that change every time. I want this to be as flexible as possible. So instead, what we can do is try to get the absolute path to our project folder by using the tools that PHP gives us. One of those is called __file__. Now this is going to give us the file, or rather the file name of wherever this code exists. So we are inside of index.php inside of admin. So we're going to see that path there. But if we change this into any other file, we're going to see the path to whatever file we put it in. So we can go to app.php, we can paste that in, and then we will see that change. Now it is app/app.php. So this gets us kind of close. I mean, of course, we want to take off the app/app.php. So let's try to start doing that. Well, one of the tools that PHP gives us is a function called directory name. Actually, it's dir name, but it's short for directory name. This is going to give us the directory of whatever file we specify. So this is at least going to chop off the file name. It is still going to have app at the end, but that's at least closer. And we could write code that would then strip this out. And I don't want to do that because that just takes too much time. So instead, I'm going to do something like this. We can concatenate a string that says /./. And whenever PHP and the operating system interpret that, it's going to actually drop us back to our project folder. It looks funky if we echo it out. I don't care what it looks like as long as it does what I want it to do. So now we just need to define a constant value that is going to have our application path, because then we can start using that anytime that we wanted to specify an absolute path so that we don't have any issues as far as relative paths are concerned. So we can start by trying this. We can say const and then app_name equals, and that would be a good first try, except that this isn't going to work because whenever you use the const keyword here, that means that whatever constant value that you're going to create has to already exist. It has to be a literal value. It cannot be something that is computed, because what we're doing here is computing the directory name of file and then concatenating the /./. So instead, we can do something like this. Const is relatively new to PHP. Before we had const, we had a function called define. It essentially gives us the same thing, but in this case, it will allow us to compute the value for our application name. So that we will call this define function. We will create this app name constant, and it's going to have the value here. So now we can use this app name, and we can go inside of our functions, and we can change this where we specify our layout page. So we're just going to concatenate the app name with the rest of that path. And if we view the admin index page, we're going to see that it's actually going to at least have the markup there. The styling is off because of how I pulled in the CSS. So let's go to our views and then the layout page. And we're just going to take off the .. because whenever you do that and you start the URL with a slash, it's going to take this relative part of the value. And this is the browser doing this. This is not PHP. It's going to take the relative path that we have and add that to the host of our URL. So it's always going to start at the beginning of the URL path, which is the host, and then tack on everything else. So now we see our styling. If we go back to the front end, we see the styling and everything there. But notice that we still had a warning, invalid argument supplied to for each, and that's because we did not include our data. So let's go to index.php, and let's call our getTerms function. And whenever we refresh, well, we still don't have anything there, do we? Now, the reason why is because if you look over here inside of admin, we now have this data.json file. So this is something else that we have to change because we used relative paths for the data file name, and so it created this data.json file inside of admin. We don't want that. We just want to use our current data.json file. So we can do this in two different ways. We can go to config, and we can use our app path here. So this would probably be the best place to do that so that we don't have to worry about specifying this anywhere else. But the other option would be to go to our data and then file functions and then concatenate the app path there. I don't want to do that there. I want to do it in the config. So anytime that we reference our data file, it's going to have the absolute path. So now we can go back. Let's refresh this, and use of undefined constant app path. Well, that wasn't supposed to happen. So app path, we just used this. Why is it not working? That's why. App_name. I want this to be app path. App name doesn't make sense. So this means that we need to go to our layout, not our layout. We need to go to functions.php, change that to app path. Now, whenever we refresh, there we go. So we are inside of admin. We are pulling in the correct data file, and we are pulling in the correct view. If we go to the front end, we're going to see the same thing. So we have at least fixed that particular problem. Any other time that we need to reference a particular file, then we might need to use our app path. Now, this did create a new data file. I did app path, and yeah, okay, so let's delete. And there we go. So in the next lesson, we can start working on the admin portion of our application. Now that we have our paths all sorted out, we need to start writing code for creating items. Now, we're not going to worry about authentication at this point in time. We've already looked at that, and we should be able to easily add that to our application, because authentication is going to add some complexity as far as development is concerned. So we want to add the functionality that we need and then add authentication later, just to make our lives a little easier. So the first thing I'm going to do is inside of our admin's index view is add a link for creating a new item so that it will take us to a new page. So where we have our search form, because we don't really need that, we're going to have an A element. The href is going to be create.php. And this is going to go naturally to our create page. Now, we don't have to say admin/create, because in the browser, it's going to take our current location, which is admin, and it's going to append create.php to that. So we're going to be fine there. And let's just have create new term. And that's all that we really need now. So let's refresh. Let's make sure that that's what we have. It is. So we can go to that page. And of course, it doesn't exist. So we need a controller. So let's go to our admin folder. Let's add a new file called create.php. And let's go ahead and bring in the app and also the view. So let's open up index.php and just, well, we can just copy what we have here. And then we will paste that in. Now we, of course, don't want to get our terms, and our view is going to be called create. So let's go ahead and change that. And you know what? Let's go ahead and create our view as well. And we can just take what we have for index and copy and paste, because that will at least give us a starting point. And then that's just create.view.php. Okay, so our title is going to be create term. And then we are going to have a form. And really, we just need two things. We need the term and the definition. So let's get rid of our table, because we don't need a table here. And just looking at this, the markup's all wrong anyway. So that might be something that we go back and change. But for right now, let's focus on this. Our action is going to be to create once again. So we're going to leave that alone. And we want the method to be post, because in this case, we are changing the state of our application by modifying our data. We are creating something. So this is going to be a post request. And then let's have a form group for our fields. So the first one is going to be for the term itself. Let's have a label. The for, we'll just call it term. And then we will have an input element, type text. The name will be term, and the ID will be term. And that's good enough for me. Let's take that, copy and paste it so that we can create our other. Oh, we do need text for the label. So we will have term, and then we will have definition. And of course, the for and the name and the ID need to change. So we'll just set this as definition as well. And instead of using a text box, let's use a text area. Or I guess I should say, instead of using an input element, we will use a text area. We will still have the name and ID, but we won't have the type attribute, and we need to close this element. And that should be okay. So let's go to the browser. Let's look at what we have, and that's not the best, but we're also missing some things here. We need a class of form control for our form controls. So let's add that in, and that should make that look a little bit cleaner. So let's refresh. Okay. Our definition field could be a little bit larger, but we're just going to stick with this because we need to move on. So let's add another group for our submit button. And I'm going to use, once again, another input element. The type will be submit, and the value is going to be create term. All right, so we have our form. Now we just need to handle the code for whenever we submit this form. So the first thing that we need to do inside of our controller is check to see what type of request was made. Because if it's a post request, then we of course want to process the incoming data. Now we can do that with our server superglobal, and then we check the request method to see if it's equal to post. And I want to break this out into another function because it would be useful to just have a function that says is post so that we don't have to type this all of the time. Now notice that I'm using the strict equality now. I am going to probably be doing that from now on. And anytime that I come across just normal equality, I will probably change it. So we're going to create a function that's going to encapsulate this so that we can just call is_post, and that will of course return true or false. So let's go to our functions file, and we will add that. So here we go, function is_post, and we will simply return if the request method is equal to post. Easy enough. So now we can do something with the incoming data. We have the term and the definition. We need to start sanitizing and validating our input. So we're going to start doing that. And to help do that, I'm going to write a function called sanitize. That's going to strip out anything that is harmful to our application because we're going to take that input and then display it in the browser. So therefore, we want to sanitize it. And we're going to pass in the value from our post. So we're getting the term there. We need to also get the definition. So we will do that. And the sanitize function is going to return one of two things. It's going to give us the sanitized value, or it's going to give us an empty string. The reason why it would give us an empty string is because the filtering might have failed. So in that case, what we're going to do is then check to see if term or definition is empty. So we'll do that. And if that is the case, then we of course want to send a message back to the user saying, nuh-uh, you've got to supply something that is valid to us. So we'll just add a to-do there, a display message, and we'll come back to that at a later time. So let's write this sanitize function. We'll go to our functions file, function sanitize. We'll call the parameter value for the lack of a better term, and we'll create a variable and we'll call a function called filter var. Now this is similar to what we've used in a previous lesson. I don't remember if it was filter input or validate input. It was one of those, and this is essentially the same thing, except that instead of supplying the type of input, like the get request or the post request, we are supplying a variable. This way we have a little bit more flexibility so that we could, do this. We can just pass in our value, and then we have that value as a variable so that we could use sanitize for anything, and it wouldn't be dependent upon a particular type of input. So we need to pass two things. First is the variable that we want to filter. The second is the type of filter that we want to do. Well, in this case, we want to sanitize. So that's called filter underscore sanitize underscore string. But something else that we should do is trim our value, because when the user submitted the form, they could have typed in a couple of spaces and then whatever the term is. And whenever you trim a string, you trim off any leading or ending white space, because we don't want any white space at the beginning or ending of our term or the definition. So we can call a function called trim, and we'll pass in our value, and then the result of that is going to be used for our filter var. Now, the filter var function returns one of two things. It gives us either our filtered string, or it returns false if the filter failed. So let's do a check for false, and if it is false, then we will simply return an empty string. Otherwise, we will return our value. So that inside of our controller, we have already set up so that if term or definition is empty, then either the filter failed or the user submitted an empty string or a string of just white space to begin with. So we're catching that and will display a message. Otherwise, we want to save our new term and definition. So we have several functions. Let's first of all look at what we have. So that was inside of app data file functions. We have get terms, get term, search terms. We can call this simply add term. So add underscore term. We can pass in our term and the definition, and then we will be good. And then whenever we add a term, we really should redirect back to the index. So we will redirect back to index, and we'll see which index that actually takes us to, either in the admin or at the root of our project. And well, we die there anyway, so we'll be good to go there. So we just need to write our add term function. So inside of our file functions, we will say function add term. And the first thing we want to do is get our terms, because we are going to take the incoming information and then add that to our array. Now remember that our terms is an array of objects. So we in turn need to change our term and our definition into an object. And we can do that in a couple of different ways. The first way would be to simply just write a class, and we will eventually get there. But for now, we're going to create an array. And the key, or the keys rather, are going to be what we've been using. Term is going to have the value of term, and then definition is going to have the value of course, definition. And then we want to convert this array into an object. So I'm going to create a new variable called obj, and then we do this. We have a pair of parentheses. We put object inside of the parentheses, and then we specify the array. So this is converting or casting the array into an object. And then we need to add that object to our items, and we do that like this. We have an array, so we specify the square brackets, but we don't put anything inside of the square brackets. And we say equal object. So this is going to add that object at the end of our items array. And then we simply want to write that data. So we have a function called getData. We'll call setData. We'll pass in our items, and then that function will be responsible for writing to the file. So we can simplify this a little bit. We don't really need this array variable. So instead we can take our array and just do this. It's a little bit more cryptic to read, but I like that better. So let's write this set data. Let's go down, function set data. We're going to get our items, but let's call this array because that's what we have. And the first thing we want to do is get our file name. So let's do that as well. And then we will get our JSON. We are essentially going to do the opposite of what we're doing here. So instead of JSON being an empty string, we're going to serialize our array. And whenever we decoded the JSON, we used JSON underscore decode. The opposite is JSON underscore encode. We pass in our array that gives us a JSON structure, and then we simply write that to the file. So we're going to use file put contents. We don't need to check if it exists, because if it doesn't, it's going to create that file anyway. We pass in the name of the file that we want to write to. We pass in the data that we want to write, our JSON structure, and that's it. So let's make sure that inside of our controller we are adding the term. We are. So let's see if this works. Let's go to the browser. Let's type in JSON, and that's JavaScript object notation. If we click on create term, that should redirect us to index, which it does, and that was inside of admin, and we now have added the JSON item. So if we click on JSON, then, well, we don't have the detail there. But if we go back to just the root of our project and click on JSON, we see the detail there. So we now have the code for creating an item. In the next lesson, we will add the code for editing an item. Editing something is a lot like creating something. You display a form, you submit the form, and then we do something with that submitted data. The main difference, however, is that when you're editing, you are working with pre-existing data. So we need to take that into account. But we can take what we did in the previous lesson and use that as a basis for our editing. And that's going to give us a lot, actually. So let's just do that. I'm going to copy the create controller, and I am renaming that copy to edit. We'll do the same thing for the view. So we'll copy the create view, and then we will just simply rename it to edit.view.php. So that is at least a lot of stuff that we don't have to do. Now let's look at the controller. We still want to check if we have a post request. We still want to sanitize the term and definition. We still want to validate that, make sure that we have something to work with. But in this case, we aren't going to add the term. We are going to update the term. So let's go ahead and make that change. Let's comment that out because we don't have that function yet, but we will eventually get there. Let's also comment out the redirect. But we also need to do something for a GET request because whenever we go to our form, we need to know what term that we want to edit so that we can populate our form. So we need to handle a GET request as well. And we could just come in here and say else and then write our GET stuff. However, I don't like that for a couple of reasons. For one, this means that we have to think about what's going on. Okay, is post, then we do this, else, okay, GET request, then we would do GET request there. So there's that, but there's also, thinking forward, if we wanted to make this a fully RESTful experience, if we had a RESTful API, then we would have more than just GET and POST. There are other HTTP methods that we could use. So let's write a function that's going to check if it is a GET request. Let's go to app and then functions. And somewhere around where we wrote is post, let's just copy and paste that. We will change the name to is get, and we will compare with get. So there we go. And this way, it's very explicit. So if is get, as we are reading this, we know that, okay, this is for the get request, this is for the post request. So if it is a GET request, we need something from the query string to know what term to display in the form. Now, we can't use the word term because that's already going to be part of the request that's coming from the form itself. So let's use something else like key. So we will essentially do the same thing. We will call our sanitize function, and then we will pass in get key. That's going to sanitize that, and then we could validate it. If it's empty, well, then we don't really need to do anything at all, do we? We can just issue a 404, just like what we did with the detail page. So let's do that. Let's go and copy the view not found, and then we will die. Well, we won't die. The program will die, and we'll be good to go there. Otherwise, we want to get our term. So let's say term equals, and then get term. We pass in our key, and then we will call our view function and pass in the view for edit, and then the model term. Now, we do need to check if we have a term. So let's do that. And I don't remember what that returns. Does it return anything? Yes, it returns false. So if term is equal to false, then we will do the same thing. Now, from a code perspective, this is just repetition. And we could do something like this to where we get our term, and then if key is empty, or if term is equal to false, does it actually return false? We need to check. Because if it does, then I'm going to use the strict check. So gets term, yes, it actually returns false. So let's do this there. Okay, so we could do it like this. And from a code perspective, that's cleaner. However, from a performance perspective, it's not. Because in order to get our term, we are doing something on the file system. We are reading a file, we are converting that JSON into something that we can use within our PHP, and then we are attempting to get a value. So performance-wise, it's better to, first of all, check if we have the key. If we don't, then it's not found. We don't do anything else. Otherwise, then we can see if we have an actual term. And I lost that code. So term equals get term, and then we pass in the key. So performance, yes. Code cleanliness, no. But in this case, we want performance over code cleanliness. So if we have a term, then we send that information to the view. So let's go to our view, and we will populate our term and our definition. So we want to set the value for our term to be equal to whatever is in our model. So we will say model and term. And then for the text area, we will essentially do the same thing, except that it will be the definition. So here, definition. And that should be enough. Let's change the submit button to edit term, or just edit. And let's also change the title up at the top, so edit term. So let's see what this looks like in the browser, although we don't have a link there, do we? So we could do one of two things. Let's go to the index view for our admin. We could add a column that's going to have an edit link. And I actually like that better than having a link on the term name itself. So we will do this, and we will say edit. We will close the A element, and there we go. Although we don't want to go to detail, we want to go to edit.php, and the term is not going to be used, it's going to be key. So let's refresh this. We have our edit link. So let's edit JSON, and we have two forms. That is because inside of our controller, for a GET request, we say view admin edit and then create. We need to get rid of the create. So there we go. Let's go back. Let's refresh. And we are at least populating the form with our information. Now, whenever we submit, we need to know a couple of things. We need, first of all, the key, once again, because if we're going to edit a term, we need to know what term that we are going to edit. We can't just rely upon what was given to us in the form, because we could change the name of the term here. If we change this to JSON1, well, then we don't have anything to match that with inside of our data store. So we can then look once again at our key and use that as what we are going to edit. Another option would be to put that value inside of the form itself in the form of a hidden field. And that would probably be the better thing to do. So why don't we do that? We'll add an input element type hidden. The value is going to be the same as our key, or our term rather. So let's just copy that and paste it in, but we need to give this a name. And the name can be original term or something like that. I like that. So we'll say original term. And let me make sure original term is spelled correctly. It is. So let's self-close that. I mean, we still could rely upon the URL, but the only thing about that is that the URL can be changed. And, you know, the hidden field can be changed as well, but at least the hidden field is hidden. So that's my thought process behind that. So for a post request, we also want to get the original term. So we will say original underscore term. We're going to sanitize the post and then original dash term. And we need to add that to our check here. If this is empty, then we definitely don't want to continue on. So we want empty original term. And if any one of these three are missing, then we will not do anything. Otherwise, we will update our term. We need to know what our original term is, so we will pass that as the first argument, and then term, and then definition. Okay, so let's write this function. Let's go to our file functions, and let's add this to our ever-growing list of functions. Let's see, there is add term, so we will put the update after that. And we have the original term. Let's just use that. And then we will have new term, and then definition. And of course, the first thing we want to do is retrieve our items. And then we want to essentially do what we did for the get term. We want to loop over our terms and find the term that we are going to edit. So let's copy and let's paste that in. And let's change the name of this variable to terms, because that's what we had in the loop. And then we want to modify our check here. We were originally just checking for what was supplied to the function, and we still want to do that. But we want to check if the term is equal to original term. That way we know that we have the item that we want to edit. So we will just say item, and we will say term equals the new term, and we will essentially do the same thing for the definition. So let's copy and paste. And once we're done with that, we can break out of the loop by saying break. Because if we have a match and we update that, there's no need for us to keep going through that loop. We're done. So we will break out, and then we want to set data, and we will pass in our terms. So that should work. Now's the moment of truth. I don't remember if there is the hidden field, so let's refresh. Let's change the text there, and let's add edited to the definition. That way we can see that we both edited the term and the definition. Let's click on edit. That takes us back to our index. We see that the term was changed to JSON1. The definition includes that edited. So we now can create and edit our terms. Now we just need to be able to delete a term as well as protect the admin section. And we will get started with that in the next lesson. We are almost done as far as managing our terms. We are able to create and edit them. Now we just need to be able to delete them. And thankfully, deleting is a lot like editing, at least as far as the setup is concerned. So we're going to start by copying the files that we wrote in the previous lesson. And we will copy the edit controller, and we will rename that to delete.php. We also want to copy the view as well. So let's go into views, admin, and then copy the edit view. And we'll start in the controller, because that's where, well, we're going to have some pretty significant changes in both of these files. But the most important is going to be in the controller. So let's start there. Now, this is going to be a page that is going to display a question. You know, we don't want to just issue a request and then the term is deleted. We want to ensure that the user wants to delete that item. So we're going to have a GET request. It is going to take the user to our view, and it's going to ensure that they want to delete that term. And if they do, then of course it's going to handle the post request as well. So we first of all need to know what item to display. And so we already have that set up where we are sanitizing the key from the query string. We are ensuring that we have a value there. We get the term from our data store, and we ensure that we actually have a term, and then we pass that on to the delete view so that we can display that information. And then as far as the post is concerned, we don't need the definition really. All we need is the term itself that we want to delete. So we can get rid of the definition and the original term because we're not editing in this case. We are just submitting a form that has the term that we want to delete. And because we don't have those, we need to remove the checks for those as well. And then the function that we will call is delete term, and the only thing that we need to pass to it is the term that we want to delete. So that should be it as far as our controller is concerned. So let's go to our view, and let's go ahead and add in the question if the user is sure that they want to delete this. So I'm going to add another div with a class of row, and we'll just say, are you sure you want to delete? And then we will output the key here, or the term itself. And we have that with our model and its term property. So there is that. And as far as our form is concerned, we don't need any type of input. We're just asking a question, are you sure you want to delete it? And then if they submit that form, then yes, they want to delete it. So the only information we need is really this hidden field. We can change the name to simply term, and that's it. So we can get rid of our text box and our text area, and then the submit button will just say delete. And let's also change the text in this H1 element. So this should be all that we need to do inside of the view. So now let's just write this delete term function. We go to our app folder inside of data and then file functions. And I guess after the update term, we will have our function for deleting the term. We will accept the term that we want to delete, and just like all of our other functions, we are going to get our terms. Now, in order to delete an item from our terms array, we are going to use a function called unset. We pass in the array and the index that we want to remove. So if we have an index of 2, then that's what we do. And that means we need to know what index that we want to use in order to unset that item. Well, we can get that very easily using a for loop. So we will initialize our for loop with our counter variable. That's going to be I. And we are going to loop for as long as I is less than the count of our terms. So right now we have 4 items in our terms array. So this loop is going to execute 4 times. And then we want to increment our counter. So inside of here, all we really need to do is check to see if our terms at the index of I has a term property that is equal to the term that was provided to the function. And if so, then we want to remove this item. And we do that with unset. We pass in terms at the index of I, and then we just break out because we don't need to process the rest of our array. We've already found the one that we want to unset there. And then we need to write our terms to the file. So we called that set data. So we will call set underscore data, pass in our terms, and there we go. Now there's one other thing that we're going to have to do here, and that is rebuild the array. And I'll show you why here in a moment. In fact, let's go ahead and prepare to do that. I'm going to open up the data file, and I'm going to copy its contents and paste it into this notepad because, well, you'll see what will happen. So now we just need a link so that the admin can go to the delete page and then delete an item. And we created that edit link inside of the index view of admin. So we can do essentially the same thing for delete. Let's just copy that, but let's put the delete link on the other side of the table. That way we don't accidentally click on delete when we actually wanted to edit. And of course we will change the URL to delete and the text to delete. So now let's just view this in the browser. So if we refresh, we have our delete link. Let's delete JavaScript. So that will take us to our delete page. Are you sure you want to delete? Well, yes. So we delete, and we have successfully deleted that item. But let's look at our data file. Here we have our JSON, but notice that it is completely different. We now no longer have an array. We have an object. And then the properties of this object are the index numbers. We have 0 there, then we have 2, and then we have 3. So here's the reason why. Whenever you use the unset function and you delete an item in the array, it removes that item, but it doesn't reorganize the remaining items. So let's say that we have an array with 3 items. We have index 0, 1, and 2. Now these are indexes, but they are also keys. So if we unset the item with an index of 1, it's going to remove that, but we still have 0 and 2. And it's going to use those as the actual keys. So then it becomes an associative array where the numbers of the index are actually the keys then. So in that case, whenever we re-encoded back into JSON, it uses those keys to refer to the actual object that we were wanting. So that's why we have to rebuild the array. We have to essentially say that, okay, we have unset this item within the array. Now we need you to rebuild this array into a true array, not an associative array. So we can do that with another function simply called array_values. What this does is this will take an array as input, and then it will return all of the values from that array and put them into a new array. So we will have this. We'll pass in our terms, and then we will assign this to new_terms, and then we will pass on new_terms to our setData function. So let's do this again. I'm going to take the data that I had copied before. I'm going to paste that into data.json, and then we will go through that whole process again. So let's go back to the browser. Let's refresh this page. We have JS once again. Let's delete JS, and that successfully deleted. If we go back and look at the data, I don't have to refresh this because it's automatically refreshed, but you can see that we now have a true array in JSON. We have our first item here, CSS, and then after CSS is PHP. You know, it used to be JavaScript, but now it's PHP. And then we have JSON1. So we now have a complete admin portion of our application. The only missing thing is the ability to lock it down so that only authenticated users can access those functions. And we will add that in the next lesson. The last thing that we need to do with our application, at least right now, is add authentication so that we can protect the admin portion of our application. Now, way back in 3.3, we wrote a simple authentication system. So we are going to adapt that to our current application. And really, it's going to be quite simple. The only thing that we really need to do is adapt the login page to use our controller and view instead of putting everything inside of a single file. So let's start with that. And we're just going to fly through this because we've already talked about this authentication stuff. So we're going to adapt it now to our app. So inside of 4.10, not inside of its admin folder, we're going to create a file called login.php. This is going to be our login controller. And the reason why it's not going to be inside of admin is because the login page really isn't part of the admin section. It's there for anybody to be able to try to log in. So that is why it's not inside of admin. Now let's take the contents of our index and let's paste that in because we do need the require. We don't really need any of this other stuff, although we might use the view bag. But the view does need to be login, and we aren't going to pass anything as the model. So we're going to start with that. And let's go ahead and create our view as well. So once again, this is not going to be inside of the admin folder. So we will create a new file, login.view.php. And let's take the markup from the original login.php. And let's paste that in. Now, if I remember correctly, there are some issues with this markup. I don't think it's going to really affect anything, but let's see if we can clean this up a little bit, because here's a form and here's a form. So we need to decide which form is the real form, and it looks like that one is. So we have a form there that's inside of a div with a class of row, and I'm looking at, the lines that line up. Now, I don't see anything connecting that one. So we should be able to get rid of that div with a class of row. That looks okay. And we don't really need this other one either, so we can get rid of that as well. Now these still aren't lining up, but I'm not going to spend too much time on this. Let's change the H1 to login so that the user knows that this is the login page, and that will be okay, at least for right now. So there's our view, and we had the status here. Let's go ahead and use our view bag here. So if view bag status is set, then we're going to output that. So we will do that there. And then we need to work on our controller. So we'll go back to the original login PHP, and we will grab all of that other code and paste that into our controller. Now, the very first thing we need to do is set our session. So let's do that. We're not going to set the title because we don't need that. We aren't going to require any of these things. The config just had the username and password. We, of course, need to adapt that to what our config is set up as. But then we do need some functions that we need to pull into our app. So we will do that here in a moment. And one of those is user authenticated. So I guess now's the time to do that. Those are inside of the INC folder at the root of htdocs. So if we go to functions, then we have the authenticate user. So let's go ahead and copy that. Ideally, we would put these authentication-based functions inside of another file. We could call it auth or something like that. But for the sake of simplicity, I'm just going to add them to our current functions.php. And there's a few other ones too. So let's go back. There's the is user authenticated. We do use that. We also use the ensure user is authenticated. But I think that's it. I think everything else was just for other lessons. So let's copy those, and we will paste them into our current functions PHP file as well, and we should be done there. So let's close that. Now let's go back to login. We are calling is user authenticated, and then we are redirecting to admin PHP. We want to redirect to our admin folder. So let's do admin/, and we'll see if that gets us where we want to go. We do not need to die anymore because that is automatically done in the redirect function. We also have a function for checking for post. So let's use that so that we don't have to type all of that out anymore. We are filtering the email. We'll still do that because that validates that we have an email, but we do need to validate our password. So we'll use our sanitize function, and that should take care of that. Then we will authenticate user. We will set the session email to the provided email address. We will redirect back to admin, so admin/, and we don't need to die. Otherwise, we set the status. So that was viewbag status, and we did that a few lines below as well. So let's just copy and paste. There we go. So that should be it, I would think. We will definitely find out. We do need to visit the authenticate user because we need to modify that so that it's going to work with our config. But we'll get to that in a moment because we need to go to our admin section and we need to add the call to that ensure user is logged in. So let's open up our functions file and ensure user is authenticated. So inside of every file, inside of our admin, we need to add this to our controllers. So the first thing we need to do is session start. Then we will require app PHP. Then we will call our function. So ensure user is authenticated. So let's just copy those 3 lines and we're going to paste them in where we have the require because we need to require as well as start session and check that the user is authenticated. So with that done, we do need a logout controller. We don't need a view because there's nothing to view with the logout. So let's create a new file. We'll call this logout.php, and we will take the contents of our previous logout, and let's just copy that and paste that in. So there we go. And we don't need to die, once again, because redirect is going to do that. We do not need to require our functions, although we do need to require our app. So let's copy that over, and we will put that after we unset and destroy our session. Then we redirect to login. We could redirect to index. Either way would be fine, in my opinion. I'm going to leave this as login. Okay, so let's close all of the files. Let's see if there's anything that needs to be saved. It doesn't. So now we need to focus on what we have inside of our functions, because how we authenticate the user is going to be a little bit different. We aren't going to be using the username and password that is inside of our config. Instead, our config is set up so that the users, well, hello, that's the wrong one. The users is in an array. We have an array of users and then the email address and the password. So I'm going to open up functions next to it so that we have a reference over here. Let's see if I can move this over a little bit, because really I'm just focused on what we have as far as the structure of config. So we want to authenticate our user, and we want to try to grab the user from the config with the provided email address. So we could do something like this. We could say user equals, we'll say config, and our users are at the key of users. So we'll do this. We'll say users, that pulls in our users, and then since we have this array of users, we can say email as the key. Although that's a little cryptic, so let's break this up into multiple lines. So the first thing we will do is get our users. So what we have assigned to this users variable is this associative array. So each key inside of users is going to be an email address. So we could actually do this. We could check to see if that email address is inside of our users. So we're going to use isSet. We'll say users, and then for the key, we will use email. And if this doesn't exist, or if it is not set, then that user doesn't exist. So we just need to return false. There's nothing else that we need to do there. And if we do have a user, then we just need to get the password, which is what we've done here. So we could do this password, or rather user password equals, and then users with the key of email, that gets the value for the provided email address. And then we just compare the passwords. We don't have to compare the email addresses anymore because we've essentially already done that. We have verified that the user at least exists. So if the user does exist and then we compare the password, then of course that user has logged in. Okay, so that was actually easier than I was planning on. So let's test this out. Let's go to login.php. And we will log in as admin at admin.com. Password is 1234. And there is something wrong. The use of undefined constant user password. And that's because I did not use a $sign there. Let's go back. We can actually refresh this and it takes us to our list. So we logged in and we should be able to go to the create and let's recreate JavaScript. So hopefully that still works. It does. So now let's log off. So we'll go back and we'll say log off, or log out rather. That will log us out. We get redirected back to login. That's what we had said. But now let's try to access our create and edit and delete from admin. So the first is the index. We'll just go to straight up admin and it tried to redirect us, but the URL is incorrect. It tried to take us to log in inside of admin, which of course doesn't exist. So we're going to need to fix that, but we can do that in a moment. Let's test create, same thing. Let's test edit and delete. So at least those resources are protected. We just need to set up the redirection so that it is correct. And we could approach this in a couple of different ways, but I'm going to take the easy way out. This ensure user is authenticated. We are only using that from within admin. So I'm just going to do this, .. and that's going to work then. Now, if we had other resources that were protected that were at a level deeper than admin, or within a subfolder of another subfolder of our project, then this would not work, and we would definitely need to rethink that. However, at this point in time, this is going to be just fine. Now and there it works. Now we can't use our app path because that is for the path on the file system itself. That's not a URL that's going to be requested from the browser. So that's the difference here. We are setting an HTTP header, which is going to be loaded by the browser. We are not telling the browser that we want you to go to this file on our file system. That's a security risk, actually. So we can't use that app path. However, we could take the same idea and create a constant that would then be used in the same way for HTTP requests. But once again, for our current purposes, what we have is going to be fine. In this lesson, we're going to start talking about object-oriented programming. Now, this is a topic that is a study in and of itself. And if you've done any type of research on object-oriented programming, then you've had a ton of different terms and ideas and concepts just thrown at you. And if you are intimidated, well, yes, you should be, because there's a lot there. But as far as this course is concerned, don't be. We're not going to be talking about patterns and how to identify patterns and where you should use a particular type of pattern. And, there's a lot of other things. We're not going to worry about any of that. In this lesson, we are going to create an object. In fact, let's look at what we are going to do. Let's open up File Functions. Let's go to the add term function, and we have these 6 lines of code where we create an object. Now, really what we've done is created an associative array. Then we've converted it into an object and stored that as an object in this obj variable. And then we add that object to the items array. So that instead of all of that, what we will do is create an object by using a class, so that we are still going to add an object to our items array, but it's going to look like this. We're going to create a class called glossary terms, and it is going to accept 2 parameters. We'll have the term itself, followed by the definition, and that's it. Our code is still going to work just fine. So I've used this term class. A class is really nothing more than a blueprint for creating an object. So I tend to think of object-oriented programming as in, well, everyday life. We live in an object-oriented world. I have a pen on my desk, and I can pick it up, I can take the cap off, and I can write. I can put the cap back on, set it back down. If I need to write again, I just pick it back up and take the cap off, write, put the cap back on, set it back down. The whole concept of object-oriented programming is so that we can reuse objects. And in order to reuse objects, we need to be able to create them. And just like this pen, the manufacturer has a blueprint for creating these pens. We're going to have a blueprint for creating a glossary term. And we will do that inside of a new file. So inside of our data folder, let's create a new file. We'll call it glossaryterm.class.php. So the class in the file name just denotes that there is a class inside of this file. And we typically have just one class inside of a file. And to create a class, we start with the class keyword, followed by the name of the class. Now, by convention, classes begin with an uppercase letter. You don't have to follow that convention, but you really should. So just use an uppercase letter for the class name, and then the opening and closing curly braces. And there we have just created a class called glossary term. Now, by itself, this isn't very useful. What we want to do is construct an object. That's just a fancy way of saying that we're going to create an object. And we create an object using what's called a constructor function. We define a constructor function just like a normal function, but it is inside of our glossary term class, and it is called __ construct. And other than that, it's just like any other type of function. So we can have our term parameter. We also need our definition parameter. Because remember, whenever we created this glossary term, we passed in the term and definition. So we want our constructor to have those parameters as well. And then we just need to set up what are essentially called properties. A property is nothing more than something that describes the object. So going back to this idea of a pen, this is made out of plastic. So a pen might have a material property that would be set to plastic. The ink color in this is black. So that would be a property. We could call it ink. And then the body color is a dark gray. So in this particular case, we have a glossary term. A glossary term really has two things, the term itself and the definition. So to create a property, we need to first of all refer to this object that we are working with. And to do that, we have a very special variable called $this. We use that inside of a class to refer to the object that we are working with. So going back to where we have called this glossary term constructor, whenever we create this object, this variable is going to refer to that object. That's how it can refer to itself from inside of itself. Sounds kind of weird, but all we are doing here is we're saying that this object's property called term is equal to the value that was passed as the term parameter. Then we will essentially do the same thing for the definition. Now, I do want you to be aware of the dollar signs here. We used the dollar sign for this variable. That's very important, because otherwise PHP isn't going to understand what this is. However, the property name does not have a dollar sign, but then of course, since we are using the parameter that was defined in the constructor function, those begin with a dollar sign. So just remember, this begins with a dollar sign, the property name doesn't. And then of course, if we are referring to a variable or a parameter, then we use the dollar sign there. So what we have done here is we've created a term property and a definition property for every glossary term object that we create. And that's going to match up with what we have done in the other parts of our code. Like for example, in the search terms function, where we use the term property and the definition property, all of those are going to match up. So that now that we have this glossary term class, all we really need to do then is require that new file, glossaryterm.class.php. That's going to pull in that file so that we can then use that glossary term class to create those objects. And so we can test this very easily. Let's create a new term, and let's create one for the extensible markup language, XML. That was the wrong thing. So the definition is extensible markup language. So whenever we create this term, we will see it listed in our list, which means that our code works just fine. But now it's a little bit easier to understand what we're doing here. Not only did we reduce the lines of code, at least as far as our add term function is concerned, but we also made it very clear what we are doing. We are creating a new glossary term, whereas that was kind of lost in our old code. So we can be more concise, we can be more clear as well. Now, you can make the argument that we really didn't need to do that in this particular case, and Yes, that's true. This is a very simple class, but the reason is I needed an example to use, and that was perfect there. But in the next lesson, we're going to create another class, one that we would use to interact with our data store. In the previous lesson, we created a class that represents an individual glossary term. It is aptly named glossary term, and it is very, very simple in that it just has two properties, term and definition, and those essentially describe an individual glossary term object. Now, there's nothing wrong with simple classes because, well, they're simple. They're easy to understand, and as long as they are named well, then you know what they are used for. In this lesson, we're going to create another simple class, but we're going to incorporate methods. Now, a method is really nothing more than a function that works with a particular object. Like, for example, we are going to create a class that encapsulates all of the functionality of our file functions. So we're going to take all of these functions, we're going to cut them out and put them inside of a class. In fact, let's go ahead and do that. Inside of our data folder, let's create a new file. We'll call it filedataprovider.class.php. And let's go ahead and define that class, filedataprovider. And then we're just going to paste in all of those functions. Now, we still have a lot of work to do here, but let's go back to our file functions. So this is essentially what we will be able to do. We can create this file data provider. We can pass in the path to the file that we want to work with. And then we can use this object to get the terms, if that's what we want to do. We can use it to search the terms. You know, all of the functionality that we had, we essentially will still have, but it's now encapsulated inside of this class. And it might not be clear as to why we would want to do this now, but I guarantee you this is something that we definitely want to do. So we want to make all of this work, and there's quite a few changes that we need to make. So let's go to our file data provider. Let's define our constructor. So let's go ahead and have that. Now, we need to know the file that we are going to be working with. Now, yes, we have that inside of our config, and we could use our config to do that. However, whenever we create an object, we want it to be its own autonomous thing. We don't want it to be dependent upon anything that is outside of that object. So, in order to know what file that we want to work with, we need to pass that to the constructor so that we can store that in a property. And I didn't mention this in the previous lesson, but a property is a class variable. It is accessible throughout the entire class. So by doing this, we're going to be able to access this file path in every one of these methods. Like, for example, this getData function. Let's go and let's find getData. It's at the very bottom. So here we are using the config, or at least we were using the config, to get the data file setting. Well, in this case, we don't want to do that because that is outside of this class. We only want to work with the data that is inside of this class. So we are going to use our file path property there. And notice once again, I'm using this variable in order to access that information because that is part of this class or this object that we are working with. The same thing for the setData function. We want to refer to the file path as opposed to the configuration options. And in fact, we can even get rid of this fname variable because, well, we don't really need that anymore. All of that is part of our class data. So let's go ahead and let's get rid of that. That cleans up our code, except in maybe getData. It might be cleaner to have the fname variable, but we'll just run with this and go from there. Now, if we tried to use this file data provider class right now, everything would fail because we no longer have a function called getTerms or getTerm or searchTerm. Instead, we have methods, and we access these methods the same way that we would access our properties. So we need to use the this variable in order to access these methods. So inside of getTerms, where we call getData, we need to put this and then the arrow in front of it. We need to do that in front of all of these calls to these methods. And remember, a method is nothing more than a function, except that it is encapsulated inside of a class. So really the only thing that we are doing here is just changing the location of those functions. And yes, it does require us a little bit of extra work in order to get this all set up, but I guarantee you it is worth the time. The only thing is that we need to make sure we reference all of our methods correctly. And if we didn't, we'll find out very, very soon. But we aren't done yet. There's one other thing, and that is accessibility. Now, classes are very special. There's a lot of features that a class provides, and one of those is the ability to hide code and hide functionality. Like, for example, we could hide the getTerms method so that it cannot be used outside of the class. So that if we tried to use getTerms, then PHP would actually throw an error because it would not be able to find getTerms. Well, that of course doesn't make sense because getTerms is definitely something that we want to be able to call from outside of the class. So we should mark this as a public method. That means that it is accessible whenever we are using the object. And we really want most of these to be public because we want to be able to get a term. We want to be able to search or add or update or delete. But when it comes to getting the data from the file or setting the data to the file, we don't need to access that outside of the class. These are things that our other methods rely upon. So really what we should do is mark these as private, because there's really no reason that we should be calling getData or setData from an object like this. I mean, there's no reason. So with those changes, we now have a class that's going to allow us to work with that data. Of course, we've kind of broken all of this. So the first thing we need to do is go to our app.php, and we need to require this class. So really we don't need the file functions because those functions are gone. So let's change that to filedataprovider.class.php. Now we do need to require our glossary term inside of the file data provider because we do use that class. And let's go ahead and delete file functions. But then we also need to go to the other parts of our application and use this new class. So if we go to index.php, not inside of admin, here we are using search terms and we are using get terms. So for the sake of simplicity, we're going to new up the file data provider. We need to pass in the path to that file, which is currently inside of our config. And we will pass that value, which was data file. So we will have that there. And then we can use that data in order to search and get the items. Now, of course, other parts of the application is not going to work. That's going to be fine because we will eventually fix all of that. But let's go to the browser. Let's refresh the page and notice that everything works just fine. And if we comment out this line that gets our terms, we are, of course, going to see that, well, things have gone very wrong there. So we know that our code is working. But this also adds a complication in that every time that we want to work with our data, we have to create this new file data provider object. Wouldn't it be nice if we just had one throughout the entire application so that we could access it through the config? Like this, for example, if we said config and then provider, and then we would use our methods. Well, that is something that we can definitely do, and we will start implementing that in the next lesson. In the previous lesson, we created a class that encapsulates all of the functionality of interacting with our file, and it did require extra work. However, we have a more flexible and robust application, and unfortunately, that's just the trade-off. If you want a flexible application, you have to put the work in and write the extra code. But let's briefly talk about what we have now that we have a file data provider. Well, one thing is that if we ever decide to use multiple files within the application, all we have to do is just create another file data provider object, and then have it look at whatever file we need it to, and now we have two objects that interact with our data in the same way, and we didn't have to write any new functions or anything like that. And that's the beauty of object-oriented programming. We are able to reuse functionality as often as we need to. But something else, and this is what our ultimate goal is. We want to move our data store into a database. And it would be really nice if all we had to do was this: change the name of our data provider so that we would use a MySQL data provider that looks at a database and interacts with it in order to get, update, and delete our information. And we will eventually get there. However, we will need to make a few changes because our data structure is going to change when we get there. But that's in the future. We don't need to worry about that. But this is the goal, so that all we have to do is just swap out whatever data provider that we are going to work with, and our application would still work without any other modification. Well, in this lesson, I want to add a little bit more flexibility. I want to use what's called a data abstraction layer. Basically, the idea is that we abstract all of the functionality for interacting with a database so that we don't directly use our data object. Instead, we would use a class, and it's a special type of class called a static class, so that it would look like this. We have data, and then we would search and pass in the information that we wanted to search. That way, this data class that we would be using would be responsible for working with our data provider, and the rest of the application doesn't care how it works. It just knows that this data class is going to provide that functionality. Now, I use the term static class very loosely because in PHP we don't really have static classes. We can define a class that has what are called static members. Now, as far as terminology is concerned, a member is just a property or a method. That's just how we group those things together. It's a lot easier to say members as opposed to properties and methods. So, what then does it mean to be a static method or a static property? Well, let's look at our file data provider. So whenever we create a file data provider, we give it the file path, and then we save that as a property. Now that property belongs to the object that we create. So whenever we create a file data provider object, all of these methods, all of the properties belong to that object. And once we create an object, they are unique to that object. So for example, this data object that we've created is unique. It works with its own unique set of information. Now, a static property or a static method belongs to the class. It does not belong to any object. Instead, it belongs to the class. So whenever you use a static property or a static method, the syntax is different. If you notice, whenever I wrote this code, we used the name of a class followed by 2 colons and then the name of the property or the method. So the syntax itself is kind of alluding to the fact that search term is part of the data class as opposed to being part of an object. So let's write this data class, or at least let's start to do so. Let's create a new file inside of data, and we'll call this data.class.php. And it's going to start off normally. We will have class data and then our curly braces, but a static class doesn't have a constructor because we aren't creating objects with this class. Instead, we just define the static properties or the static methods that we need. So let's start with the getTerms. We're going to use the keyword static, followed by public and then function, and then the name of this method, getTerms. And this is going to do nothing more than use our data provider's getTerms method. But then how do we get a data provider in here to work with? With our file data provider, we provided data that the class needs through the constructor, such as the file path. Well, since we don't have a constructor, we aren't going to be able to use a constructor to get data into this class. Instead, what we could do is just write another method. In fact, let's make this the first method. And we'll call this initialize, so that we will initialize our data class with a data provider. And then we will store this in a static property so that we can access it throughout the class here. Now, as we are inside of the class, we don't really use the name of the class in order to access a static method or property. Instead, we use self. Now, I've always found this interesting because if we refer to an object, we use this, which has a $sign, whereas with a static class, we don't. We use just the word self. Just something else as far as the syntax is concerned that alludes to the fact that we are interacting with a class itself as opposed to an object. But then after self, it's the same syntax. We have 2 colons, and then we have the variable that, or the property that we want to interact with. In this case, we're just going to call it DS, short for data store, and then we will set that to data provider. Now, one thing I do want to do is go ahead and just define this before we assign it, and we will do that outside of any method here. So we will make this private because it doesn't need to be accessible from outside. That's why we have this data class, so that it is going to work with the data store as opposed to anything else. So now inside of getTerms, all we have to do is just return the result of calling our data store's getTerms method. So it's going to look like that we are going to have a lot of repetition, and kind of in a way, yes, we do. But the idea is that our data class is wrapping around our data store or our data provider so that we don't have to worry about working with the data provider directly. And I just pasted in the code because once you do it once, it's the same thing all the way down. So now that we have this data class, the first thing that we need to do is make it accessible throughout our application. And the app file is really the central part of our application. So let's just copy that line. We want to include data.class.php. And now we will initialize our data class, and we will provide it the file data provider. So we're just going to call the constructor, passing in the result of calling that constructor. And there we go. And I like this particular approach because, first of all, we now have this data class that we use to separate our application from our data providers. But we have also protected our data providers, because let's look at where we have first created that file data provider. We assigned it to a variable. Well, a variable is just a variable. Somewhere down the line, we can mistakenly set it to something else, and that's going to break our application. And there's really no way to make this a constant like we did inside of config. It would be great if we could come in here and we could use the constant like this. But we can't, because we can't have objects in a constant. That's just a limitation of PHP. So we have separated the application, or the main application code, I should say, from our data providers. And we've also protected it, because now we can't just come in here and erase or change the value of our data provider, because it is now protected inside of this data class. So all we have to do now is just use the data class everywhere that we need to. So all we have to do then is just copy this data : and since all of the method names are the same, we'll just paste in data class. So that was index. Let's look at detail. Here we'll just paste in the data class, and I think that that's good to go. Now the admin is going to require a little bit of extra work here, but for the most part it's going to be relatively simple. We'll just add in data anywhere that we are interacting with our data store. So here we are getting the term so that we can later edit that. So we want to update term there. We'll go to delete, which is kind of the same thing. We get the data, and then for a post request, we delete the data. And then for create, all that we need is right here, add term. And I think everything else should work just fine. So if we refresh this page, everything is going to work. Let me make sure everything is saved. Yes, it looks like it. We can close all the files, and that will tell us, yes, everything is saved. So we can easily view our information. If we go to the admin, we will need to log in. But after we have logged in, we should be able to edit any one of these. Let's edit XML. Let's delete XML, and let's create a new term. This will be JS2. We don't really care because we just are testing the functionality. So everything still works as it did before, but our application code is much more flexible now that we have a data abstraction layer. In the previous lesson, we created a static class called data that we can use in our application to interact with our data store. But of course, our data class needs a file data provider in order to actually work. Now, the technical term for this static class would be an abstraction layer. We have abstracted away all of the details for interacting with our data store so that our application really doesn't care how that's done. And that then allows us to be able to swap out data providers whenever we need to. Abstraction layers are a very powerful thing that you can add to your applications. The most common use for them is to be able to use different data stores or different types of databases. Like there's a lot of software out there that supports both MySQL databases and Microsoft SQL databases, and they would use a data abstraction layer so that the customers using that software can use whatever data store that they want. Now, that's all well and good. However, we do have an issue here in that we can technically pass anything to this initialize method. Here I've passed a string, and if we try to look at this in the browser, of course, it's going to blow up because a string does not have the methods that our data provider has. We need to be able to get terms or search terms or add, update, or delete a term. So we need some way to ensure that whatever we pass to this initialize method has the necessary methods to work with our data. Now, we can mentally keep track of that, and that's perfectly fine. However, we can also write a little bit of extra code and let PHP worry about what we pass to initialize. And I much prefer that approach because the less I have to worry about, well, the happier I am. So there's different ways that we can accomplish this. And in this course, we are going to use inheritance. But before we get into that, let's just look at inheritance. So let's create a new file. This is going to go in the root of 5.4, and I'm going to call it pen.class.php. This isn't going to be part of our application, but we need a code file for some examples. So I've used, just a pen as an example when talking about objects. So let's write a class that we would use to programmatically represent a pen. So we would have a property called ink color, and then we could have a public method called write, because every pen is going to have a color. It's going to be able to write a message, and we're just going to echo out that message. And that's great. However, we need to be a little bit more technical here, because we don't really think about different types of pens. We just pick up a pen and we just start writing. However, if we're going to be making pens, we need to be very specific. We need to be very detail oriented. So the pen that I have in my hand right now has a cap, and not every pen has a cap. Some are retractable. So if we are actually going to write with these pens that we are creating, we need methods to be able to take a cap off and to retract the point. Now, it doesn't make sense to add methods in this pen class because not every pen has a cap and not every pen has a retractable system. So instead, it would make much more sense to create classes to represent those other types of pens. So we can do that. Let's go ahead and let's write a class called capped pen, or we could just say pen with cap. And then we could have our public ink color, and we could have our public write. And as you can see, I am essentially duplicating all of the code that we wrote for the pen class. Well, we don't want to do that because in object-oriented programming, we have this concept of inheritance. Now, inheritance in programming is a lot like genetic inheritance in that we, human beings, are inheriting the properties, the traits, even behaviors of whoever made us, our parents. And that's the same thing that happens in our applications. So what we have here is two classes. We have a class for pen, then we have a pen with cap. What we want to do is inherit the ink color, because every pen has an ink color. We don't want to have to duplicate that over and over again. And every pen can write. Once again, we don't want to duplicate that for every class. So instead, we extend the pen class. And then automatically, we inherit all of the traits and behaviors from pen. So that by default, automatically, our pen with cap gets the ink color property. It also gets the write method. So if we wanted to create a capped pen, we could easily do that by calling the constructor, and then we can toggle the cap because we need to do that before we write, and we will write something. I mean, it really doesn't matter what, but we'll just write some text, and then of course we would want to put the cap back on, so we would toggle the cap. Well, let's look at the same thing for a retractable pen. So we can essentially take what we've already written for our pen with cap, we can copy and paste, except that this is going to be retractable pen. It extends the pen, and the method that it's going to have is called toggle point. So now we can create an object that represents a retractable pen. I'm going to call it rect pen. And we would essentially do the same thing, but instead of this case, we would toggle the point, we would then write, and then we would toggle the point again to retract it. But let's make this a little bit more complete because we do need to set the ink color here. So we can have our constructor, and that's where we would put the ink color. So we would pass that there, and we would set that inside of the constructor. And so by doing that, we don't have to declare that there in the class. So now we can say that the pen with the cap, that's going to have black ink. The retractable pen is going to have blue ink. And even though we don't have a constructor and we didn't define the ink color inside of pen with cap or retractable pen, those things are going to be there automatically. Now, not only can we inherit the traits and behaviors, but we can also override anything that was defined. So if we wanted to, inside of the retractable pen, we could write our own write. If we had some customizations that we needed to do, we could do it with here. And I'm not sure what we would want to do, but we could just say that written with retractable pen, and then we would include the message. So now our pen with cap would just write the message that we passed to it. The retractable pen would use the write method that overrides the original one because we define that inside of our retractable pen. So with that in mind, we can go to our data folder and let's create a new file. We'll call it dataprovider.class.php. And this is going to be a base class for all of our data providers. And to save us some time, let's go to our file data provider and let's copy that code and then paste it inside of data provider. And really the only thing that we need to be concerned with are the methods, but we don't want any default behavior here because when it comes to working with our data, that is specific to each individual data provider. So these methods aren't going to do anything. They're just going to be there so that we can overwrite them later. Now, these private methods for getting the data and setting the data, those are specific for our JSON implementation. So we're going to delete those. We don't need those here. And one other thing I'm going to do is change our property name because this is a generic data provider. It's not really working with a path. It's not really working with anything. So I'm just going to call this source. So for our file data provider, it's going to be the path to the file. For our database, whenever we get there, it's going to have the information for connecting to our database. And with that done, we can go to our data class and let's go ahead and require that data provider. Because what we're going to do is use a type hint for our initialize method so that only a class that inherits from data provider can be passed to it. This means that in file data provider, we can get rid of this require because that's being done elsewhere. We do need to change some things here. Now, first of all, we can get rid of the constructor because that is being inherited from the data provider. We do need to extend data provider, and we need to change our file path that is now source. But other than that, everything else should work fine. And of course, we will definitely find out if it doesn't. And now we need to go to app because we do need to include, well, no, we don't. We are automatically including that data provider, aren't we? So everything should still work as is. Let's refresh, and there we go. Everything is working just fine. Now, if we try to pass anything else to initialize, we of course are going to see that it's not going to work. But now we're going to have a different error message than before. Uncaught type error. Argument 1 passed to data initialize must be an instance of data provider. So now we have something that's very clear. If we pass something that is not a data provider to this initialize method, then we see an error message explicitly saying that. And that's much easier to fix than trying to track down why a particular object didn't work for our data provider. So there we go. By using inheritance, we have made our application a little more robust so that in the next lesson, we can get started working with a database. Well, it is finally time for us to start shifting towards using a SQL database for storing our data. And before we just jump right in and start doing that, let's very briefly go over what a database is and how and why we would want to use a database. We'll also talk about how to manage them as well. So let's first of all talk about what is a database. Well, it is very aptly named. It is a place for storing data, especially text and numeric data. Now that might sound very limiting, and I guess it kind of is. However, the vast majority of applications, that's the data that you're working with. It's text in some way or shape or form and numeric data. Now you can technically store binary data like images, zip files, anything else that could go on the file system, you could technically store in a database. However, a database really isn't designed for storing that type of information. We use SQL, which stands for Structured Query Language, in order to promptly find information and then update it, read it, delete it, whatever it is that we want to do. And if your data is binary, SQL is not designed for working with binary. However, it is highly designed for working with text, numeric data, dates, and just simple data types like that. And when it comes to a database, our data is stored in what we call tables. And a database table is a lot like a table that we would have in a web page. Like, for example, our table here has two columns. We have the column of the term, then we have the column of the definition. And even though we don't have headings here, this would easily translate into a database table. Because what we do is define a table and the columns inside of that table, and then each row is a record, and it contains the information that we would want to store in that table. So we can essentially translate our table here into a database table very, very easily. So let's do that. And to do that, we need to get into some kind of management application for our database, because we have to, first of all, create the database, then we have to create the table, and we could technically do that through the command line. But when it comes to working with the database, I like graphical tools. And thankfully, we have one already available to us. If you're using MAMP, just go to the MAMP application, click on Open Start Page, and then go to Tools, and then PHP MyAdmin. This is an open source management tool for MySQL databases. It is a very old application. Well, it's been around for a very long time, I should say that. It is actively developed, it is updated, and it is rock solid. Now, if you're not using MAMP, if you're using something like XAMPP, which I have magically turned to, we can get to PHP MyAdmin almost the same way, except that in this particular case, we would go to localhost and then PHP MyAdmin. Either way, it's going to take us to PHP MyAdmin so that we can start managing our database. So over on the left-hand side, you're going to see that I already have some databases here. But for our purpose, we want a new database for storing our terms. And so we're going to click on New, and we're going to enter the database name of Glossary. Now, the UI here is a little busy, especially on smaller size screens. So if your eyes tend to glaze over when there's a lot of things on screen like mine, just take your time, try to pick apart what part of the UI is really what you need to focus on, because especially after we create this and we go to the next screen for creating a table and actually defining that table, well, you're going to see what I mean. So we want to create a table. And in our case, our table is going to be very, very simple. We just want to store the terms and the glossaries. So let's call this just plain terms, because that is what we are storing in this table. And then we can choose the amount of columns. Now, we aren't bound to whatever we specify here. So if we need more, we can always add more. And if we need less, then, well, we can just leave some blank. But we're going to use 3. Now, you might think, why 3? Especially because our data is just 2 columns. Well, there's a third column that we typically always want to have in every one of our tables. It's called a primary key. It's a way that we can identify an individual record within the database. Now, you might think that we could do that with the term, and I could get behind that, except that some of these terms might have multiple meanings. I mean, I can't really think of that off the top of my head, but it's possible. So it would be nice to have some kind of identifier that we could use to identify an individual record. And that's what that third column is going to be. So let's click on Go. And this is the UI that, to me, just tends to be way too busy. So we have several columns up top: name, type, length values, blah, 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 blah. And then we have 3 rows here. These are the columns that we are going to create. And the first one is going to be simply ID. We could call this whatever we wanted, but by convention, across all languages and all platforms, ID is typically what we would use to denote the primary key for that table. Then we can choose the type of information that is going to be stored for that column. And in this case, it is an integer. That's what we want. That is what most IDs are. Let's scroll on over. There's a lot of things here that we can talk about, but we're going to skip most of it. And we're going to go to this AI. This stands for auto increment. And we're going to check that. And it's going to ask us to add an index. Don't worry about any of that. We don't have to worry about indexes right now. And you won't worry about indexes until you just really need to start worrying about database performance. But for now, just click on Go. And what this is going to do is make this ID column automatic so that whenever we add data to the database, we don't have to worry about the ID. The database is automatically going to assign an ID for every record that we add to the table. So that's what that auto increment is. So the next thing that we want is the term, and the term is not an integer. So let's look at the drop down, and at the very top, we're going to see the most common types of data. There's int, varchar, text, and date. Now you might think that we need to go with text, but one thing to consider is the amount of data that you expect to use. Text is a very large type of data. And if we choose text here, then behind the scenes, the database is going to allocate the maximum size available for text for every record. And in this day and age, storage really isn't that big of a deal. But when SQL databases were first created, it was a very important deal. So you only wanted to specify the types of data that you absolutely needed. And that's a good practice to follow. So we're going to use varchar, which is also a string, but it's a variable sized string, so that we could say that we only need a single character or 2 characters or 250 characters. Now for our terms aren't very long, but I want to be sure that we have enough for our purposes. So I'm going to say that the length can be 50. And we're going to leave everything else alone. The next is the definition column. That is going to be a varchar as well. Once again, we could use text, but our definitions aren't going to be more than 65,535 characters. I mean, that's the size of a text column. That's just way too much. So we're going to say that our length is 250. That should be fine. That's probably more than what we need, but that is just fine in our case. And so now we just want to save this table. So we will click Save. And then we get a brief readout of the structure. We see that we have this ID. It now has this key. That is the primary key. By checking that auto increment option, it automatically set that as the primary key. Then we have term, and then we have definition. So now we have a table ready to go. All we need to do is connect to the database and then start inserting data. And we will start doing that in the next lesson. In this lesson, we're going to start writing our SQL data provider. And to do that, we need 3 pieces of information, because before we try to read, update, delete, or do anything in the database, we have to connect to that database first. So let's go to our config, and we're going to add 3 things here. The first is going to be the connection string. I'm just going to call this DB. And the connection string contains a wide variety of information. The first thing is the type of database that we are connecting to. So in our case, that is a MySQL database, followed by a colon. And then we need the name of the database that we want to work with. That is DB name equals, and in our case, that is just glossary. So glossary. So we have a MySQL database with a DB name equal to glossary, semicolon. Next, we need the computer that the database is on. and that is localhost for us because that is where our database server is. And then finally, after the semicolon, is the port of the database server. Now this is going to be different based upon however or whoever installed your MySQL database, but you can easily find it by going to PHP MyAdmin, go to Home if you're not already there, then go to More and then Variables, and you're going to get a big list of things, but you can just type in port, and right here, port 3306 for me. Yours might be different. So we of course want to set port equal to 3306, and there we have our connection string. It contains all of the information that we need there. So the next thing that we need is the username, because not everybody can just connect to the database and just start working with that data. You have to log in as well. Now this is of course going to depend upon however or whoever set up your MySQL database. But if you're using something like MAMP or XAMPP, then chances are the username is root and the password is root. But of course, it really depends upon your particular instance. So in our case, root and root. Now, in my case, it might not be root, but we will definitely find out if it's not. And that's it. So we're done with our config. Let's go to our data folder and let's just copy the data provider class because that's going to give us a good starting point there. So let's call this MySQL data provider.class.php. We of course need to change the name of the class to MySQL data provider. Let's get rid of that require statement. And this of course needs to extend data provider. We don't need the constructor. And now we need a method for connecting to our database because before we get terms, add, update, delete, we have to connect every single time. So let's create a method called connect. This is of course going to be private because it doesn't need to be accessed from outside of the object that we use for our data provider. And we are going to try to create an object, and we're going to catch an exception that may occur because if something did go wrong, if we were unable to connect to the database, then we don't want to just display an error. We want to return null so that we know that we don't have anything to work with. And so inside of the try block, we are still going to return, and we are going to create a PDO object. PDO is how we interact with the database, and it is fairly new to PHP in that before PDO, we would have a set of functions for a specific type of database. So if you were using a MySQL database, you would use a certain set of functions to work with MySQL. If you were using a Microsoft SQL database, then you would have another set of functions specifically for working with Microsoft SQL databases. And of course, if you were using some other type of database, then you would have another set of functions. It was a mess. And PDO just kind of does all of that work for us so that we don't have to worry about using different types of functions or anything like that. We just create a PDO object and use that to interact with our database. So as far as the information that we need to pass to the constructor, it's very straightforward. The first thing is the connection string, which we're going to have inside of our source property. Because whenever we call the constructor for our MySQL data provider class, we're going to pass in the connection string. That's going to be that source property. The second thing is the database username. So we will go ahead and have that as dbuser. Was it dbuser? Yes, it was. So dbuser. And then we will have the password. So all three of those new configuration options are going to be passed to our PDO constructor here. Now, if this succeeds, then we are going to have a PDO object that we can work with. If not, then it's going to return null. Now, we do need to have something in this catch. And if a PDO exception occurs, then we want to catch that and return null, because that would mean that for whatever reason we couldn't connect to the database. It could be because some of our information is incorrect. It could also be that the database server is down. And if that's the case, then we would have to find out why. So now all we have to do is do the actual work. And in the next lesson, we are going to implement the add term method, because right now we don't have any data in the database. So it makes sense to start there so that we can have data. The next thing that we need to do is get some data. Now, we can do this in a couple of different ways. The first would be to just insert data using PHPMyAdmin, because we can do that. You can go to the terms table, click on insert, and then we can supply values for the ID, well, not really the ID, but for the term and the definition columns, because the database will handle the value for ID for us. And that's perfectly fine, but we do need to write the functionality for inserting a term into the table. So let's just go ahead and write the code for that. So we are going to implement add term in this lesson. And the very first thing that we need to do is connect to the database. So this is going to give us a PDO object, if you'll remember. If it fails, then it's going to give us null. So we need to do two things. First, we need to call the connect method and then check to see if that is null. And if it is, well, then we're just going to return, because there's really nothing for us to do because we don't have a connection to the database. But after that, then we just need to construct our SQL statement and execute that statement. So let's create a variable called SQL. This is going to contain our SQL statement, or our SQL statement. And SQL is an entirely different language. And we're not going to spend a whole lot of time going over the commands and syntax and everything, because this is something that you will learn as you keep going on. In fact, I'm still learning things about SQL, and I have been using it for well over 20 years. So, there's that. Now, to insert data, we have an insert command. We are basically saying that we want to insert into a particular table, and our table is just terms. Now, notice the casing here. SQL is not case sensitive. So we could actually change this to be whatever we wanted as long as the word was insert. So it could look like that, and the database is going to be just fine with that because it is not case sensitive. However, the convention is to use all uppercase characters for any SQL keyword. So insert, into, and then our table name. And then we get to specify the columns that we are going to provide values for. Now, since we only have 3 columns, we can only have 3 options here. But really, one of those columns is being managed for us, that ID column. So really, we only want to provide a value for term and definition. So we provide those 2 column names separated by a comma, and then we specify the values that we want to provide for those columns. And then we can just add in our term and our definition. Now, here's one very important thing. Never trust user input, especially when you are working with a database, because an attacker can use what's called a SQL injection attack. Basically, what they would do is, let's go to admin. And if they click on create new term, they could actually insert SQL into either one of these fields. And they could do one of 2 things. They could output information, or they could completely wreck our database. Both of those scenarios are not what we want. So instead, what we can do is use SQL parameters. And I apologize for switching in between the terms SQL and SQL. But just know whenever I say SQL, I am meaning SQL, and vice versa. So what we are going to do is use parameters. These are a lot like a parameter to a function or a method, in that we simply define the parameters that we are going to provide. So in this case, our parameter begins with a colon followed by the name that we are going to use. So term and then definition. Now, as far as these parameter names are concerned, these could be whatever we wanted. If we wanted one to be foo and the other to be bar, that's perfectly fine. There's no correlation between the name of our parameter and the columns that we define. However, the order in which we define these things are very important, because if term is first in our column list, well, then term needs to be first in our values list. If definition is first, then definition for our values needs to be first. So it doesn't matter what order we put these in, just as long as we match the column position with the value position. But I tend to go in order of how it's defined in the table, but that's not a requirement. All right, so we are going to insert into term. It's not term, it's terms. And then we have the term and definition are the columns that we are going to provide values for, and then we provide those values. And we're going to use this SQL statement to create a statement object. And we do that by calling the prepare method on our database object. This is going to create what's called a prepared statement, so that we can then execute that statement and then pass in the values for the parameters that we specified. And that's just going to be an array where the keys are the name of our parameter names. So term, in this case, is going to have the value of term. And then definition is going to be, of course, our definition parameter from the method. Now, by using a prepared statement here, we are essentially protecting ourselves from any type of SQL injection attack. If we took the term and definition and plugged them directly into our SQL statement, that's bad. However, since we are using a prepared statement using these parameters, then we have essentially protected ourselves, and we don't need to worry about that type of attack. So after we execute this, we need to set our statement to null, and then we want to set our database object to null. That's going to free up those resources, and we definitely want to do that. And so with that done, let's go to our app, and we need to change out our data provider. We want to use our MySQL data provider. Let's go ahead and bring that in as well. So let's just copy and paste, make the necessary changes. And as far as what we pull in from the config, we want that connection string, which I think was just DB. But let's take a look. And yes, that is. So we should be able to do this. Let's go back to our application. Let's refresh this page. And right now we are interacting with our database. So we should be able to put in CSS and cascading style sheets. And let's create that term. Now we can see that there's an invalid argument supplied in for each, and this is from the index view. That's because right now our data provider doesn't know how to read the data from the database. So in order to make sure that this worked, we have to go to PHP MyAdmin. Let's click on the terms table, and hopefully we are going to see something here, and we don't. And it could be that my password is incorrect. So let me try this. I'm going to change my password to just a blank password, and we will try that again. So let's go back. The term is CSS, cascading style sheets. Hopefully that will work. This error is fine, but let's look at the database. So let's browse once again, and there we go. We have our data. And, you know, I've said this before, but this is a little busy, but here it is right here. Our data is right here. Our term CSS, our definition, cascading style sheets. So now we have the ability to add terms. In the next lesson, we are going to read the data from our database and display that so that we can easily see the changes that we make to our data. In this lesson, we are going to read data from the database, and I often think of reading as the most important thing when working with data, because a lot of times you need to be able to read before you can do anything else, like updating or deleting, because if you can't read, what do you know what you want to update or delete? So reading is kind of important, at least in my opinion. So in this lesson, we are going to go to our MySQL data provider and the getTerms method. We want to display our terms here, even though we just have one right now. So we can start by copying and pasting some of the code from add_term. Because we want to create a database connection, we need to check to see if we actually have a connection. And if not, we still want to return, but in this particular case, we want to return an empty array because the code that relies upon getTerms expects an array. And we can see that just with this error message here. We are expecting something that we can use the for each loop over. And it's not getting a for each, so therefore we are getting this error. So we can fix that by always returning an array from getTerms. It doesn't matter if it's an array of glossary term objects. It doesn't matter if it's an empty array. What matters is that it is an array. Although if we do have data, it needs to be an array of glossary terms, because once again, the code that's using getTerms is expecting that data. Okay, so now we just need to query our database. So let's create a variable called query, and we are going to use our database objects query method. That is the technical term for finding data in the database. We are querying the database, and we use the select statement to query the database. So we want to select the columns that we want data from. So we want all three columns in this case. So we can say that we want ID, term, and definition, and that would be fine. If we only wanted the term and definition, we could just specify term and definition, and the order in which we specify these columns doesn't matter, but it will return the data in whatever order that we specify. So if we were to execute this query, it would come in the form of the definition before the term. But that's not that big of a deal, especially whenever you fetch data and map that to a class, which is what we are going to do. But in this particular case, we want all three columns. We want the ID, the term, and the definition. So we can explicitly type those out, or we could just use the asterisk. We could say select asterisk, and that would mean that we want to select all of the columns from our terms table. And there's our query. So with that query, we can then fetch all of the data. So we need to use our query object. We'll call fetch all, and we can use PDO's fetch capabilities to fetch the data and map it to a class. So whenever we call fetch all, we're going to pass in PDO : which you know means that we are accessing a static member on the PDO class. In this particular case, fetch class is a static property. So we are telling PDO to fetch the data as a class, and then we need to tell it what class we want it to map to. So that is glossary term. Now, our glossary term class has a constructor, and it accepts the term and the definition. And we could set a few more settings here whenever we call fetch all to handle that for us. However, I'm going to take the easy way out, and we're just going to comment out the constructor. Because here's the issue. By default, PDO doesn't know anything about the glossary term class. It doesn't know that it has a constructor, and it doesn't know that the constructor accepts two values. And if it passed in the wrong value for the wrong parameter, well, then you end up with wrong data, basically. So we're going to comment out the constructor, and we're just going to define the properties so that we have an ID property, a term property, and then the definition property. And there we go. Now, by making this change, it does require us to go into the file data provider and make the necessary changes here. But we're not going to do that because we're not going to go back to our file data provider. I mean, if we wanted to be absolutely correct, then yes, we would need to do that. We would also need to modify our file data provider to rely upon the ID as well, because we will be making that change as we implement these other methods. But we're not going to worry about file data provider. We're going to stick with our MySQL data provider. All right, so we are fetching the data. We are mapping that to the glossary term class. So this will give us an array of glossary term objects. And then at the end of this method, we want to return that data. But just like in the previous lesson, we have this query object and this DB object, and we want to free those up basically. So all of the resources that are being used is going to be released, or at least marked for release, so we don't have to worry about any resource issues. So now if we go to the browser and refresh, we have our list. That's perfect. And if we added any other items, let's go ahead and do that. We need to log in so we can add something else. Term JS definition JavaScript, and then create term. There we go. And notice though that we are able to see this list as well, because this list is using the getTerms method. And so if we go back to our index, then we will of course see that as well. Now in the next lesson, we are going to continue reading data from the database, but we're going to do so using the ID of a record. We want to fetch a record with the given ID. If we go back and look at our database table, we now have those two records. And before, with our file data provider, we relied upon the term. But now we are going to use our IDs as our unique identifier for each one of these terms. So we need to change our application to, first of all, use the ID, and then we will use that to fetch an individual record in the table. In the previous lesson, we started reading from the database, and we can at least display our list of terms. But now we need to be able to select an individual term so that we can display the details. But we also need to address the URL parameter, because before we were using just the term itself, because our data provider was a very simple file data provider. There was no primary keys or anything like that. And now that we have a proper data store, we have an ID that we can use to refer to an individual record in the database. And this is actually ideal. It will make this application more flexible because we can now have multiple definitions for the same term. So if JS had multiple definitions, we can have multiple JS terms with different definitions. And because everything is based upon the ID, we could go to the details for a specific definition. So the first thing I want to do is go to our index view. And I want to change the value that we are using for the term URL parameter. So instead of the term property, we are going to use ID. And there we go. We've changed that. So now if we go to either one of these, we can see that our term is now a numeric value. So now we need to go to our data provider, and we want to implement the getTerm method. And it's going to be essentially a combination of what we did in the previous lesson and what we did for the add term. So let's start by copying the code for add term, and we are going to paste that into getTerm. Once again, we want to connect to the database, and we want to ensure that we have a connection. Now, in this particular case, it's returning nothing, really, but that's okay, because whenever we don't return anything, we see that it's not found to begin with. So we don't need to do anything like we did in the previous lesson to where we returned an empty array. We don't need to return an empty object or anything like that. So we have our database object, but our SQL statement is not an insert. Instead, we are still reading data from the database, so we are going to use a select statement. So we will select all from terms, but then we have a condition. And it's not if or anything like that, it's simply where. We want to select all from terms where the ID is equal to whatever value we specify as the ID parameter. So we are still going to build a prepared statement here because we do need to include this ID, which is the term that's passed to our method. And we still want to execute because we have to specify what that ID is. But then from there, the rest of the code is like from the previous lesson in that we are going to fetch the data and we are going to let PDO map that to a glossary term object. But here, let's do this. Let's check to see if our data is empty. And if it is, then we will simply return. Otherwise, we set our statement and our DB objects to null, and we return the first item from our array. Now, note that whenever we select data based upon an ID, there's only one of two results. Either we're going to have an empty result set, or we're going to have a result set of just one item, because there cannot be two records in the same table that have the same ID. That is impossible. So if we've gotten past this check to see if data is empty, then we know that we have something to work with, and we return the first item in that array. So that is saved. Let's go to the browser, let's refresh, and we have an undefined variable query. Yes, we need to change query to statement. Let's go back, let's refresh, and there we go. Detail for CSS, we can see that that is cascading style sheets. And if we click on JS, we see the same thing. But let's do this. Let's go to admin, and let's create a new term for JS. And this will be JavaScript 2, I guess. And notice that we can have two terms that are the same, but have different definitions. And so if we look at this on the client side portion, we can click on either one of these and we get the detail for that specific record. So here's the detail for JS, that's JavaScript 2. If we click on this other one, that's for just JavaScript. So there we go. We have that method ready to go. We do, however, need to go back to admin. And let's see what happens if we click on edit. That, we need to address that, first of all, because we are trying to use this key, and we no longer have this key. So let's go to admin. We want to go to edit, and I guess we could still use key here. I mean, that would be the easiest thing to do, since otherwise we'd have to change it in multiple places. But we do need to go to index, and I should say index view for the admin. And we're going to change our key here from the term to the ID. We want to do these for any place that we've done that, really. And if we go back and refresh, of course, that's not going to work. Now, there we go. Okay, so we are seeing what we would expect. That's good. So as far as reading the data is concerned, we are good to go. Searching the database is just another query. We already know how to use the select statement. We also know how to select data based upon a condition using the where clause. So now we just need to use those again in order to find where our search term is inside of the term column or the definition column. And it's very, very simple. So we can start by taking our code from getTerm. Let's just copy the whole thing and let's paste that into search terms. Now, if our DB connection failed, we want to return an empty array because this is going to return an array. We can have no items, we can have one item, or we can have multiple. So we're going to return an empty array if the database connection failed. And then we are going to, once again, select all of the columns from terms where, but we aren't going to use the ID in this case. We're going to use where term is like our search term, or we also want to make sure that we search the definition as well. So, or definition is like the search term. And there's our query. We want to prepare that. And of course, we want to execute this, but we want to change search. And we don't want to do search here like this, because what this is going to do, well, if you use the like keyword, then you also want to use a wildcard. And there's several different wildcards, but the one that we would want to use is the %. And really, the % is what you would expect the asterisk to be. In that, if we did something like this, well, let me use the correct thing. If we did something like this, where we had the % and then style and then %, then the database is going to look for a term or a definition that has style somewhere in it. So it doesn't matter what comes before style or what comes after style. If it has style, it's going to be there. Now we can change this up in that if we just pre-pinned our search term with a %, then this indicates that we're searching for something in our columns that ends with style. There's nothing that comes after style. So currently, that's not going to match anything. And, similarly, we could remove the beginning % and just have an ending %. And in this case, it's going to try to find anything that starts with style, which once again, right now, there's nothing that does, because the only thing that has style is cascading style sheets. So what we want to do then is change the value that we use for our search parameter here so that we include those %. That way it's going to search the entire content of a column. And in this particular case, that's what we want. In most cases, as far as search is concerned, that's what we want. So we have our search term. We are still going to fetch all. We're going to map that to our glossary terms. We're still going to check to see if we have results. If not, we want to return an empty array. Otherwise, we set everything to null. Although, you know what? That should actually be up here. We don't want to return anything until we set those to null. But in this case, we want to return all of the results. And I guess really we don't even need to check to see if it's empty or not, because if it's empty, well, it's empty. Okay, so let's give this a whirl. Let's see, if we do a search for style, we should get just one item, CSS, cascading style sheets. If we do a search for C, we should get all 3 items. If we do a search for J, we should get all of the JavaScript. Same thing if we do just JS or JA. So our search now works, and it works beautifully. In fact, it works just like it did before, except that now it's probably a bit faster because as our data grows in the database, the more work the database server has to do to find that, but that's a whole lot more efficient than if we had a large JSON file and we had to try to find the appropriate term or definition there. So there we go. We have the ability to search our database so that now we just need to edit and delete our terms. In this lesson, we are going to do two things. We will update the data in our database table, and then we will delete a record. And these use the update and delete commands respectively, and they are very simple commands. And I like the update command because the syntax is a whole lot more logical than the insert command, and you will see that. But the first thing I want to do is modify the edit view and the delete view, because currently they are using the term in their hidden input fields. So let's open those up and let's change those hidden input fields. We want to use the ID value for those. So let's do the same thing inside of edit, and we will be good to go there. So now we can just focus on the database code. So let's open up our MySQL data provider. And of course, the very first thing that we need to do is create a connection and make sure that we have a connection to work with. If not, then we will just return. We don't need to return anything, just simply return. Now, I'm sure you have noticed there's a lot of repetition when it comes to working with databases, and we can alleviate some of that, which we will do at a later time. But for right now, let's go ahead and update our database. So our SQL statement looks like this: update terms, and this looks very much like how we would say it in English. Update terms, set term equal to the term parameter, comma definition equal to the definition parameter, where ID equals, and then the ID parameter. So we don't have to specify the columns and then the values for those columns. We have the equal operation here, which I really like because this is a whole lot easier to debug than an insert statement. So now that we have our SQL, let's create a prepared statement. So we will of course use the database objects prepare method. We'll pass in our SQL, and then we want to execute this statement. So we will call the execute method, and of course we need to specify our parameters. And let's do this. Let's go ahead and let's grab the call to execute from our insert, because we already have that stuff there. We do need to change the names of the term parameter to new term. But after that, definition is okay. We do need to add in the ID parameter, which is the original term. And there we go. After we execute, we want to set the statement object to null and the DB object to null. And with that in place, let's just go ahead and give this a try. So let's edit CSS. We'll just change the term. Let's also change the definition because we want to make sure that both of these work. So I'm going to remove the G. So this is Cascading style sheets. Let's edit, and our edit was successful, but let's change that back there. So our editing works. Now we just need to be able to delete, and we're going to delete this JavaScript 2. So let's go ahead and go to that page, and let's write the code for deleting, which is once again going to require us, in fact, let's just copy everything from the edit, and then we will make our necessary changes. So here, our SQL statement is delete from terms, and you definitely don't want to stop there because that will wipe out everything in the database. So we definitely want our where clause, but that's it. Delete from terms where ID is ID. That's it. It's pretty simple. So as far as our execution is concerned, we will get rid of the term and definition parameters. We will change the variable name that we use for the ID, and there we go. That's it. So let's delete this, and voila, we have deleted that term. So by now we have done basically all of the normal CRUD stuff. If you're new to that term, it's just CRUD for create, read, update, and delete. And 99% of the applications that we write are basically CRUD applications. Of course, our SQL statements can get more complex, but everything builds on these commands that we have been talking about over the past few lessons. Well, in the next lesson, we are going to work on our code so that we don't have as much repetition. In this lesson, we are going to try to clean up some of our database code because we have a lot of repetition. Every one of these methods, we have to create a connection. We have to check to see if that connection is there. We also have to dispose of any of the objects that we need to dispose of. So there's some of these things that we can kind of group together. Like, for example, when it comes time to getting the terms or getting an individual term or searching for the terms, those are all closely related because we are querying data as opposed to adding a term or updating or deleting. Those aren't querying at all. Those are just executing commands and then, just executing them. So we can essentially break this down into two methods, one for querying data, one for executing data. Although as I'm saying this, get term is a little bit unique because we are essentially just focused on one item. So we might just leave this alone because, otherwise we would have to just create another method for retrieving a single item. And, we already have that. So let's start with our get terms. Now, when it comes to writing software, the very first lines of code that I write aren't going to work because I like to think about what code I want to write. So when it comes to getting the terms, I would love to just have a method called query, pass in the SQL statement, and that would give us, our results. So that this method is essentially just this. One line of code. That's beautiful. So let's implement that. And I tend to put all of my private methods at the bottom of the class. Some people do it based upon alphabetical order. Other people like to put the private stuff at the top and public stuff at the bottom. Doesn't matter. Just be consistent with whatever floats your boat. So in this case, this is a method called query. We are accepting the SQL statement. We are doing, everything else. The only thing that we need to change here is the query method on our database object. We need to pass in the SQL statement that was provided to our own query method. But other than that, we're good to go here. So great. We're going to skip the get term because we aren't really going to gain anything from trying to simplify that. But our search terms, since we have that query method, we could essentially do the same type of thing here to where we would call query, we would pass in our SQL statement. So let's go ahead and let's grab that. But we have more than just the SQL statement. We also have the parameter array so that we can specify what we want to search with. And that would be really cool to pass as a second argument to query. So let's do that. I like that so that the code is essentially just that. That's a lot cleaner. But that also means that we need to modify our own query method because now we may have an array or we may not have an array. So let's go ahead and let's take that into account. So we will have our param array. Now let's call it SQL params, and we will default this to an array so that here we still need the query, but we're going to have to do something a little different. So let's do this. We're going to check to see if the SQL params is empty. If it is, then we have just a normal query. We don't need to do anything special. So that's where we would use the database objects query method just like that. However, if we do have an array of stuff, then we want to prepare the statement. So we would need to do this to where we call prepare, and then we would need to execute that so that we could pass in the parameters. So we would call execute, pass in SQL params, and that's it. So that then we can actually perform the fetch. So let's do this. We'll start with query equals null, and then query will change based upon the result of SQL params. So that should work, and we could very easily test that. Let's go to the browser, and we are reading the database just fine. Let's do a search. If we look for something with CRI in the name, we have JavaScript. So that works just fine. We didn't break anything, and that's important. Let's make sure this is 6.8. Okay, so we are running the same, or at least the correct code. So we have just made our calls for get terms and search terms a lot cleaner. Now we can essentially do the same thing for the code that we need to just execute. So let's write another private method. We'll call this execute. We will need the SQL statement. We will also need the SQL params because all of these have some kind of parameters that we need. And let's just take the code for delete, because really it's the same pattern over and over again. The only things that change are the SQL statement and the SQL parameters that we specify. Everything else is just fine. So we will need to make the necessary changes here. But other than that, that's it. I mean, it's that same pattern. So that now for delete, we can do this. We will call that execute method. We will pass in the SQL statement for deleting. Let's put that on its own line. And then we will have the SQL parameters so that we will have ID, and that value will come from term. And there we go. That's it. We don't need to return anything. We will just execute our SQL statement, and that's it. So we can take this, and we will paste that inside of update term, and then just make the necessary changes. We, of course, have this longer SQL statement, so let's grab that, and let's paste that on up here. And then our array for the SQL parameters, we'll just grab that as well and paste that, and there we go. We're done. Well, we need to get rid of the old code, but now we're done. And then repetition, we'll do the same thing for the add term method. Now the SQL statement here, it's even longer. So, well, it might not be that much longer, but anyway, we're going to paste that on up there. We need our array of parameters, and there we go, just like that. And we're done. There we have cleaned up our code. We still have some repetition because you can't get away from repetition as far as calling the same method, passing in just different information. There's nothing that we can do about that. However, this is a lot cleaner. And if we're going to start by reading this code, then it's a lot clearer as to what's going on. And you might think that, well, we haven't really gained anything. And, you know, that's debatable. But something that we could do is create another class, one that's just a SQL data provider, something that's very generic, but it would have some of these methods already defined so that the code for interacting with the database would already be there, and we wouldn't have to even worry about it. We would just have to execute that code. That requires a little bit of extra thought, because as you start to build classes that build upon classes that build upon classes, things can get either a lot better or it can get a whole lot worse. But in this case, we're fine. Our code is cleaner. I'm happy about that. But most of all, it works. Or does it? We didn't test it. So let's go to admin and let's make sure that it does. We want to edit, so let's make a few changes here. This will be cascade and style sheets. That works just fine. if we create something extensible, we don't care. We just want to see if this works and if we can delete it, and that works. So the code still works. Our code is a little bit easier to read. I'm happy. PHP 8 brings in a lot of new features, and one of them is called named arguments. Now, I'm going to nitpick on some terminology here because a lot of times we use the terms parameter and argument interchangeably. And a lot of times that's perfectly fine, especially if it's in conversational contexts and everybody knows what we're talking about. However, in this particular discussion, there is a distinction between parameters and arguments. So if we look at the view function, we have defined that function with two parameters. So when you are defining a function, the things in between the parentheses are called parameters. When you use a function by calling it and you're passing data to it, then you are passing arguments to that function. So parameters are for when you define the function, arguments are for when you use the function. And the reason why this is important is because the name of this feature is named arguments. So that implies that we can use this feature whenever we are calling the function. And the syntax for this is very simple. We use the name of the parameter. In this case, it's going to be name, followed by a colon, and then the value associated with that parameter, so that our argument here is a named argument. We have the name of the parameter and the value associated with it. And then we can do the same thing for the model here. So we have model followed by a colon, and then whatever value we want to specify for the model. And there we go. Let's go to the browser, let's refresh the page here, and we can see that everything works just fine. So the question probably burning in your mind is, why? Because this adds just extra keystrokes. It takes time away from doing something else. Why would I use this? And I fully understand that, because the first time I saw named arguments, not necessarily in PHP, but in other languages, I thought the same thing. Well, there's quite a few advantages to using named arguments. For one, it adds clarity to your code. Now, in our case, the view function is not complex at all. We have two parameters. We're not going to get those mixed up. However, imagine a function that has 4, 5, 6, maybe 7 or 8 parameters, and you need to pass arguments to all of them. Well, to keep track of all of that information, it makes a lot of sense to use a named argument in that case. So for one, it adds clarity. And there's also times when that could be used as far as documentation is concerned as well. So while it might not necessarily add any more clarity to our call to the view function here, it does add documentation that the name is index, the model are the items. So there's a benefit there. It also gives you the flexibility of not being bound to positional arguments anymore, because once you start using named arguments, the position of those arguments doesn't matter because everything's associated by the name and its value. So if you wanted to, we could switch this up so that we specify the model first, followed by the name. And if we go to the browser, refresh the page, everything works just fine there as well. Another advantage is that if there are any arguments with default values, you can skip over them. Like for example, let's go to our view function. Let's add in another parameter. Let's call this should work. And we're going to initialize this with the value of true, just so that we don't break anything. So that if should work is true, then we want to pull in the layout. And I guess what we actually should do is call this use layout. So we have this addition here so that we have 3 parameters. The first one is required. That is, of course, the name of the view that we need. But the model and then whether or not to use the layout, those are optional. Now, if we needed to use the name and then the use layout using positional arguments, we would have to specify all of those values. So we would have to have index followed by some value for the model, which an empty string would be fine. And then we would want to pass in a value for using the layout. Well, because the model is optional, we can now skip that by using named arguments. So we could simply have the name and its value, followed by use layout and its value. We don't have to worry about specifying anything for the model if we're going to use its default value. So if we go back to the browser and refresh the page, we don't get an error, which is fine. We don't really expect one in this case, but we can see that we are no longer using the layout there. So it adds clarity, it adds flexibility so that you don't have to worry about the position of those arguments, and it also allows you to skip other optional parameters if you so desire. Now there is a caveat. Let's back out all of these changes to the view function, and that is this. Whenever you opt in to using named arguments, you have to use named arguments after it. Now, what do I mean by that? So we are using the named argument for our name, but we aren't specifying anything for items. So if we go to the browser and refresh the page, we see that there's an error that we cannot use positional arguments after a named argument. So once you use a named argument, you are opting into that feature. So anything that comes after that positionally has to use a named argument as well. So since we are passing a value for the model, we have to specify the model with a named argument. If we weren't passing a model, then that's not that big of a deal. All we have to do is specify name and then we're good to go. But in this case, we're not. So once you use a named argument, you're opting into the feature, and any argument that comes after that named argument has to also be specified with a name, unless if you want to skip it because it is an optional parameter. So there we go. That is essentially named arguments. It's a very simple concept in addition to the language, but it's also powerful and has a variety of uses. If you do any object-oriented programming, not just in PHP, but in just about every other language, you're going to see a very common pattern, and that is initializing properties in the constructor. Like, for example, our data provider class, we have a constructor that accepts the source. And we take that value that was passed to the constructor, and we save that to a property called source. Very common. And in fact, we do the same thing inside of glossary term. Our constructor accepts the term and the definition. What do? Inside, we turn around and store those values in properties of the same name. This goes throughout all of object-oriented programming across all languages. Now, some languages have a feature that PHP is now calling constructor property promotion, which basically takes all of this boilerplate code and gets rid of it so that we can essentially define these properties and assign them values by just defining the parameters. So this is how we use this feature. We're going to get rid of where we store the value inside of our source property, because we don't need that now. And all we have to do is prefix our parameter with public, protected, or with private, all depending upon how we want to access that information. I'm going to make this public. So just by saying public source, behind the scenes, PHP is going to create a source property, and it's going to assign it the value of whatever we pass here. So if we save this, we go to the browser, we refresh, voila, everything works. And we can prove that this works by changing the name of the parameter so that if it is something other than source, then we see that the code breaks because it was expecting source and it didn't get source. So this allows us to simplify a lot of our classes, such as the glossary term, because this was created for just the purpose of representing a glossary term within our application. There's no other purpose for this class. So we can simplify this by getting rid of the definitions of those properties and just using public term and public definition. Now, there are a few things to note about this feature. For one, you can assign default values. So if you wanted a default value for source, all you have to do is specify this as a default parameter so that source would have its value. Now, we can only use simple values like a string or numeric value. We can't new up another object or anything like that. So if you're going to use a default parameter that is going to be promoted as a property, then it has to be a simple value. Now, there cannot be any duplicates. So by using the property promotion syntax here, we cannot define another property called source outside of the constructor. That's just not going to work. We would get an error if we do so. So in fact, let's go to the browser, let's refresh. Cannot redeclare source. So we can only have one property declaration, because that is essentially what we are doing with this property promotion syntax. Now, inside of the constructor, we can use our source in two ways. We can use it as just a normal parameter, or if we wanted to use the instance syntax, we could do that as well. Either way, it's going to work. They both reference the same thing, and personally, I tend to go with the parameter name itself. That's just a little easier to type. And that is basically that. It's a very simple and straightforward feature, but it saves a lot of time. Because as I said, this is a very common pattern, and this gives us the syntactic sugar to give us the same functionality with less code. PHP is my second language, JavaScript is my first, and I started learning these two languages in the late 1990s. And one of the things that just really bugged me about them is that when it came to strings, there was just really no good way of determining whether or not a string contains another string. Now, yes, there were functions or methods that you could call that would kind of give you that information, but it wasn't just a straight up true or false. You had to take the return value, you had to decipher from there, and it was just stupid, really. And PHP's approach was even dumber because, well, the string position function returns two types of values. If the needle is not in the haystack, which is the terminology that the PHP documentation uses, then it returns false. Okay, that's great. Perfect. But if it does, then it returns a non-negative integer value. So you get two different types of values, and you just, you learn to work around it, you spend time with it, and every time you type the code, you think how stupid it is, and then you just get bitter, and then you move on to a different language. But now, finally, in PHP 8, well over 20 years later, we have string contains. It simply returns a true or false value, whether or not if the needle is inside of the haystack, and voila, there you go. I don't know what took them so long to add this to the language, but it's stupid regardless. Anyway, we can change our file data provider class so that instead of using string position, we can now use this string contains, and we have just simplified our code, which is perfectly fine in my opinion. But now let's make sure that this works. You can see that I've already done a few tests here. So we can search for CSS, we can search for JS, we can search for anything else, and we are going to find a match as long as it is contained within our data store. So we are good to go there. Now, I would be remiss if I didn't include the other two new string-oriented functions, which, once again, should have been here to begin with. The first is string starts with. It simply checks to see if the haystack begins with the needle. And of course, it returns just a simple Boolean value. True if it does, false if not. And if you have a starts with function, you better have an ends with. And so once again, if the haystack ends with the needle, then the function returns true. Otherwise, it's false. Now, of course, we don't have any place where we really used that functionality, so I'm just going to comment that out so that it's inside of the code, along with the string contains. But finally, in PHP 8, well over 20 years, really, I think almost 25 since the beginning of PHP, we have the ability to just simply check if a string contains another string. PHP is the most popular server-side programming language, and rightfully so. It's so much easier to learn and grasp than many other languages, and with tools like MAMP, it's incredibly easy to get started with. Now, I want to give you a few pointers before I leave you. At this point, you're just starting down the path of a PHP developer, and PHP has a huge community. So when you hit a roadblock and you don't know how to handle something, ask the community. We've all been in your shoes, and you have the benefit of having us as a resource. So ask questions, even hit up Stack Overflow, and you will get some help. Also, don't discount the PHP website. Everything is documented, and so many people in the community have commented and continued to comment on the documentation. Thank you so much for watching this course. As always, feel free to contact me on Twitter or the Tuts Plus forums if you have any questions. From all of us here at Tuts Plus, thank you, and I will see you next time.